Google I/O is just around the corner.
And we're really excited to show you what we've been cooking up.
For the first time, in addition to our live streams, we are rolling out over 100 I/O Bytes.
Short videos to help developers like you dive in.
And experience I/O anytime, anywhere.
We're delivering more content.
And making it easier than ever to design,
Develop.
And distribute.
And making it even more accessible.
And it's all for you.
It's just for you. It's all just for you.
So let's say that you've got some awesome Android game with hundreds of thousands of downloads, but it seems like you can't break that million user mark. The reason? Users are unhappy with your game's performance. You see, users notice bad performance before any other feature in your game, before your item stats or your UI interfaces, or how in level 3 one of your characters is actually speaking Klingon. And guess what? Users unhappy with performance give bad reviews at a higher percentage than any other problem in your game. So you want to break the million user mark? You're going to have to fix the perf problems in your game. And for modern Android games, that starts with understanding that there exists a delicate dance, a tango, if you will, of interaction between the CPU and GPU in your game that can have a drastic impact on your performance. And the dance works a little something like this. Modern graphics APIs don't allow the CPU to talk directly to the GPU hardware. Instead, it uses an intermediate process known as a graphics driver to handle communication between the two. Drawing calls from the CPU are cached by the driver in a message queue, and when the GPU hardware is ready for work, it will start consuming commands from the same resource and begin executing on them. The existence of the message queue process in the driver means the CPU can be pushing messages into the driver at a different rate than the GPU is reading from it. And as such, your GPU can be consuming, processing, and drawing data that's around 1 to 2 frames behind the CPU. Now, while alarming, don't worry, this is actually really typical of modern hardware architectures. But with this in mind, understand that hitting 60 frames a second in your game requires both your CPU frame and your GPU frame to both complete their work in around 16 milliseconds. When either of these two systems starts to go out of sync and take longer than that, bad things happen to your frame rate. For example, what if your GPU has more work to do than your CPU? This means that your CPU is going to be submitting frames into the driver at a faster frequency than the GPU is actually going to be consuming them. Eventually, the driver queue is going to get filled, and anytime the CPU wants to submit a driver call, it'll have to block, wait for the GPU to clear up some commands in order to free up space, at which point the CPU can then carry on and submit its new commands. On the other hand, if you're CPU bound, then you're inserting bubbles into your GPU pipeline. Every time the CPU submits a frame, the GPU will consume it immediately, process it, and sit around waiting for the next frame where it can do work again. The straightforward way to fix this is to simply do less work on the CPU. But in this case, it may be that the GPU simply doesn't have enough work to do, and the correct action is actually to give it more work in order to fully maximize the GPU throughput. There's a great opportunity to put like 200 extra zombies on the screen for your designers. You can get a general estimate of where the problem lies by taking a good look at your CPU frame time for a couple seconds of simulation. For example, if your CPU frame time is around 16 milliseconds, then your game is running pretty well. Now, while your goal is to keep things under the 16 millisecond mark, some frames your CPU load changes and you expect slight variances in the time. If, however, your frame time starts to spike suddenly and your CPU computation load hasn't changed, you haven't put 200 zombies on the screen, then there's a high probability that this is due to the GPU getting backed up, forcing your CPU time to stall in the driver. These tall spikes are actually pretty telling, since they're around 11 to 15 milliseconds in time, which would be exactly how long the GPU would need to flush a frame or so. In order to figure out what the culprit really is, it's time to sit down and get proficient with mobile profiling tools. Some of the nuances of the GPU performance require dedicated tools to discover, but thankfully, each Android chip manufacturer provides a great suite of tools to give you more information on how to optimize your game for their hardware. Understanding and optimizing the dance between the CPU and GPU is the first step in maximizing your game's performance, which of course results in happier users, which could result in better transactions, and that's the whole point, right? So keep calm, profile your code, and as always remember, perf matters.
You started an online store and the customers are rolling in. Your website is functional art, your ad campaign's gone viral, and the shopping carts are filling up. Your products have universal appeal. And you notice, hey, I'm huge in Japan. You're getting lots of international traffic, but it's not converting into sales. Why is that? After examining your analytics data, you see a lot of items getting abandoned during checkout. Do your international users just have a shorter attention span? Or is there something suboptimal about the user experience that is frustrating their urge to consume? We're going to address these questions and elucidate some of the famous question marks that beget profit. Have you ever seen an address in Japan? Let's start with something easy for me as an American. Here's where I work in Los Angeles. But here's where Googlers work in Japan. Let's remove the language barrier for a second. As you might notice, we're not in Kansas anymore. The order of this address is almost completely reversed from Western conventions. But you're smart. You can handle this. You whip out some JavaScript and manipulate that DOM. After a careful reading of Wikipedia, you are pretty confident. You can deal with users coming from Japan, shuffle your address around to make sure they feel right at home. Remove any impediments that might prevent them from obtaining the latest in wearable tech for their pets. But wait a second, every country does things a little differently. How many countries are there in the world? I don't know, a bunch. You're going to be up pretty late tonight, scouring the web for this sort of information for every country that likes cats. That's problem one. Now, here's problem two. Here's that address again, but this time it contains a typo. Can you spot it? I can't either. But users love typos, almost more than their cats. So you better figure out how to verify the address as it's being entered. Yo. Okay, I will end this rant. I hope you're convinced. Addresses are hard, and you just want to go shopping. But it's okay. Chrome's Request Autocomplete gives you all this and more for free. Request Autocomplete is a brand spanking new member of the HTML standard. And today, you can find it on Chrome for desktop, Chrome OS, Android, and iOS. And it's super easy to integrate into your site, which is nice. Request Autocomplete remembers your address, so in practice, most of the time you won't need to enter a new one, but when you do, here's what it looks like on your phone. It's native UI. So this is straightforward to use as an American. You can put in your name, my city, all that stuff. That's well and good, but here's the hard part, Russia. As you might have expected, the address fields look quite different from the United States. For example, you see the postal code and the city fields on top of the street address and the name fields. What about validation, you ask? No problem. Request Autocomplete can do that as well. Fantastic. Best of all, next time my address is ready and waiting for me. So, Chrome handles address input, data validation, and more while you focus on your product. Want to add Request Autocomplete to your site? Check it out here, or point your browser here. Easier internationalization is just one reason why Request Autocomplete rocks. The team is working hard to improve the checkout process for your users. Our goal is to help you maximize conversions and optimize the payments experience for the web, especially the mobile web, because let's face it, this resource is occupied. Until next time, I'm Ruslan Salamakin, and I'm huge in Japan.
Hi, I'm Alex Danilo from the Google Developer Relations team. One of the things I found really hard as a web developer is making compelling animations on a site. It seems easy enough at first to throw some CSS animations onto a site and watch the browser fly stuff around you and you feel all chuffed when you first see it. But if you're like me, you want to make your site really stand out, be memorable, not just another pre-canned clone of something people have already seen. So I started experimenting with different web animation techniques and right away hit problems with doing fancy things. Like for example, I wanted to make two things animate in perfect sync, but couldn't find a way to do it really easily. My solution took 1,000 lines of code and was extremely choppy and riddled with jank. If only there was a better way. Now this is the kind of thing I wanted to build, a 3D hardware accelerated view of the world with silky smooth, jank-free animation and total control. Well, now there is a better way. A bunch of browser writers and animation experts got together a couple of years ago to look at this with a fresh set of eyes. Lots of eyes, in fact. We spent a lot of time discussing what web developers need, how animation designers work, and a whole lot more. What we came up with is Web Animations 1.0. We aim to take all the existing web animation primitives out there and unify them, and also bring new capabilities that weren't just more powerful, but would run faster and smoother as a result. Now, one of the best APIs to play with animation from JavaScript is, of course, Request Animation Frame, especially if you want fine-grained control of everything that's happening on a frame-by-frame basis. So let's take a quick look at how animation works when you use Request Animation Frame. Now, using Request Animation Frame gives great control, but forces JavaScript execution on every frame. Now, this is fine if you're not doing much in your JavaScript, but we only have 16 milliseconds for each frame, and that includes paint and layout time too. So if you run out of time, you know what happens? Skipped frames, resulting in jank, which some people call jitter. Now, this is the main reason it's a good idea to decouple the animations from JavaScript execution itself. So we wanted the flexibility of control from JavaScript, but not the jank, and so this is what we designed. The Web Animations API lets you create animations from JavaScript, then offload the animation calculations to the browser so it can take care of all the heavy lifting for you. And in many cases, it can take advantage of hardware acceleration, so there's very little work to do for each frame. Now, what this means, it enables proper hardware-accelerated animations to happen via the use of a JavaScript API, but without the slowdown from recalculating lots of stuff each frame. This is something we didn't have before, which is pretty cool, huh? I know what you're thinking. Yeah, but we already have CSS animations that are hardware-accelerated. Right, well that's true, and by unifying everything, we extend the reach of hardware acceleration. The Web Animations design brings together CSS animations, transitions, SVG animation, and JavaScript created animations all into one thing. In fact, the Web Animations engine is currently used to run both CSS animations and transitions in Chrome. You probably didn't even notice when that happened, and that's testament to how seamlessly the Web Animations engine integrates into browsers. Now, even better is that in addition to powering CSS animations, you can call element.animate, which creates an animation player object that's used to interface to the animation internals inside the browser. Now, the object return lets you query and modify the running animation, so you get decoupled running of animation in the browser, but retain the ability to modify running animation from JavaScript, kind of the best of both worlds. Now remember this, the cool 3D globes actually built using Web Animations. Bet you didn't guess that. And it's just the tip of the iceberg. Here's another demo which shows how you can manipulate a running animation using input like touch. Now, you can't build something like this using CSS animation, since there's no way to dynamically manipulate a running animation once it's started. But with Web Animations, you can. And here's another which shows true synchronization, something almost everyone I've talked to is excited about. Web Animations are so cool, and you can use them right now. Not only does Chrome have native support for Web Animations, but we launched an open source implementation in JavaScript, which lets you use the API in any modern browser. That polyfill lets you use Web Animations right away, and we're doing all of this work in public at the W3C to make sure all browser vendors are on board. So take a look at the polyfill, the demos, hack through the code, make your site shine with the most powerful animation primitives available to web developers today. I know you'll blow people's socks off. I'm Alex Danilo. I'm excited to see what kinds of things you'll build using Web Animations.
Google and Udacity have teamed up to bring you a series of cutting-edge technology courses. Today, we're announcing 4 new courses developed with Google. In Android, Cloud, Web Performance, and UX Design. For more information, visit udacity.com/Google.
Hi, my name is Pong Ying, and I work on the Google Wallet team. I'm here to talk about the Wallet Objects API for native Android. I used to have a keychain full of these, different loyalty cards to take advantage of discounts and rewards. And these, I usually just end up leaving at home, unfortunately. I could have saved so much money. I don't think anyone but the most dedicated savers carry around all of their loyalty cards and offers all the time. To make it easier for everyone to carry around everything, Google provides the Wallet Objects platform. Wallet Objects is the concept of digitizing and storing all of your items in your wallet in the cloud and making them accessible from anywhere. And combined with a mobile app that has contextual information, we can make these items smart, so they appear when you need them. For example, I have a test object with a geofence of this building. Whenever I enter the geofence, my wallet object appears in Now, and it can notify me that it's available to use through an Android system-level notification. And we fine-tuned the contextual triggers so that these notifications won't trigger when, say, I'm just driving by the office. This functionality allows developers to do interesting things. Let's say you have an existing mobile user base, and you want to convert users from mobile to another physical medium. One example, it's a mobile game, and you want to convert the user to a console. In the game, you could add a geolocated wallet objects offer for a console title to incentivize user action. With the offer saved, the next time the user goes to a geolocation you specified, whether it's Fry's, GameStop, or Best Buy, or some other retailer, Wallet will notify the user that the offer is available to use. They buy the title, and boom! Now they're playing your game in the living room in addition to on mobile. Wallet objects can help with retail as well. Instead of all the coupons and offers that you need to remember to bring when you go shopping, you should just be able to save those offers from an app or from the web and have them notify you when they're relevant. Let's say I walk past a store in the mall and my phone notifies me that I have a coupon to save $20 off a purchase. I'm going to try to take advantage of that savings and check out if there's anything in the store that interests me. Cool. So you want to integrate, right? Let's go over how to create and save an object. The wallet objects flow is simple. You define the data representing the object and add a Save to Google button that calls our function createWalletObject with the object to save. The rendering is based on a template that gets populated by the information you define. To reduce redundancy, WalletObject stores data in two forms. It's somewhat analogous to programming. The class data represents information that's common to all users, like merchant details. The object data represents information that's specific to a single user, like a specific discount or a barcode. All this information is merged, then filled into the template. We have a number of fields here, and in this template, and any section without data is going to be hidden. Let's check out the code. First, we need to create the class. This code defines an offer class. We set the merchant and some offer details, some images, some subsections, and lat-long geolocations. Finally, we insert the class. Inserting the class needs to use a server-side REST API. Once you've created and inserted the class, you can create the object data in your Android app. This may look like a big wall of code, but it's your standard builder pattern defining an object. Here, I'm referencing a class I just created. I'm overriding some class fields and defining information that's specific to the user, such as barcode and messages. Once I have that, we can tie the object to a createWalletObjects call and tie that to an image button click, and we're done. So if you want to remind and incentivize actions for your users, integrate the WalletObjects API into your app today. For more information on the integration and a step-by-step tutorial, check out our developer documentation. I can't wait to see what you build. I'm Pong Ying, and thanks for watching.
Hey guys, I'm Eric Beitelman. I'm a staff developer relations engineer working on Polymer at Google. So in this video, I'm going to talk to you about how you can use Polymer and web components to interact with some of Google's most popular APIs and services just by writing a little bit of HTML. You know, the other day I was thinking, how many APIs does Google have? Do you know? I actually didn't. I had to do my research on this one. So it's over 250 APIs, things like Google Maps and Google Drive, spreadsheets, calendar, analytics, you name it, Google's probably got it. And of course, we all know that creating complex web applications requires you to interact with APIs and services. So on the Polymer team, we've been thinking about this a little bit. How do you combine Google's awesomeness with the world of web components? We really want to make working with web components as easy as writing a little bit of HTML. That's really the power of web components. And it turns out they're a great delivery vehicle for wrapping existing content, libraries, and services. Think of it as a way to declaratively provide a declarative surface area for the API that exists. This is really where Polymer comes in. For those that don't know, Polymer is a bleeding-edge technology. It's a library built for the web and allows you to create web applications based on web components. But to me, what Polymer really does is provide a thin layer, of opinionated layer on top of the web component APIs. So we built in things like data binding, property observation, gesture support, mobile support. These are really important when you're building applications. We want to make it easier for you to ramp up and use. So we built that into Polymer itself. You know, a popular API is something like Google Maps. It's very complex, it's very rich. So let's take a look at how web components can actually make your life easier using that API. This is Google Maps Hello World, right? It's pretty simple, but there's a little bit of boilerplate code that you have to write every time you want to render just a map to your page. You have to know to style it using a little bit of CSS. You have to know that there's a container div that you need to create. You have to load the library. You have to remember that. You have to work with loading and callbacks and write a little bit of JavaScript. Point is, there's a lot of process you have to go through to get this thing kicking. So let's see what we can do with web components. In the world of web components, this is the Google Maps API. It's a single tag you declare on your page. That's ridiculous. Ridiculously awesome. You declare it and you're off to the races, and it does exactly what you expect, which is render a map to your page. It's simple, it's declarative, it's intuitive. I don't have to write JavaScript code. I don't have to know about callbacks. I don't have to read API documentation. You get my point. You just use this thing and it works. But Google Maps, right, is an extremely complex API. So instead of writing JavaScript, what we can do in the world of web components is expose attributes on this element for people to configure the different properties and methods that the API exposes. So for instance, really common thing to do, latitude and longitude set the center of the map. We can do that now using that latitude and longitude attributes. We can also set the zoom level of this map just by setting the zoom attribute to 15. That's really awesome. Again, it's all declarative and super intuitive. You can read this code and know what's going on. And adding markers is just as easy. It's just as declarative. So we can drop in a bunch of Google Map marker elements inside of the Google Map tag itself and compose these in different ways. The fact that the marker tag is in the map is significant. It knows to render that marker to the page. I'm also reusing other parts of the platform here. So you notice I didn't reinvent the wheel for the title attribute, or I didn't reinvent the wheel for the drag and drop API. I'm using the draggable true attribute. So again, I can reuse parts of the web platform that already exist. I don't have to reinvent that wheel every time I start a new project. That's cool. The other thing I really love about this element is that it makes some of the API complexity go away. So one thing that's really common to do in the world of maps is center your map inside of the viewport of all the markers that contain inside of it, right? Make sure they're available to the users at all times. That's a little bit of boilerplate code, a little bit of JavaScript that you have to know how to write every time you want to do that. You add a new marker, you want to update the map. Instead, what we can do in the world of web components is, again, expose another attribute, this fit to markers attribute. So as long as I have that on my marker tag, my map tag, boom, the map just updates itself. It knows to set the zoom property accordingly. That's Google Maps. It's super declarative, super easy to use. But you can imagine a ton of other use cases here for all the APIs Google has, whether it's working with charts or spreadsheets, analytics. Anything can be a web component. We can provide a declarative surface for people to tap into that. And that's exactly what we've done. So we've been experimenting with this over on GitHub. If you want to check it out, Google Web Components is the GitHub organization. We have a growing collection of awesome components there. Things for analytics and maps, you saw, Google Spreadsheets. We also have base components for doing more low-level things, working with the libraries that Google has, doing OAuth 2. God knows that is very complex. So just like Maps, these are super declarative, super easy to use. Check them out. If anything is missing, let us know. We're really interested in getting your feedback, getting pull requests, and adding new APIs and services all the time. So actually, let's use this. Let's combine proof in the pudding, create an application that uses Google Maps and Google Spreadsheets. We'll create a Polymer element that wraps all that together, and users can use that element inside of their own applications. Oh yeah, I almost forgot. We're not going to write any JavaScript to do this. We're just going to write a little bit of HTML. So if you're curious, this data is going to be coming from a Google spreadsheet. This is what the data actually looks like. Essentially, it's just a list of businesses in Portland, Oregon, right? There's a little bit of metadata, but the most important thing here is that we have the latitude and longitude columns. This is the data that's going to render those marker objects. So the first thing we do, we got to bring this stuff locally into our app. We're going to use Bower to install it. We're going to Bower install the Google Map tag, and then you see the example here, which we've already seen, so let's move on. What you haven't seen is the Google Sheets tag. This is an element for working with Google Spreadsheets. We're also going to Bower install that, bring it in locally to our application. And the second example here is how you actually use this element. So again, it's super declarative. I declare Google Sheets, and boom, I'm off to the races. It's got a publish property, which essentially means, hey, this data is being published publicly. Don't worry about doing authentication, it's just there. GID corresponds to the tab in the spreadsheet that I want to interact with. So GID 0, first tab. And the last thing we're doing is providing a spreadsheet key. And you see the example here where you actually get the key is in the URL bar when viewing this spreadsheet in Google Docs. So it's super easy to use. And the last step, if you're outside of Polymer, you just have to write a little bit of JavaScript to maybe listen for the event that this element fires and then react accordingly. So in this case, we can print out the data that the spreadsheet returned. But it's really that easy. Declare, go. So now that we have those dependencies installed, right, Google Maps and Sheets, let's actually use them. Let's create a Polymer element that wraps that functionality together. This is the entirety of the application. Let's walk through these pieces. So the first thing, now that we have the dependencies installed, you want to list them at the top of your file. So this is using HTML imports, which is one of the web component APIs. We're going to list Polymer as a dependency, the Google Sheets as a dependency, and Google Maps as a dependency, now that they're in our application. The second thing we're going to do is create a Polymer element. So this is using Polymer's declarative sugaring to do this. The name of the tag we're going to create is map-sheets. This is what somebody's actually going to declare on their page when they use our stuff. The second thing you see here is this no-script attribute. That's essentially just a hint to Polymer to say, hey, I'm not going to add any properties, any methods to this. It's just going to be a little bit of markup that we're essentially repackaging for users. So it's a pretty simple element. Inside the elements template, you're going to drop in that Google Sheets component. This is what's going to talk to our spreadsheet. You can see I got the key there. I got that publish attribute, and we're data binding to the rows attribute that this thing has on it. More on that in just a second. Right below it, we have the Google Map Sheet. This is your friendly tag that we already know about. Notice that we're using that fit to markers attribute that we talked about before. So again, anytime I have extra markers being rendered in this map, it's just going to know to set the zoom level to the appropriate level. Lastly, what we're doing is we're using Polymer's declarative data binding features to declaratively loop over the row data returned in the spreadsheet. So again, I'm not writing any JavaScript code to wire this stuff up. I'm literally just declaring a template, looping over the data, and stamping out Google Map marker children. And of course, we're data binding that latitude and longitude property to the particular cell that we're interested in. So again, it's all super declarative, and the surface area is just using HTML attributes. So that's the entirety of the application. If somebody wants to use this, it's just a matter of bringing in platform.js, right? These are the polyfills that actually allow you to use this stuff in browsers that don't support the native APIs. Check. You want to declare the Google Maps sheet as an HTML import. That's going to bring in the element we just created. Check. The last thing you want to do is just declare the Map Sheets tag on your page. And of course, what people get is this beautiful map, marker data, all powered by Google Spreadsheets. We didn't write any code to do it. We used Polymer web components. That's the bee's knees. So if you want to see a live demo of this, go check it out. It's at googlewebcomponents.github.io. We have this demo as well as a ton of other demos for all the other components we've created. So that's a small taste, just a small taste of what Polymer and web components can do. I really think web components are going to unlock a fundamentally new way to program for the web. You've already seen it's productive, it's declarative, it's reusable, and you can vastly reduce the amount of code you write as a front-end developer. That's really, really awesome. So if you want to know more about creating applications using Polymer, do check out Rob Dotson's video and Eddie Osmani's video. These are a couple of stellar guys with some really, really great content. Check us out on polymer-project.org. This is our website, powered by Polymer, of course. And follow us on Twitter at Polymer. You can also feel free to hit me up anytime, ask questions. I'm always on Twitter. I'm on Google+. Oh yeah, one last thing. Go componentize the web, guys. Thanks for watching.
Hi, I'm Jarek Wilkiewicz, and I'm a developer advocate. I was born in Poland, and like many other engineers, I grew up reading science fiction. In fact, this is my favorite author. My childhood home was actually very close to his house in Kraków, and little did I know that his work would have major influence on my life. Did you read science fiction too? Do you remember the moment when the protagonist, while busy saving the world, asks her computer for something? Computer, make it so! And the machine just does it, and it nails it. Now, why can't the real world be more like this? For example, when a user says, "OK Google," and asks for something, the application or service most suitable to fulfill the request should be invoked and get the job done just like that. Today I want to talk to you about technology based on schema.org actions, which I think is a small step in that direction. With actions, we have an opportunity to delight your users and bring more engagement to your app. However, we can't do it alone. We need your help. At Google, we have been working on organizing the world's information to make it universally accessible and useful.
To help with that, we've built the knowledge graph. The knowledge graph contains information about entities and their relationships. One of the interesting applications of the knowledge graph is resolving ambiguities when processing language queries. For example, the artist dual core is a band, which is different than the concept of dual core. As far as the strings are concerned, these two are equal, but to a user who is asking their phone to play dual core, the difference is quite clear. Dual core the band is assigned a machine ID in the graph. We like to refer to these types of object-based identifiers as things, not strings. Having a graph entity with a machine ID, OMID, makes a big difference. The knowledge graph can also help satisfy user requests with your application. I thought a good way to show you how this works is to actually build a small knowledge graph together with you. But first, let me introduce you to my buddy, Sean. This is Sean. We both like music. Sean likes to DJ and spin dance LPs in his free time. One day, we would love to open a record store. We would curate an awesome selection of LPs, and on weekends, we would invite our favorite artists to give concerts at our store. Now, wouldn't that be great? Our music selection would, of course, be available for purchases online. We would offer web and mobile streaming access as well. Since today, most music recommendations are provided by computers, we would want to make it easy for computers to discover and understand what we have to offer. For example, when the user says, "OK, Google, play dual core," we would like our app to be ready to fulfill users' request. All right, so we have this music store. We are selling LPs, offering streaming access, and hosting events on weekends. How do we express this information in a machine-readable way? And how will it be used? Let's look at a simple architecture diagram. The flow of information is illustrated by the direction of the arrows. As you can see, the crawler fetches data from our music website and saves it in the knowledge graph. The graph is then consulted when a user issues a voice command or a web search. Sean and I publish this information about our music artists and albums on our store website. Now, how do we do that? Rather than inventing a new publishing format, we will apply the linked data principles. The term linked data refers to a set of best practices for publishing and connecting structured data on the web. We will use schema.org vocabulary and JSON-LD serialization to describe the entities in our music store. If you haven't heard about JSON-LD or schema.org, don't worry. Click the links on the screen or follow along. It's pretty straightforward. For example, here's what an artist looks like in JSON-LD. The JSON-LD markup is embedded in an artist's web page on our site. Now, take a look at the same as property. This property will make it easier to reconcile or match the JSON-LD document describing an artist with a corresponding entity in our knowledge graph. In the spirit of linked data, the same as property links the artist with information on another site. This stuff is pretty important, but we'll show you more about how that's used in the next video. As I mentioned earlier, we built a mobile app so our customers can enjoy music on the go. How do we express the fact that our music artist we carry can be listened to using our app? Remember, I want our mobile app to be triggered by the OK Google voice command. Fortunately, we can also use schema.org and JSON-LD for that. A recent addition to the schema.org vocabulary makes it possible through something called potential actions. Here's an example. Note that in our markup, we are making an association between an artist and a mobile application we have built. Let's recap. Sean and I described our store using JSON-LD and schema.org. So now this information is machine readable. We have also associated our music app with artists that it can handle. Does this mean that our music app will now be triggered when the user asks Google to listen to the music we have marked up? Not quite. First, we need to test. There are several things that can go wrong we want to verify. The crawler has to be able to parse the JSON-LD markup we have published. Artists described in our JSON-LD documents have to successfully reconcile or match with entities in our knowledge graph. Our mobile app has to handle specific intents so that the music starts playing when the app is triggered. Quite a few things to test, isn't it? Don't worry. To help you with testing all this, we have provided sample open source implementations of the components you see highlighted in this diagram. The website, the mobile app, the crawler, and the small knowledge graph running in a graph database called Kaylee. We have also built a mobile and web simulator to help you trigger the schema.org actions defined in the JSON-LD documents for the music store. All right, what do we do next? Now that our JSON-LD markup is on our music store site, we can run the crawler to make sure our markup is correct. The crawler parses the JSON-LD markup and transforms it into a graph database called triples. It looks like this. If this sounds intriguing to you, it sure is for me. See the second video where my colleague Barak will show you how the output of the crawler can be loaded into an open source database called Kaylee. Barak will also show you how you can join the music store data with Freebase, a free structured data repository with millions of people, places, and things. If you would rather skip ahead and learn more about how the entities published on our music store website work in conjunction with schema.org actions, see the third video in this series. Better yet, clone the repository that we have shared and play around with the code before you proceed to the next video. Thank you and have a great day.
Mobile developers and designers use different approaches to achieve the same goal: creating 5-star apps that users love. While both development and design approaches are essential, they are usually considered separately. In User Experience Design for Mobile Developers, you'll learn how to integrate design approaches and techniques into your mobile development to build world-class apps. This is a design course for developers who want to give their users a great experience. For more information, visit udacity.com/Google.
Everything has a location, whether it be the photos you took, where you are, the places you like to hang out, where you bought that special gift, or even the last place you met your date. I'm Megan Boundy, Product Manager for the Google Maps mobile SDKs. Today I'm going to show you some cool ways to use Google Maps mobile SDKs to help you both bring these experiences alive and delight and engage your users. In this session, I'm focusing on the Google Maps Android API v2, but all of this functionality is available in the Google Maps SDK for iOS as well. This is great if you're looking for cross-platform consistency for your apps. When developers think of having a map in their app, they often think of something like this: a marker on a map. This is great for showing your location or marking out where you might want to meet someone. But did you know that you could add Street View to your app like this? Or make cool apps like Santa Tracker that follows Santa around the world as he delivers presents. Let's take a look. Our docs show you how to embed a Google map in an Android activity. Then it's easy to add markers to your map. You just use the Add Marker method and specify a few options to customize the marker. For example, you can set latitude and longitude, change the color of the marker. You can also set what shows up in the info window when the user taps the marker and the info window pops up. You may even want to use photos as your marker. Maybe you want to show where the photo was taken on a map and associate it with an event, rather than just showing a strip of photos in your app. Now that you've seen markers, let's take a look at Street View. Most excitingly, you can add Street View imagery to your apps. In this demo, you can see the split screen with the Street View imagery in the top half and the Google map in the bottom half. By long pressing the marker and dragging, Street View imagery updates and shows you the location where you drag the marker to. So how do you do this? A very similar demo is available in the demo examples in the Google Maps for Android API v2 itself, so the code is all there. Here we've split the layout into two parts. It's one fragment for the Street View panorama and one fragment for the Google map. You then set the same initial location for the map, the marker and the panorama, and we've given our marker a custom icon which is Pegman. When you drag the marker, you listen to a drag event from the marker and use the callback to position the location of the panorama. When the panorama change event occurs, the listener will give you the precise location of the panorama, and you can feed this back to the marker to update its position completely accurately. So what else can you do with Street View? You may want to add Street View to your store locator, see an area around a hotel, or view a museum or an aquarium. Street View also provides you with seamless access to Google's indoor Street View imagery. You can set the Street View panorama to be of imagery within the aquarium, or set it outside the aquarium and have your users navigate inside if they wish. Of course, you can do this for stores as well if the store has indoor business view imagery. This would be awesome if you're a store owner and you want your customers to see what's available inside to entice them to come and visit you. Okay, moving on. How can you make your users feel more immersed in their Maps experience? Have you tried out the Santa Tracker app and wondered why it felt so movie-like to follow Santa as he flies around the world? This is because we made the camera track Santa's location. Both the Google Maps mobile SDKs use a camera that lets you set the location of what you want to look at. You can animate the camera by using a camera update and calling the animate camera method. This is where you can also set the zoom level, the bearing, the tilt, and the duration of the animation. It's so effective. If you don't want to see any animation, you just call the move camera method instead, and it will move the map directly to that new location. We have a whole session dedicated to the Santa Tracker app at Google I/O 2014, so make sure to take a look. Now you know how to make your users feel more immersed in their Maps experience. How do you add things to the map and animate them? For example, how do those weather apps get the clouds coming in over the terrain map? Google Maps has several map types available, such as satellite, hybrid, or terrain. It's really easy to switch between map types. You just use the set map type method on the map and specify the map type that you want. These apps are also using mostly transparent tile overlays with the clouds as the opaque features. Tile overlays allow you to specify particular tiles to be shown at a given set of coordinates. You should also specify which tiles can be shown at each zoom level. All you need to do is define a URL tile provider and supply that to the tile overlay options, then add it to the map. To make the clouds appear to be moving, the weather apps are swapping out multiple tile overlays periodically to make it appear animated. Talking about the weather, it may be time to go inside. There's also the ability to see indoor maps along with programmatic control of the indoor level of the building and the floor picker. You can find out which building is active by calling Get Focus Building, and then find out the active level of that building by calling Get Active Level Index. This is great if you want to show custom markup for the active level, such as markers, polylines, tile overlays, and other shapes. You can also turn off our default level picker and implement your own by passing false to the method Set Indoor Level Picker Enabled, and then adding your own. Now we've seen all parts of the world via our map: indoor, outdoor, street view, a normal road map, and weather overlays. Who knew you could do so much with maps in your apps? To get started mapping up your own apps, go here for Android and here for iOS. And if you need any help, our support page lists the Stack Overflow tags that you need. So what are you waiting for? It's time to get out there and start mapping up your apps.
Hi, I'm Lewis from the Google Play for Education team. In my experience as both a former middle school teacher and in working with thousands of teachers over the past 10 years to integrate technology, I've learned that schools and classrooms are a pretty unique environment. Vibrant, supportive, collaborative, nurturing, busy, perhaps even a bit chaotic are some words that come to mind. And diverse. Curriculum, classroom environments, and teaching and learning styles vary dramatically. Google Play for Education is a dedicated store designed just for educators that works hand in hand with our tablet program. Its features make it a great opportunity for educational app developers. Your app's success depends on whether it pays careful attention to the demands of the unique environment. Many of the principles involved in developing an app for consumers at home need to be rethought for the classroom. So in this video, I'd like to share 5 key considerations for optimizing your app for the classroom. I'll also tell you about some of the top requested features we've heard from educators. So let's get started. First, simplify your app by focusing deeply on a few aspects of the user experience. Here's why. Students will have very limited time to learn and use your app, and will often need to access your app quickly from multiple devices. For example, if a device has a problem, many schools keep a stash of extras on hand to distribute on the fly. Or students might use a different device at home. So here's a few aspects of your user experience to be sure to focus on. First, make sure your app can be learned without instructions or has a quick onboarding experience. Teachers won't have time to teach students individually how to use your app. Next, make sure your app works well in bite-sized chunks and that students can quickly pick up where they left off. Students need to be able to get in, use it for 5 to 10 minutes, and then move on to another part of the lesson. Be sure to test how well students can transition from one device to the next. So if you have a website that complements your app, be sure students can move back and forth from tablet to laptop and back really easily. Google Sign-In is a great way to do this, which I'll talk about later. And finally, clean up your UI. Don't forget that if your app might be used by little kids, say in kindergarten, make your touch targets large to help their little fingers out. Also, many students, even older ones, might not be able to read or might be English language learners. So use lots of visual cues or audio prompts. Walk into a classroom with an amazing teacher. You'll immediately see students that are deeply engaged. But where does technology fit in? We asked schools, and they told us that using Google tools is about more than technology. It's about adopting a culture that extends beyond the classroom walls. It's about openness, curiosity, and working together. Plus, learning should be fun. So to make sure your app supports an open and engaging classroom culture, consider this. Since students using your app will all be using tablets, are you taking enough advantage of the hardware's unique capabilities? Are you using the touchscreen in interesting ways? What about the camera, the microphone, or other sensors? Students should not just be staring at a screen. Does your app work well in highly collaborative environments? You might see a few students gathered around a tablet, or maybe 5 students, each with their own tablet, working together on a project. And lastly, can students use your app to learn by creating? Students need to apply their learning by building, being creative, and expressing what they know. Apps that enable this are much more engaging, and also give teachers an authentic assessment of what students are mastering. So whether it's the sensors that are being used to take measurements for an experiment in science class, or students in English class that are making a video with their own dramatic interpretation of Shakespeare, be sure your app fosters student engagement. Teachers and students will use a variety of apps and tools. So be sure your app isn't an island by integrating with Google's platform APIs. The most common request we hear from teachers is that apps must integrate Google Sign-In. Imagine for a moment that you teach middle school math, which is what I taught, and have 180 students going through your doors every day, which is what I had, by the way. And what it'd be like to manage that if the kids had separate usernames and passwords for each app they used. Google Sign-In helps solve that problem. We've literally had teachers tell us that when they're looking for apps to buy, they start by first looking at only those with Google Sign-In. Easy authentication, it makes that big of a difference. Here's why. All students will already be logged in to their tablet with a Google account. It's required as part of our tablet setup process. So if your app authenticates with Google Sign-In, students can log into it with just a couple clicks. And 30 million students across the world use Google accounts as part of our Google Apps for Education offering for schools. So integrating Sign-In is also a great way to appeal to that huge base of users. The details on this OAuth-based approach are on our website at this link. Oh, and don't forget, if your app reads or writes files, be sure to also integrate with Google Drive, as Drive is incredibly popular among those 30 million students and teachers I mentioned. Many teachers use Drive sharing features as a way for students to collaborate with each other and to turn in assignments for grading. Teachers have incredibly hard and busy jobs with tons of constraints and demands. Even if your app's primarily focused on students, the more it can also meet the unique needs of teachers, the more likely they'll keep using it. So be sure your app aligns to the Common Core state standards in the US, and especially the increased rigor and application of knowledge that they represent. Common Core standards are learning goals adopted by 44 states that outline what a student should know and be able to do at the end of each grade. Our educator review process explicitly looks to see that apps align well to the Common Core. Plus, this will make it easier for teachers to find your app, as teachers can filter by standard right there in the store. So the next 3 suggestions go hand in hand: support differentiation, progress monitoring, and feedback. This type of personalization allows students to work at their own pace, but with support from their teacher. A great book reading app, for example, might allow a teacher to assign different students to different books based on their reading level. Then, teachers should be able to see key metrics for each individual student, such as what concepts they've mastered, which books they've read, or how much time they've spent on different topics. And allow teachers to give meaningful feedback to students right there in the app. Lastly, have an educator-friendly app description. Be sure to highlight standards alignment, differentiation capabilities, any other teacher features right there in your app description. For example, the description for slice fractions highlights the specific fractions concepts covered by the game, and it also includes a note to teachers. Lastly, and this hopefully goes without saying, but be sure to test, test, test. Try your app on the various Google Play for Education devices. As of this video, there's 4 supported tablets, but be sure to check out our site for the latest. And be sure to try your app with real kids and teachers, and iterate constantly based on their feedback. Also be sure to check out our Google Plus education communities too, as they're a great place to connect with educators who would love to share their ideas with you. So to recap, here are 5 things to keep in mind to supercharge your app for the classroom and help teachers and students transform learning. Be sure to check out our site with even more info, with details about topics like safety, privacy, and data, monetizing and ads, more information about app quality and testing, and our Google Play for Education review process. And I can't wait to see your amazing educational app. We'll see you in the classroom.
Hi there, my name's Ellis, and this is Making Polymer Elements Accessible. So you've gotten the web components bug and downloaded Polymer and you've made your first custom element. Fantastic. Today, I'm here to talk a bit about how we can make sure our brand new custom elements can be used by everyone. Right now, built-in HTML5 elements work well for accessibility. This didn't happen by accident. Browser developers followed published standards for ensuring the accessibility of these elements and add keyboard handling, styling, and semantic information to make sure that all users can use them. When we're creating new components for the web, ideally they should be using the same standards. They too should be accessible to all users. When we talk about all users, there are several broad classes of impairment that we consider. Visual impairment, which could range from poor color vision through low vision to no vision. Hearing issues, whether a user is deaf, hard of hearing, or simply can't use their device's audio output. Mobility or motor impairment, whether temporary or permanent, such as a broken arm, RSI, or long-term motor disorder. Other impairments, which encompass a very broad range of issues, including cognitive impairments like dyslexia, ADHD, brain injury, and other impairments like learning disorder, epilepsy, and vestibular disorder. The first thing we want to look at is whether our element can be used with the keyboard alone. This is a first step ensuring it can be used by users of assistive technology on all platforms, but also important for users with motor impairments or injuries, or any desktop users who can't or won't use a mouse right now. During your user experience design, think about how you would use your element with the keyboard alone and figure out a consistent set of keyboard interactions. To help with the design process, consider including physical impairments in your user experience personas. If you're creating an element which mimics an existing element in some way, consider copying the way it handles keyboard interaction to provide consistency. Try using a native element with the keyboard and find out what already works. Chances are you've been using the keyboard sometimes anyway, so you'll find it comes pretty naturally. Later we'll talk about ARIA, which allows you to specify additional semantics for your element. Once you've picked a semantic role, you can use the ARIA Design Patterns Guide to get some extra advice on what keyboard events to handle. The first step in actually implementing keyboard interactions is to make sure the element can take keyboard focus. Unless you can actually focus on the element, it's not going to get any keyboard events. Ensure you have a sensible focus target for your element. For a simple element like a button, this will obviously just be the element itself. A complex element like a menu may be one focus target within the page, but then manage focus within itself, so that the active menu item always takes focus. In this case, you want to make sure that the menu items are programmatically focusable, but not in the tab order itself. This is where an understanding of the nuances of the tab index attribute is going to come in handy. Tab index can take one of 3 classes of values. When tab index is 0, the element will be in the natural tab order, which is defined by the DOM order. This is what you would use to make a custom element, such as a custom button, keyboard focusable. When tab index is negative, the element will be programmatically focusable, but not in the tab order. This will be useful for something like the menu example on the previous slide. The menu container element can manage setting focus to each individual menu item when appropriate. The tab index is greater than 0, the element will be in a manual tab order. This makes no sense in the context of web components, since you essentially never know where your element will fall on the page. So now that you've spec'd out your keyboard interactions and made your element focusable, you need to implement the actual keyboard interactions. Luckily, there's an event handler for that. You can add an on-key down attribute to your Polymer element and add a method to handle the keyboard event, checking for any key press events you're interested in. Finally, make sure your keyboard interactions are discoverable, especially if they're not using one of the standard patterns. Tooltips or keyboard help overlays are common patterns for achieving this. Once our keyboard interactions are working, we're a good part of the way there already. Next, we need to take a look at whether our element can be used with assistive technology. The types of users who would use assistive technology range from users with visual impairments who might use screen readers or braille displays, to users with cognitive impairments, such as dyslexia, who might use a screen reader to augment their reading ability, and users with motor impairments who need to use technologies like voice control to interact with their devices. There are really only two parts to ensuring that your element can be used with assistive technology, including screen readers, once you've addressed keyboard accessibility. Adding semantic information, including the element's role, state, value, and name, and making sure that all information conveyed visually has a text alternative. First, let's talk about semantics. One of the great things about custom elements is that they make our markup look semantic again. We can hide presentation logic inside the shadow DOM and use meaningful element names to create a readable DOM. However, assistive technology doesn't see those semantics. It still sees, essentially, div soup, unless you tell it about the semantics you want your element to have. Assuming we're not extending built-in elements, the way we tell assistive technology about these additional semantics is using WAI ARIA, or ARIA for short. ARIA is a specification defining support for accessible rich web applications. It defines markup extensions implemented as attributes on elements, which can be used to provide additional information about the semantics of elements to assistive technologies like screen readers. This is what using ARIA looks like in vanilla HTML5. So we can use ARIA to add the semantic information we want to our custom elements. This is a custom slider element, which you can visually see has a minimum value of 1, a maximum value of 5, and a current value of 2.5. Until we add the relevant ARIA attributes, though, this element doesn't communicate any of this to assistive technology. We can add ARIA value attributes to tell assistive technology about the value of this element. Here we've added the attributes for role and current minimum and maximum values. Finally, once all your semantics are in place, make sure you always have text alternatives for any other information which is conveyed visually. For example, if your custom button uses a settings icon, make sure you give it a name of settings as well. And obviously, make sure all of your images have an alt attribute, even if you want them to be skipped by assistive technology. Assistive technology will try to come up with alternative text if you don't provide it, and often it'll pick the file name. So provide an empty alt attribute if you want the image to be visible to assistive technology. We also need to make sure that users with any form of color blindness can use our element. Firstly, this makes sure that we're not communicating anything with color alone. Color shouldn't be used as the only means of conveying information, such as indicating a status, prompting for a response, or distinguishing a visual custom element. Here we have the Chromium dashboard, which as well as being a Polymer application, gives a status for each new web platform feature being developed or shipped in Chromium. Since the color dots next to the stakeholders are meant to convey information, the developers added a tooltip here, which appears when you hover over the name giving the same information. We also need to make sure that there's always sufficient contrast between text or icons and the background color. This is important for users with low vision who might have trouble reading low contrast text, colorblind users in the case where we're using two different colors next to each other, and any user using a mobile phone or device in bright sunlight. Any text content displayed in your element should at least meet the minimum contrast ratio of 4.5 to 1. You can audit your element for sufficient contrast using the Accessibility Developer Tools extension, which even provides suggested foreground and background color pairs if it finds low contrast text. Lastly, make sure any moving or flashing content is stoppable and safe. If you have any fancy slidey, parallaxy transitions, make sure you have a way to turn those off. They can be a real pain for people with vestibular disorder who may experience motion sickness symptoms while using them. And if you have any flashing content, please don't tell me you're re-implementing the blink tag. Make sure it meets the criteria for safe flashing content of having a flash frequency of 3 times per second or fewer. So let's recap and summarize everything into a handy list. Remember, Every built-in HTML5 element will have all of these properties, at least in a mainstream browser, so we should make sure that custom elements do too. Make sure that your element can be used with the keyboard alone. Make sure that it works with assistive technology. Make sure that it doesn't rely on color to communicate important information. Make sure all text and icons have sufficient contrast ratio with the background. Make sure that it works without sound. I didn't cover this, but make sure any video or audio elements have the appropriate text alternatives, and make sure you aren't relying on audio cues to prompt for actions. And finally, make sure any moving or flashing content is configurable and safe. Please check out our article on the Polymer Project website, which goes into
Good afternoon and welcome to the first session, right? What's new in Android? The session that I like to think of as the Android keynote for the people that couldn't actually wake up that early. So congratulations for actually waking up this early. We'll see how it goes. Yes, well done. Give yourselves a hand. Absolutely. This is a talk that traditionally has been done by me and Romain Guy, who could not make it this year because we didn't ask him to. But we did get an appropriate stand-in for Romain. We found someone that can fake a decent French accent.
Croissant, café, Eiffel Tower.
So with that, let's introduce ourselves, because obviously you have no idea who we are. I am Chet Haas. I am on the UI Toolkit team in Android.
I'm Dan Sandler. I'm on the Android System UI team.
That accent didn't last very long.
It didn't. I couldn't.
All right, so one of the questions that comes up, it just came up at lunchtime actually down in the cafeteria, is, okay, so there's an L release. What does L stand for? And I'm here to tell you, can we have like a drum roll or something? L if I know. But for today, we are calling this the L Developer Preview release. We heard about this in the keynote. And we can see by the graphics on the screen that aren't quite professionally done that it is not a final release. It is instead a preview release where things work pretty well, but it's not done yet. We're hard at work finishing the L release. And in the meantime, we're exposing it to you to actually use. In the meantime, get your apps running and happy on it. And most importantly, to send us feedback about what's not working exactly perfectly so that we can actually nail that down by the time we ship it. So in the meantime, today we wanted to give a session talking about all the bits that are new in this preview release that you can get your hands on and play with. And there's a lot of material in here. We'll see how fast.
We have about 6 hours of material to cover in 45 minutes, so you're going to have to hang on.
So first of all, let's start with graphics and UI, because I like to start with graphics and UI, and I usually like to end with that as well. So we heard about the material design stuff in the keynote, and we wanted to touch on a couple of those elements in here. I also want to point out, I'll give you references at the end of this section about where to go for more information during the conference. In fact, one of the whole points of this session is to give you just a little bit more detailed info on all of the feature areas that we find interesting to talk about, and also the references to what other sessions and what are the videos you should check out, or sandboxes that have further information, or where you can simply find Diane on the show floor if you want to ask her directly. So in the material area, we have a new theme, we have some new widgets for you, and we also have some new APIs, which you can use at your option. The theme exposes new colors. There's an idea in material design that all the assets are by default grayscale, and then they can be tinted. So it's very easy to brand your application or your application state with colors, as opposed to baking the colors directly into the assets. So that's much easier now. There's new icons out there. Some of them are animated, part of the rich interactive experience that we have with material design. We have touch feedback ripples we'll see a little bit more about that give the user a sense of interacting with the UI and knowing exactly what's going on in the UI at all times. And also activity transitions with shared hero elements. We'll see a little bit more about that. In the widget space, we have a couple of widgets that are very important. One of them is minor. It's card view. There's not a lot there. It's basically a container with rounded corners, and it's raised up off the view hierarchy plane a little bit to give a shadowed look to it. This is not something that's too hard to do in your own code, but having card view there allows you to have this look and feel in a consistent way that other applications are using it as well. Recycler view is a little bit larger. If we can actually just do an informal poll of who has actually used list view. Okay, if I can just count, hang on. Okay, so that was basically everyone in the audience. Now, if we can get a count of the people who have enjoyed that experience, I count 2, which is actually 1 more than I expected. So you can think of Recycler View as being List View 2. This is more extensible, more flexible. We have layout managers that you can plug in to get different layouts. It's amazing. You can actually linearly lay out both vertically and horizontally. Incredible. Absolutely. Because on the Android team, we think not only about Y, but also about X. So we have a linear, why the groan? We have a linear layout manager in there right now. We have some other layout managers that we're working on that will come out with it, or you can write your own custom layout manager. There's also animations baked into it, some very simple add-remove animations right now. I don't know if anybody's actually tried to implement animations in List View. I know I personally have done several videos trying to explain how to do this nearly impossible task. What we'd like is for that to simply be automatic. So we started down the road for that. And both of these, most importantly, unlike a lot of the new APIs, which are obviously just part of the L release, these widgets are actually in the support library in V7. So you can use those.
How much did you pay them? We're getting a lot of applause lines here.
I actually don't know what they're clapping at. It has nothing to do with what I'm saying. Something else is going on.
World Cup.
So you can use those in your material applications, in your L applications, but you can also use them in code for earlier releases as well. So have at it. Also in the graphics area, we have real-time soft shadows. We heard a little bit about that in the keynote. We'll hear more tomorrow in some sessions tomorrow. It's the ability to give elevation to views, to pop them up off the view hierarchy plane. Not only giving them elevation and z-value, and then allowing them to cast a shadow, a soft shadow, based on that elevation, but also to draw outside their bounds. One of the tricky parts about doing things like shadows is, or if you want to scale that view, well, then you need to tell the containment hierarchy of that view not to clip it. Well, giving it elevation pops it into what you can picture is like an aquarium, a 3D volume that sits on top of the view hierarchy. And all of a sudden, you've got much more flexibility about how that thing is drawn, about how it's clipped, and about the ordering with which it and its shadow is drawn in the hierarchy. We have animations. Yay, more animation stuff. The biggest one in this area is activity transitions, in particular the ability to share elements between activities. So we've seen some work, I think it was last year at I/O, there was an animation talk, and there was some dev bites around this where we showed techniques for passing information between activities such that you could pass information about elements and you could sort of fake this animation to look like it transitions seamlessly from one activity to another. So that technique has been baked into the platform. So there's a standard API way for you to say, this is my shared hero element, or a set of shared elements. And you can pass those between activities, and they can share them. They can animate them between the activities. You can animate other items in and out between the activities, and you can customize the entire experience, making it all part of the material idea of making all the transitions seamless for the user as they go from state to state to state in their application or in your application. Also, there's new animation curve capabilities, both motion and timing curves. So you can have a much more custom path-based curve in the timing area. You can also move things in X and Y along a curve, which is a little bit tricky, possible, but tricky before. And finally, there's animated reveal capabilities. So you can reveal the next state of an activity or a view by having a circular reveal that exposes it over time. And I think there's a video of some of this stuff. So this is sort of an epilepsy-causing animation here that I looped, just showing some of the shared element transition stuff where we're popping the view in and out. If you look closely, you can see a shadow that's popped as we're elevating it. And then as it goes back down to the view hierarchy, we launch the next activity and pass that view over as the shared element between these two separate activities. We have some new icon capabilities. There's a couple of different ways of animating states in icons. One of them you see in the checkboxes and radio buttons, the ability to basically animate keyframes or these images that represent an animation from one state to another. And there's another one called State List Animator, where when you go from one state to another, you can specify a custom animation that'll animate properties over time. And then finally, we have touch feedback ripples, which gives the user indication of what's going on in the UI when they press that button. It's not simply going from unpressed to pressed, but it's actually giving them information about the gradual state change that's occurring, as well as possibly where that state change occurred. So if we look at the video here, let's see if that is really hard to see on the screen. There's some subtle ripples on the button down below, and you can see the ripples are actually emanating from the touch point that I had when I touched this beautiful button in my UI. And then the checkbox up at the top, that's one of the animated PNG animations that we have for the animated state list drawable. And render thread. So this is kind of an implementation detail, but it's a really interesting one, so I'm going to talk about it anyway. And it's also important, and probably increasingly important as we go forward for performance. One of the issues that we have with UI and graphics animations and performance in UIs in general in Android is that everything needs to stay on the UI toolkit thread, which means if you're doing something silly like querying a web service on your UI thread, A, don't, and B, you're going to freeze your UI, and C, A before, don't do that. But you can get yourself into these positions in some cases necessarily because that is an operation we need to perform in the UI toolkit thread, and therefore everything else happening halts. A really great example of that is when you launch an activity, then we need to inflate that new activity if you're in the same process on the UI toolkit thread. Well, in the meantime, if you're running an animation that also needs to run on the UI toolkit thread, then that animation is going to stop while the activity launches. So we came along with the render thread technology to be able to break apart the two processes of rendering. There's the creating the display list of what we actually want to render, and then there's actually executing that display list and telling the GPU how to draw this stuff. And we broke these two apart. So we create it on the UI toolkit thread where it necessarily has to be, and then we pass that information over the wall to the render thread to let it actually execute and talk to the GPU on a separate thread. In particular, what we want to do is take these atomic animations and send them over so they can perform completely autonomously on the render thread, so that now you're not beholden to the state of the UI toolkit thread if you're inflating an activity or doing an expensive operation, because the animations can happen asynchronously at the same time. So we've started down that path right now. There's going to be more work going forward on that. A great visual example of that right now is the touch feedback ripples, which happen on the render thread, and they happen completely autonomous of the UI toolkit thread, which is why when you click on something that launches a new activity, the ripple continues to actually animate while the new activity window is coming up. There's some important I/O talks where we go into a lot more gory detail in a lot of this stuff. So I would suggest that you check those out. Some of them are, of course, the material design talks themselves. They're scattered throughout the conference. And I frankly didn't look up the names and titles, so they're not on this slide. There are two sessions in particular that go into the more techie details. One is called Material Science. This is tomorrow morning at 11. And the other is Material Witness. Material science is an overview of the sort of entire space, kind of a deeper dive of everything I've just talked about. And Material Witness is a use case where Romain and I wrote particular apps using these APIs and then talk about how they were actually implemented and how the technology works. The sessions in your schedule right now probably have different names because we were withholding the material name until after the keynote, but the real names will be out there very soon. So check those out, and there's also an I/O byte on activity transitions in particular that you can check out as well. In Support Lib, there's the recycler view and the card view stuff that I talked about. There's also other capabilities, including palette capabilities for doing color sampling stuff. This was mentioned in the keynote. Matthias was talking about that this morning. There's rounded bitmap drawable. This comes into play in things like card view. It's very useful. View property animator. This was done as more of an implementation detail of getting recycler view animations to work. And notification compat is useful for Android Wear stuff. And we're on to WebView, where we have updated to Chromium build M36, which enables various useful web standards. So you now have WebGL and the other things listed on the slide. Check out the I/O byte, what's new in WebView, for more detailed information. On the graphics side, there's an update to OpenGL ES 3.1 with new compute shaders and new language shader language Capabilities, we have bindings in the SDK as well as NDK. And obviously, it's backward compatible with OpenGL ES 2 and 3, as they usually are. And you can say use feature in your manifest to specify this version exactly. The other important thing to mention was also mentioned by Dave Burke in the keynote. It's the Android extension pack. We basically collected a bunch of extensions that are really useful and powerful together and sort of bring the platform up to the current state of, say, console gaming hardware. And all of these come as a bundle, and we're working with partners to enable one and all of these extensions together. And there'll probably be a mechanism in the future for you to ask for this particular capability, which basically gives you the whole sandbox of capabilities all together. Lots of useful stuff in there, including tessellation, enhanced geometry shaders, and texture compression would be nice. Camera and audio space, there's a couple of talks I would suggest you go to for the actual details on this, but some image processing capabilities, also some audio data type, buffering information that I couldn't possibly address because I don't know. So I would suggest you go to the talks instead. And in the meantime, listen to Dan.
You can take a breath now.
Yay!
That's right. So related to the audio is a whole new set of APIs to effectively replace remote control client. If you've ever built a media player and you've dealt with transport controls, you know about remote control client. Here to the rescue is Media Session and its friend Media Controller. These are two new classes and a bunch of other support code in the platform to allow you to make multiple playback sources and multiple transport controllers and wire them all together. The nice thing about Media Controller is that it works from a non-UI process, so you can be running this entirely in the background if you need to do control of an ongoing playback stream from there, extract metadata, things like that. And we use that in the system UI as well. We'll talk about that a little bit later in the talk. Media Session hooks up to your playback stream and essentially handles those transport control requests in much the same way that you're already accustomed to. And you'll talk to the Media Session Manager to work with those. Great new tools, all in android.media.session, so you want to check those out. And we'll segue from here into all the other good stuff that's in the framework that doesn't fall under the green category.
It's the non-visual framework stuff.
That's right, except that I'm sure there's going to be some visual stuff here, like right here at the beginning. So recent documents and tasks. You saw this in the keynote. Our recent apps interface in the system UI is not just for apps anymore. We're now encouraging your app to break apart different components of the experience into different tasks or documents. We sort of call this a more document-centric interface. So you see in the screenshot here, we've got a couple of different web sessions, essentially web documents that are showing up as different cards in the recents experience. And so this gives the user much greater ability to shift back and forth between different tasks on one device. Go ahead.
Yeah, I was going to say, this came up in the keynote when they were talking about Chrome. There was a web session where they were talking about different tabs in the recents, and this is the capability that enables that.
That's right. So you can start a new document at any time by throwing in flag activity new document into that intent. You can also mark your activity that way in the manifest to say this is always going to start a new document. Lots of other APIs that we didn't have room for on the slide. You should definitely check it out. Also in the system UI, you can now do more with the status bar. In KitKat, we introduced a translucent status bar, which was great for wallpaper experiences and things that wanted to go full bleed. The problem that we struggled with was that gradient that we put in there to protect the status bar and navigation icons didn't work great in every situation. It's not a lot of space. We didn't want to overlap the app window. We didn't know what was going to be in the app window region. So in the L Developer Preview, you'll be able to see that you can do a lot of things with the status bar that you couldn't do before, particularly change the color to something that matches your application's color branding and so forth. You can use a solid color there, or you can use a completely transparent status bar, and then it's up to you to make sure that all the status bar icons, all the navigation bar icons still look great. But as you can see here in the screenshot, that gives us the opportunity in Google Now Launcher to create a nice long gradient that both protects the icons so the user can see them and gives you a really nice transition into the content. Check it out. You heard about power a bunch in the keynote, and we'll talk a little bit about it here. There's so much more to look into under the heading of Project Volta. The first thing you'll see is that there's a battery stat service that you can ask from ADB to give you all kinds of gory details about where the power is going on the system, what kind of power events there have been, and break it down by UID as well as looking at the global story. There's a tool in the SDK called Battery Historian, which I believe Dave Burke mentioned, that gives you sort of a trace view like HTML graph output. You feed it a bug report, and it will tell you essentially what happened to all of the power in that device over that session. It's incredibly, incredibly useful. Just a quick example of how to talk to these things. You can talk to battery stats and say, oh, you want to turn it on, you want to enable the full history, clear out all the stats, take a bug report, and then you stuff it into the historian, and you get out this great piece of graphics that you can use to understand where those coulombs went. Another thing that helps with power, and this was also touched on a little bit in the keynote, is Job Scheduler. We're going to go a little bit deeper here. It's pretty common that you've got an app that wants to do some work later, sometime in the background, sometime when it's plugged in, sometime when you have access to an unmetered high-speed network. So you can do all this today, right? You probably do in your app. You wake up periodically, check the conditions, and then go back to sleep if the situation isn't right. That's not super efficient because you are waking up the device just to check to see if it's a good time to wake up the device. Job Scheduler is here to help. Wraps it all up into something that the system can do and essentially call back your job when certain conditions are met. You see a little bit of code here. The interesting part here is that you specify the capabilities you need, and then you just give it a component name, and you'll get that component name called when the time is right. Very handy. Also in the framework, some improvements to the storage access framework, which we introduced in KitKat and API 19. Previously, if you wanted to pop up a file browser and ask for a directory, you couldn't do it. Now you can. Once an app receives a whole directory from the picker in this way, you can actually explore the entire subtree of documents and do whatever you need to do with that whole directory. Also in our framework are some new things around networking, a couple of different topics. The first one is multi-networking. We talked a little bit about Job Scheduler being handy for doing some work later under a particular kind of condition. What if you need to do work now? Your service is running now, your app is running now, but you need to open a socket on a link that has some particular feature, some carrier feature you need. It needs to have SMS capability, it needs to be unmetered, and so forth. The Connectivity Manager now supports the ability to handle these network requests. You say request network, and you give it a callback. Inside that callback, you will find out when a network meeting your criteria becomes available. And then you can use that network object to look up hosts and open sockets on that link specifically. The other nice thing about the callback, this is very cool, you get warnings when possible when the network is about to go down. This allows you to actually do a graceful handoff in your app from one link to another. Oh, you're about to lose Wi-Fi because you're leaving its range. We're just going to move this over, rebuild the stream on cellular with no interruption to the user. Also under the banner of networking is Bluetooth. We introduced in 4.3 Bluetooth Low Energy. In L, we are now adding peripheral device support to BLE, so you can provide services and scan for services pursuant to the way that Bluetooth LE peripheral devices do that sort of thing. Check out the Android Bluetooth LE package for more on that. Finally, under networking, we have NFC changes. NFC has been a little hard to use for users, a little hard to use for developers. We're trying to remove all those pain points. We're now showing Android Beam in the share menu to make it easier to go ahead and start an NFC transmission from the user standpoint. From an app standpoint, I don't know if you've ever had a situation where you're trying to pop up a dialog saying, now hold your phones closer together. And now you can actually specifically start a Beam operation anytime you want with NFC adapter invoke Beam. Another thing that has been a little harder than it needs to be is creating a very simple piece of text to push over NFC. Now there's a method on NDEF record to let you do that. And there's a bunch of new card emulation stuff that I can't begin to explain because, as Chet explained, we don't know what it is. So you should check that out. And now as a subhead of the frameworks, we're going to talk about notifications. There's a lot to talk about here.
It's the visual side of the non-visual.
The visual side of the non-visual. That's right. Yeah. Layers. There's a lot to talk about here. It's so key to what we're doing with L. We're doing with L for the user. There's a lot to talk about with notifications. Also, it's an area of my expertise, and I have the clicker, so we're going to talk about it for a while. I'm going to look at 4 different categories: how they look, how they work. We're going to talk about how that interacts with the lock screen and some privacy features we've added to make that work for everyone. Additional metadata that every app needs to start putting into its notifications to make sure you're ready for L. And then finally, we'll touch on Wear just a little bit. They've got great talks later in the program, but I wanted to just mention some of those interactions. So first, the new style notifications in L. We should take a quick look back. These are the different versions we've had just in the last 5 years. We've had a little bit of evolution. I don't know if you can see the differences there.
We're getting blacker and black.
The dark time for the rebellion right there at the end. Here we have notifications in L. We've moved to the material style. Let's go through and take a look at the pieces here. So first, I want to show you that we are, in fact, using the material theme. We are in line with the rest of the material design system that we're introducing for Android with L. We've got these card-shaped backgrounds. They cast shadows. The foreground is now dark text, dark icons, and the background is this light color. I should point out at this point, if you've been following the icon guidelines, there are no new icon guidelines, again, by the way. Trying to keep that going. But if you've been following the icon guidelines, you should now have small icons for notifications and for actions that are effectively masks. And in L, we're actually going to treat them as masks. We're just going to use those to draw in the correct color. As Chet was alluding earlier, that's something we're trying to do more of in L. So if you have any opacity baked into your icons right now, now is the time to get rid of it. Those should be full opacity, white on transparent icons everywhere. The next thing I want to draw your attention to is this accent color. This really looks great and can really make a notification pop out and showcase, again, that sort of color story that you may be trying to tell with your app. It's just one method on the builder, set color, and it fills that nice circle right behind the small icon and the notification inside that layout. I should point out that if you have a large icon in the past, we've kicked that small icon, that important symbolic representation of what that notification is about. We've kicked it over kind of to the side where nobody notices it. Now we're going to keep that color circle. We're going to keep that visual story, and we're going to shrink it down to a little badge that goes right in front of the large icon. So it's always right where the user expects to see it. And then finally, it just bears mentioning that everything else you know and love about Android notifications is still alive and well and showcased great in the L Developer Preview. Expanded views, action buttons, and as always in Android, if what you need extends beyond what we've been able to come up with in our templates, custom remote views are there for you and available. Now, I will say that one of the things that people have said to us is, well, OK, that's all fine and well, but I have to make a media player. And for media players, people expect transport controls, and then I have to go deal with custom remote views and all that pain. We've been suffering along with that basically since Honeycomb. No longer. We have a new template for you, the first one since Jelly Bean, media style. Material design finally comes to media playback. If you use this template, you will opt into essentially the design created just for you by the Android UX team, designing something that'll look great both on the lock screen and in the regular notification shade. One of the things that you'll notice about this is that the accent color fills the entire background of the card.
Is orange.
It is orange. I wanted to make sure they could see it from the cheap seats. Yes. What am I saying? This is Google I/O. There are no cheap seats. The accent color fills the entire card, and that helps it pop out when you're looking at the lock screen. That's where your media is coming from. For the first time, we're going to let you actually use up to 6 action icons. In fact, you could always attach up to 6. We just only show you the first 3. If you're using media style, you'll get all 6. And we draw them as little transport controls here, which is super handy. And in fact, we even let you use 1 or 2 of those in the compact form of the notification, again, to make sure that wherever you see that notification, it's a great place to play and pause media. There's a custom progress bar that fits with the theme. But most importantly, you don't need to use remote views anymore just to do simple media playback. I mentioned a little bit earlier there's a media session API. There's also a bit of the media style that allows you to attach your media session token right into the notification, which is going to tell the system UI, hey, this thing is playing back media right now, which is going to be important as we start to do things like integrating more metadata from that track, more metadata from that ongoing playback into the system UI. So for example, if you take a look at the L Developer Preview, you'll see that album art is regrettably not showing on the lock screen right now. I was working on the plane. I couldn't quite get it done in time. I'm sorry. But when we have it in L, it will use this connection to media session to get that metadata right out of your ongoing playback in real time. Very quickly, I want to show you a wall of code because everybody loves that. The important thing about this is just to note that most of these APIs here are the existing notification APIs that you know and love. They're the 5 actions that are in the demonstration there. I'm setting the color. And then right there at the bottom, we're doing notification media style, which lets you attach the media token and then pick which of the actions to show in the compact form. Something else you saw in the keynote, it kind of went by quickly, and I really should have put a video in here. So it went by so quickly, it disappeared from this slide. Heads-up notifications is something that we've added to L to make it easier for important things to get in front of the user without actually taking you out of context. So in the past, if a phone call comes in, you're in the middle of playing a game, that activity is paused, that activity goes away. If it was a multiplayer game, that's a great way to cause somebody's game to freeze so that you can tag them or what have you. No longer. Heads-up notifications are the new way for important things to get the user's attention without stealing focus away from the app. When that pops up, you can look at it, you can decide to ignore it, you can decide to swipe it away, you can decide to just push it back into the notification shade without swiping it away, or you can act on it by clicking one of the action buttons. We're using this for things that the user needs to deal with, the user needs to see. So high priority notifications will show up there. Notifications that involve people, we'll talk about that in the metadata section. Similarly about notifications that buzz, make noise, or that would use the full screen intent, which is the way, of course, that phone calls and alarms and things like that would take over your whole screen just from a notification. Let's take a little time and talk about the lock screen. So this is a big part of L. You saw this in the keynote. We heard you like notifications, so we put your notifications in your lock screen. It's there anytime you want to look at it. Why would we bother doing this? What is the point of this? Pre-L, the workflow of your phone going off, your phone buzzing in your pocket is you hear it buzz, you hear it ding, you reach in, you take it out of your pocket, you turn it on, unlock the screen, pull down the notification shade. By the time you've gotten through all those gauntlets, you've forgotten what you came there for. And there's some 5 other things that your email was sitting there before you pulled down the notifications, and you're already distracted. In L, you hear the phone buzz, you take it out and turn it on, and that's it. It's right there. It's completely glanceable for everyone using an L device. But what about privacy? So for many users, the design that we showed in the keynote, the design I just described, is a perfect trade-off. It's OK for you to allow your notification content to show up on your lock screen because that's super useful to you. Unauthorized users are still not able to get into your phone without authenticating. But that doesn't work for everyone or every IT department, particularly in a bring-your-own-device scenario. So we've introduced something in L called notification visibility. This is a new privacy feature for notifications specifically about how they interact with the lock screen. It lets apps specify what is safe to show where. It lets users specify whether they care about this level of privacy, and device policy can be involved as well. So to explain this, I have to dig into the spheres of visibility. I need like an echo, like a reverb for that, spheres of visibility. This is the public sphere. This is all the things anyone can do with your phone. You can do it. Chet can do it if he picks up your phone. The person who picks up the phone at the bar when you've left it on the bar stool. These are all the things that you can do from the lock screen without authenticating. This circle inside of it are the private things. These are the things that only you can do with your phone because you know how to get into it. You can authenticate. You can get past the lock screen and get into your notifications, your email, your apps, your games, your data, your pictures, and so forth. So in the notification visibility world, we call this central, this ring of the things that only you are supposed to be able to see, visibility private. A notification that is marked visibility private, very much like an Android notification up until now. That is to say, we don't leak anything about it on a lock screen where the user has said that they care about this sort of thing. All you show is the icon, and in fact, in L, we also show the application name to help fill the space. If you set a notification to be visibility public, you're saying this notification has nothing sensitive. It's completely unobjectionable. It's the weather, right? It's your device is low on battery. This is not information that is personally sensitive. It's safe to show on any lock screen, no matter whether the user is concerned with that level of security. There's a little ring here that I didn't mention before, which is the things that are private that you can kind of see in the lock screen. I told you that in L, we continue Android's tradition of showing notification icons even if you haven't authenticated. So one of the things that you can do now in L, I'll show you an example in a minute, is say if you've got a private notification where the user doesn't want to see all that sensitive information on the lock screen, you can provide a substitute, a public version that lets you provide a redacted form of that same notification for a sensitive lock screen. We'll see an example on the next slide. I do want to mention also that now that we've created all these circles, all these pretty builds in this slide, there's one little spot that's left, which is things that only you know are even there. We didn't have an opportunity to do this in Android before. So we've created the third and final visibility level, which is visibility secret. If you post a notification that is visibility secret, it doesn't appear on the lock screen at all. So if this is an app that's particularly sensitive and you like to get notifications for it, but you don't really want anybody else to know that it's installed, visibility secret is for you. OK, here's that promised example. So let's say the user has said, this is important to me. They set up a pattern or a pin on their phone, and they've said, when the device is locked, I want to hide the sensitive notification content from the lock screen. If you have a notification that is visibility public, this is what you see on the lock screen. I may or may not have overseen that on a lock screen somewhere. Anybody can see this notification, whether they've authenticated or not, whether the user cares about security or not. This is safe for everyone.
I don't think so.
Well, so this is why you would say maybe this is something that's visibility private. A chat app is the sort of thing that maybe is supposed to be personal.
Should have been.
Should have been, really. You should think about that next time. So if you have a visibility private notification on a lock screen where the user has said hide sensitive notification content, this is the experience you'll see by default under the L developer preview. Icon, app name, nothing else. So if you as an app want to provide a better experience, you can provide that redacted version. You can create a public version of the notification. You say set public version. You construct a whole new notification object that is a substitute for that one to be shown only on the lock screen. And so in this case, we've corrected, we've changed the app name a little bit. We've added an exclamation mark because that makes people feel cool. And we've actually given the user some interesting information. You have a new message. It's not simply something is happening from this app, which could be I have a sync problem, or you need to pay $5 or whatever. It's actually giving you a little bit of information, but it's not sensitive information. So it's compatible with the user's wishes. And then finally, there's that visibility secret, and those things wouldn't show up at all. Now, of course, if the user goes and says, well, when my device is locked, I actually don't mind seeing all my notifications there, then you see the same thing. It's essentially as if every notification is public. We talked a little bit about metadata, about adding people and things like that. We actually talked about metadata in KitKat. We've started to introduce some new features to be able to stick more information onto notifications for the benefit of the system UI and any notification listeners that the user may have enabled. Well, we've got more for you in the L developer preview. One of the reasons is that we want to do sorting a lot better. There's limited space to show notifications on the lock screen. And in the past, sorting things chronologically, maybe with a little bit of priority, it's good, it's not great. We're doing better in L. So one of the things that you can do in L to make sure that notifications get sorted in the right way so that users are seeing the most important stuff first is attach, first of all, a notification category. We have a number of categories. They're in the notification API. It's a set of essentially a global partition of notification space. If what you have doesn't fit, then you don't have to set a category. But if your thing is an incoming voice call or an incoming video call, or you've got an alarm clock app, hi timely team, then you could tag your notifications with that category and make sure that the system UI knows what kind of thing it is. And as we improve L, we will be able to do more things to sort of mute things that are not relevant to the user's current context. We'll use that category to do it. There's a new extra key for the notification extras called extra people. This is for you to be able to say this notification relates to a person that the user might care about. What do you put in here? You put in a URI from the contacts provider, or you put in a telephone number if that's all you have and you're not integrating with Android contacts, or you put in an email address. Whatever you have, you put in extra people, and then System UI can take a look at that and say, hey, that involves somebody. I might want to boost that up. And the other stuff is still important. The timestamp, whether there's a full screen intent, priority, whether it makes noise, all these things are going to give the System UI new tools to be able to know what things are most important to show to the user first. Most importantly, though, for developers is to give that user that control. Let the user turn off notifications. Let the user change the properties of notifications. You don't want to run the risk of the user banning notifications using the system settings app, a very popular feature that we introduced in Jelly Bean. And when you do give users choices about notifications, when you give the users that activity that lets them configure everything, put that activity into your manifest with the new intent category listed on the slide, notification preferences. And we will actually link to that notification preferences page right from system settings. So if you go into settings, notifications, you'll be able to jump straight into the apps that have notification preferences that the user can control. Briefly, I want to mention that where is key to the notification story in L and vice versa. It's very much like the L lock screen. It's super glanceable, except with where it's already out of your pocket. Your phone app's notifications appear on wearables automatically. They get bridged there. You've seen this in the keynote. You saw this as part of the Wear unveiling a couple months ago. Notification Wearable Extender is the place where all the APIs exist for you to customize the appearance of that notification specifically on the wearable device. Split it up into multiple pages, group notifications together, and things like that. And as you get into more advanced Wear development and you're developing apps for Wear itself to run on the watch, you'll see that it uses notifications there too. In fact, the notification manager on the watch is the thing that manages those cards that you see in the wearable UI. So you'll use the same old notifications API to interact with Wear from on the wearable itself. There are I/O sessions that you should definitely check out. Tomorrow at 10, the Android developers on the Wear team are going to take you through all these APIs in detail, and there's an I/O Byte on YouTube about building these UIs as well. OK, other important stuff. Take it away, Chad.
OK, I took my breath. I'm back.
OK.
So other random stuff that we couldn't actually find an appropriate bucket for. So here it is. Art, we heard about this in the keynote. You've heard about it before. It came out in KitKat as an optional runtime, and now it is the runtime. I had thought previously, oh, it's the one that's enabled by default, and then I was corrected this week. It is the one. In fact, Dalvik, what Dalvik? Everything is art, and it's a good thing. Faster runtime, the ability to actually precompile this stuff, so it's running faster, a lot more intelligence going on in that runtime than we had before. And one of my favorites is the increased capabilities for garbage collection. So less frequent pauses and shorter durations of those pauses mean better ability to actually hit your frame rate, particularly for animations. If you had a GC pause of 10 milliseconds, which was sometimes common, unfortunately, in Dalvik, depending on what was going on in the system, that could just push you right over the boundary of a frame, and you'd skip a frame, and the user would see a hiccup in the animation. Now, if you have pause times of around 2 milliseconds, then it's much more probable that you're going to stay within that 16 millisecond boundary, and it's not going to affect your frame rate of those animations. So faster, better, newer, cooler. Check it out. In particular, go to the art talk that's Thursday, tomorrow morning at 10. And also go to the Sandbox, and they're giving an ongoing talk, GC and Jank in art. Talk to them. I think there's also documentation that's coming out on the web if it's not there already. So lots of stuff to check out there. Oh, one of my favorite things, too, is the moving collector, the ability to actually move stuff around in the heap, which caused some of the delays that we saw before, that things couldn't move. So then the heap would get fragmented, and then it got harder and harder to find space for things that you needed to newly allocate. Well, now we can actually collect the heap and move stuff around when that app is backgrounded. So very powerful capability, linked with the ability to then take really large objects like bitmap and put those in a set-aside space so that the really large objects aren't taking up room in the common space where all the little tiny objects need to go. So that's part of the reason why we have much smaller pause times for allocations as well as collections, because it's much faster for us to find the space that we need when we actually need it. Android TV.
There's a great talk about this. Let's see when it is. That's this afternoon. Yes, this afternoon. All about Android TV. There's an I/O Byte on YouTube. The message from the Android TV team is this. You saw it in the keynote. There's going to be one app. You're going to produce one app, and it's going to run great on every device that calls itself Android: phones, tablets, TVs. When your app is ready for that 10-foot experience they talked about in the keynote, there's an additional intent category you can toss into your manifest to move your app up so that it shows up on that main panel, that main rail inside the TV launcher UI. You can still launch your app if it's not there, but when it's ready for that TV experience, that's how you move it up. More info at d.android.com/TV.
Enterprise, the main thing I'd say here is go to the Sandbox and attend the talk on frameworks for enterprise and device management. And Ben will give you more information about what's going on for enterprise. They talked about it a little bit. Sundar was talking about it in the keynote. About managed profiles, the ability to actually have your IT department, let's say in a BYOD world, actually manage what's on the device, and then this division between the device owner, the person actually using the device, and the profile owner, which might be the organization that that user is a part of. And the ability to do that in enterprises is increasingly important. There's new APIs in Device Policy Manager that enable this, and there's also an app that they're working on for pre-L releases that will enable some of these capabilities as well. Android tools. I spoke to one of the people on the tools team and got the brief take on exactly what's new and exciting in the tool space. And then I said, OK, great. I will talk about it in the session. He said, actually, we're going to talk about it in Thursday, so please don't. So go to their session tomorrow at 9 and learn what's new in tools. Play services, there's an excellent session coming on this afternoon. So we have the Wear Data API, much more information about what's going on there. Games capabilities, the capabilities of quests, as well as saved games in the cloud. So you can actually save your share state between devices much more easily. New drive capabilities, new wallet capabilities, increased analytics for your apps. Much more that I didn't want to get into this slide, and they can tell you much more about that at the session if you go there. And some other stuff that didn't even fit into our other grab bag category. Security. SE Linux is now in enforcing mode. I would encourage you to go to the secure development on Android I/O Byte on YouTube and check that out. Get more information about that, as well as some other things in the encryption area that you can learn
learn about. And also in the printing area, but I would say just in general, we have a new PDF renderer capability that allows you to take PDFs and then render them as bitmaps. Very useful for printing, and we use it for the print preview, which is now part of the release. But you can use it in general if that's a capability that you need in your application. And most importantly, the Preview SDK, what is it? When is it coming out? Tomorrow. So here's some URLs. d.android.com /preview is where you can get more information about the preview release, as well as download the bits for building against and download system images for Nexus 5 and 7 minimally. That comes out tomorrow. So please get started developing today. Yeah, there's the links to tomorrow. Yeah, develop for the preview release of L today, tomorrow. And in the meantime, go to all the I/O sessions, enjoy those, and the I/O Bytes online are being posted as of today. And please, if you have issues, please submit them. The sooner the better, because the sooner you submit them, the better chance we're going to have of actually knowing about them in time to fix them for the full-on L release.
And we ran out of time.
We did run out of time.
We planned it perfectly. We have 17 seconds for Q&A. So actually, we're going to take Q&A downstairs in the sandbox on the platform level. That would be the second floor, right?
We'll be there right after this talk, and thanks for coming.
Hi, I'm John Raygrant, Product Manager for Gmail Extensibility. I'm here to talk about the new Gmail API. Let's start with a quick history lesson. Back in the midst of the distant past, there was email. Many email systems were closed, meaning that you had to use a specific application or a specific website to manage your mail. This made it hard for people who had multiple accounts or multiple clients to manage their mail. So IMAP was born. IMAP is a standard protocol designed for an email client to connect to an email server. IMAP's great because it means that we can do cool things like get all of our mail into one inbox or send email using any of our accounts from the same client. So IMAP was designed to enable a full-fledged email client to connect to an email service. Gmail initially introduced IMAP support in 2007, specifically with the goal of making it easy to use mobile device email apps to access your Gmail account. And it was good. Then things got interesting. Once Gmail opened up to IMAP, the developer community realized that there was now a way to enable users to add features that use their Gmail data. These developers, you folks, went way beyond building simple email clients. You did brilliant things like adding a record of messages exchanged with each prospect to a CRM system. You made useful utilities which manage your email subscriptions or allow you to send mail at a later date. You even wrote custom Chrome extensions which talk to IMAP and extend the Gmail UI. All of these are good things. So what's the problem with IMAP? Well, IMAP's great, but Gmail and you have gone way beyond what it was designed for. IMAP was designed a long time ago, originally in 1986 with the last major core protocol version in 1998. To give some context, that's the year that the Sony PlayStation was battling it out with the Nintendo 64, and a new search engine called Google first launched. APIs have come a long way since then. IMAP was designed to handle the kind of mailboxes people used to have. It was never intended to scale to hundreds of thousands of messages in an inbox. In 2004, Gmail revolutionized the inbox by giving you 1 gigabyte of storage, giving you the ability to stop wasting time sorting folders and instead use powerful queries to search labels. Despite the decade since IMAP was introduced, it still doesn't have standards to support the revolutionary way Gmail interacted with users a decade ago, let alone our many improvements since then. It's not that IMAP isn't useful. It's that it's getting used in ways for which it wasn't designed, sort of like this golf club. You can use it for bowling, and since you're clever and determined, you might manage to knock down some pins, but it's not really the right tool. So, we're introducing the new Gmail API to enable you all to creatively meet the modern use cases of today's users. We've kept in mind all the performance and ease of use that you'd expect to come with that. The new Gmail API provides very simply what you would expect, with RESTful access to threads, messages, and labels, including drafts. In contrast to IMAP, which requires access to all of a user's messages for all operations, the new API gives fine-grained control to the user's mailbox. If you just need to send mail as a convenience from your app, you don't need to ask the user for permission to read mail. To keep in sync, the API allows you to query the inbox change history, thereby avoiding the need to poll or do archaeology to figure out what changed. Most importantly, this API is designed to make it easy and efficient to do specific queries, such as, get me all the messages exchanged with Joe, or get all the messages received with the My Company label, or get me all the messages in this thread. Essentially, the API offers the full search capabilities of the web UI using the same syntax as the search box. Since the new Gmail API is a standard Google API, you get simple HTTPS access using RESTful calls and get your responses in JSON, XML, or Google Protobuf formats. You can also make these calls from standard web languages like Java and Python, and there's no need for a TCP socket. This means that the API is accessible from many cloud environments that couldn't support IMAP. Not only does the new API replace IMAP for many applications, it also replaces SMTP for mail sending. And one huge advantage is speed. As I mentioned earlier, IMAP was never designed to do what you've been getting it to do. Because the new Gmail API was designed for the Gmail backend architecture, it understands labels instead of folders and is optimized for exactly these operations. Here are some preliminary speed tests which demonstrate that even before the tuning which you beta users will be helping us to do, the Gmail API handles getting a thread or doing a search for matching messages a factor of 3 to 10 times faster than IMAP. Since the new Gmail API is a standard Google Developer API, you'll be able to get started right away using the same developer key and developer console that you already use for other Google APIs. All access is under standard OAuth 2.0 authentication, so you've likely already done that as well. If you haven't, the example apps and SDK documentation have done most of the work for you. The Gmail API is entering beta the week of June 24th, 2014. We're really eager to get your suggestions and feedback. To get started, go to the Google Developers site and follow the instructions to sign up for the beta. And we'd love to hear your feedback and suggestions. On behalf of the Gmail team, thanks for your attention, and we can't wait to see what you'll make with the new Gmail API.
Hi, I'm Jarek Wilkiewicz, and I'm a developer advocate. I was born in Poland, and like many other engineers, I grew up reading science fiction. In fact, this is my favorite author. My childhood home was actually very close to his house in Kraków, and little did I know that his work would have major influence on my life. Did you read science fiction too? Do you remember the moment when the protagonist, while busy saving the world, asks her computer for something? Computer, make it so! And the machine just does it, and it nails it. Now, why can't the real world be more like this? For example, when a user says, OK Google, and asks for something, the application or service most suitable to fulfill the request should be invoked and get the job done just like that. Today I want to talk to you about technology based on schema.org actions, which I think is a small step in that direction. With actions, we have an opportunity to delight your users and bring more engagement to your app. However, we can't do it alone. We need your help. At Google, we have been working on organizing the world's information to make it universally accessible and useful. To help with that, we've built the Knowledge Graph. The Knowledge Graph contains information about entities and their relationships. One of the interesting applications of the Knowledge Graph is resolving ambiguities when processing language queries. For example, the artist dual core is a band, which is different than the concept of dual core. As far as the strings are concerned, these two are equal, but to a user who is asking their phone to play dual core, the difference is quite clear. Dual core the band is assigned a machine ID in the graph. We like to refer to these types of object-based identifiers as things, not strings. Having a graph entity with a machine ID, OMID, makes a big difference. The Knowledge Graph can also help satisfy user requests with your application. I thought a good way to show you how this works is to actually build a small Knowledge Graph together with you. But first, Let me introduce you to my buddy, Sean. This is Sean. We both like music. Sean likes to DJ and spin dance LPs in his free time. One day, we would love to open a record store. We would curate an awesome selection of LPs, and on weekends, we would invite our favorite artists to give concerts at our store. Now, wouldn't that be great? Our music selection would, of course, be available for purchases online. We would offer web and mobile streaming access as well. Since today, most music recommendations are provided by computers, we would want to make it easy for computers to discover and understand what we have to offer. For example, when the user says, "OK, Google, play dual core," we would like our app to be ready to fulfill users' request. All right, so we have this music store. We are selling LPs, offering streaming access, and hosting events on weekends. How do we express this information in a machine-readable way? And how will it be used? Let's look at a simple architecture diagram. The flow of information is illustrated by the direction of the arrows. As you can see, the crawler fetches data from our music website and saves it in the knowledge graph. The graph is then consulted when a user issues a voice command or a web search. Sean and I publish this information about our music artists and albums on our store website. Now, how do we do that? Rather than inventing a new publishing format, we will apply the linked data principles. The term linked data refers to a set of best practices for publishing and connecting structured data on the web. We will use schema.org vocabulary and JSON-LD serialization to describe the entities in our music store. If you haven't heard about JSON-LD or schema.org, don't worry. Click the links on the screen or follow along. It's pretty straightforward. For example, here's what an artist looks like in JSON-LD. The JSON-LD markup is embedded in an artist's web page on our site. Now, take a look at the same as property. This property will make it easier to reconcile or match the JSON-LD document describing an artist with a corresponding entity in our knowledge graph. In the spirit of linked data, the same as property links the artist with information on another site. This stuff is pretty important, but we'll show you more about how that's used in the next video. As I mentioned earlier, we built a mobile app so our customers can enjoy music on the go. How do we express the fact that our music artist we carry can be listened to using our app? Remember, I want our mobile app to be triggered by the OK Google voice command. Fortunately, we can also use schema.org and JSON-LD for that. A recent addition to the schema.org vocabulary makes it possible through something called potential actions. Here's an example. Note that in our markup, we are making an association between an artist and a mobile application we have built. Let's recap. Sean and I described our store using JSON-LD and schema.org. So now this information is machine readable. We have also associated our music app with artists that it can handle. Does this mean that our music app will now be triggered when the user asks Google to listen to the music we have marked up? Not quite. First, we need to test. There are several things that can go wrong we want to verify. The crawler has to be able to parse the JSON-LD markup we have published. Artists described in our JSON-LD documents have to successfully reconcile or match with entities in our knowledge graph. Our mobile app has to handle specific intents so that the music starts playing when the app is triggered. Quite a few things to test, isn't it? Don't worry. To help you with testing all this, we have provided sample open source implementations of the components you see highlighted in this diagram. The website, the mobile app, the crawler, and the small knowledge graph running in a graph database called Kaylee. We have also built a mobile and web simulator to help you trigger the schema.org actions defined in the JSON-LD documents for the music store. All right, what do we do next? Now that our JSON-LD markup is on our music store site, we can run the crawler to make sure our markup is correct. The crawler parses the JSON-LD markup and transforms it into a graph database called triples. It looks like this. If this sounds intriguing to you, it sure is for me. See the second video where my colleague Barak will show you how the output of the crawler can be loaded into an open source database called Kaylee. Barak will also show you how you can join the music store data with Freebase, a free structured data repository with millions of people, places, and things. If you would rather skip ahead and learn more about how the entities published on our music store website work in conjunction with schema.org actions, see the third video in this series. Better yet, clone the repository that we have shared and play around with the code before you proceed to the next video. Thank you and have a great day.
Hi, everybody. Welcome. So during the keynote, you heard a little bit about material design. And we hope to give you a little bit more detail about that today and in the sessions that follow tomorrow. But first, I want to tell you a little bit about our inspiration around material design. Every object in this room owes its origin to a few people throughout the millennia who paid careful attention to their environment. They sought out the very best materials, and they learned their properties, and they used this knowledge to make things. And when you consider making things, the design and the manufacture of things, we inherit thousands of years of expertise. In contrast, relatively, software design is just getting started. Much of interface design concerns itself with what people see. But with modern high-resolution displays coupled with the ability to physically interact with the software, your expectations are much greater. In fact, there's thousands of years of expectations. And so we took a step back. We looked at all of this software and we asked, what is this made of? We challenged ourselves to define the underlying physics of our interfaces and craft a visual language which unifies the classic concepts of good design with a solid understanding of the most fundamental physical properties. At first, we thought like designers. How should it appear? How should it look? But then we thought like scientists. Why does it behave this way? And after many experiments and many observations, we wrote down everything that we'd learned. These are our material principles. Thanks, John.
Yeah.
Hello. In Android 4.0, Ice Cream Sandwich, we introduced a typographic magazine-style UI. And a lot of people liked it. We were pretty happy with it. But design is continually evolving. Users are getting more sophisticated. The design landscape is more sophisticated.
In particular, motion has become incredibly important over the last few years. We wanted something that was taking the very best of graphic design clarity and the innovations in motion graphics and motion communication, but that still tapped into those elements of tangibility, of physicality that industrial designers themselves use. So this led us to a question of, how do we do this? And the very first principle in material design is metaphor, which seems a little random. Why metaphor? Metaphor is basically a very, very short story. And like stories, metaphors are really powerful because they are deep and dense in meaning. They communicate more richly than verbal language can. When I say, if I'm writing a play, if I'm telling you about a character or a person in real life, if I say she was a hurricane, I don't have to tell you about her force of will or her indomitable spirit. I don't have to tell an actor that averting her gaze would be inappropriate. The metaphor is a form of knowledge transfer that depends on shared experience. And in fact, this capacity to transfer knowledge and to transfer learning is one of the things that defines humanity and, in fact, defines intelligence. So for us, the idea of metaphor is a backstory for the design. It unifies and grounds the design, and it has two functions. It works for our audience. We want to present a metaphor that they can understand, that they can connect with, that they can use to move faster into understanding how to use things. But it's also a metaphor for ourselves, for the designers and the developers and the PMs and the QA people, everybody working together. Because when you have a metaphor that everybody understands, intuitively understands, you don't have to explain how they violated subsection C, clause 2 of your style guideline. They just know it feels wrong. They know it's out of place. So why this particular metaphor? Why did we imagine a material that was a form of paper sufficiently advanced as to be indistinguishable from magic? Well, one part of it is, of course, that we do have a lot of experience as humanity communicating with paper. Paper is just rich in a history across all our cultures of conveying information, and it naturally affords so many different ways of interacting with it. But the other aspect of paper is that it is a physical thing. It exists in the world. And this idea that surfaces, because they're tangible, are a metaphor that we can use to accelerate understanding of our UI is really important. You have this perception of objects and surfaces that's happening in the more primitive parts of your brain. It's happening in these visual cortexes that are in the back and lower parts of your brain. And that means they're simply easier than language. They are more natural than language. You have this inherent understanding about the separation of things and the relationships of things that allow us to look at this and have it make sense, even though we know there is no material in the world that could possibly do this. It is irrational and yet feels completely natural. And that's what we want when we're creating digital magical interfaces, right? Because we are not constrained by the laws of the real world in our user interfaces. Surfaces are intuitive, and that's why we use them as the foundation. They organize space and rationalize the interaction. And it matters that you preserve this inherent sense of what's right, not for the sake of artifice, but in order to make the mind work less. One of the things you'll discover in our material design documents is that our buttons rise to the surface in response to touch, instead of sinking into a surface like a fake plastic button would. And we do this because we want this illusion to be consistent. The idea that when your finger touches that glass on your phone, that surface is coming up and meeting your finger at the point where it touches.
Thanks, Matthias. Content is bold, graphic, and intentional. We pushed ourselves when we were thinking about material design to make clear and deliberate design decisions regarding color and typography. So embracing these classic visual design principles that John and Matthias have both spoken about in our new framework. With Ice Cream Sandwich, Android introduced a new system font, Wearable. And today, we're updating Wearable to go beyond phones and tablets and be the default typeface for the Material UI. Here you can see the current version of Wearable. And Wearable is now slightly rounder, friendlier, and most importantly, redrawn to perform on desktop and beyond. And I can tell you from personal experience that it handles really well. We also developed and documented our design guidelines for typographic scale. By using one typeface and a handful of weights for emphasis, we believe that it delivers a consistent and clear hierarchies in your products. Using scale and appropriate display sizes, you can create dynamic print-like layouts with using white space and contrast. This focuses your users on the content that really matters. Using vertical key lines and baseline grids, content is bold, elegant, and graphically clear. We also developed a complete color palette with intentional color decisions for shades, tints, and accent pops. These are not just adding white and black to a color or using alpha. We actually looked at each of these shades and decided what they should be. So strong and intelligent application of color gives life to your UIs, and it connects users with your brand. It also can create very strong hierarchy and liven up some pretty standard UIs. As you can see in this example, it's essentially some kind of form that you're filling out, and there's a clear area for your title, and that's what we want people to focus on. Dynamic color is also really exciting. Earlier today, Matthias announced a new API in the L preview called Palette. This system really makes it easy to color things, dynamically select, and extract color for use. One of the things that you could use color for is contrast accent colors. Contrast colors make this floating action button, which is the play pause button, really pop. Brand color and icons are accelerators that guide users through your design. When thinking about app icons, we looked at real-life studies in lighting and shadow. We started by defining a universal grid for app icons, one that supports primary geometric shapes. A product icon is the first literal touch point of your user's experience. We looked at extracting those attributes from your icon and from your brand and intelligently applying those to the surfaces within your UI. The top toolbar and the floating action button, again, are accelerators for those actions. Here's just another example of how to connect those surfaces to the product icon. And finally, we took the same modern, bold, geometric approach from app icons and applied it to the UI icons you see in your app. Our design teams are now using one common set of icons between Android L, Polymer, and the web. This means one trash can across all devices, and we'll be releasing these icons later this summer through our design guidelines available for use on both Android and the web.
All right, so even if we're doing all this and we've got great typography, as an industry we're leveling up when we start using baseline grids. We've got amazing color. it's not enough just to draw the static states and stop there. We can do more to show people how the states are changing, letting them focus on the content that matters. So when you think about it, almost all state changes in a UI start with user input. And this is why Material UI puts that user input at the center of the animation story. So when I touch the screen, immediately the surface responds. I can see exactly where I touched and the intersection of the object that's responding. This does two things. First, it tells people that they've been heard. They feel powerful, they feel like they're in control, apps feel responsive. Second, it confirms to them that the UI is going to do the thing that they expected, that it's working. This animated touch feedback is now built into the platforms for both Android and Polymer, and it's being used by all of the relevant components. So it's not just the immediate touch feedback, though, that's centered on user input. The material itself transforms to bring in new content. And all of this happens on a shared stage. And when I say a shared stage, I'm talking about the environment where this material lives. It's important to know, as we're looking at the material, that it lives in the same scale and in the same space as we do. We're not flying through some imagined space or looking through a window into another world. This material lives in the same scale as the device itself, whether it's in our hand or we're looking at it on our desk. We don't move, the material does to bring the content to us. You can see how this works as transitions organize themselves around the object as it's selected. The material moves, expands to reveal the new content. And notice that even as the content transforms in a way that maybe a physical material like paper wouldn't, it's still very clear what's happening because of the way the material responds to light and the way the shadows are being rendered by the platform. So animation is crucial to reinforcing this metaphor that Matthias talked about. It's just in the same way that the shadow rendering helps us understand what we're looking at, the way that things move give cues about how they work and about their properties. So, for example, the material animations naturally show continuity from one state to another. When I select an item, it expands to the next state. It doesn't jump cut. It doesn't blink in and out. It moves naturally like sliding a piece of paper across the table. If we teleport our users from one state to another in a UI, it can be confusing and disorienting when they get to the other side, almost like if we were to be teleported in the real world, if I were to just appear on the stage in front of everybody here, it'd take me a few moments to get my bearings. It's the constraints that are inherent in the material that make it clear for people what can happen and it lets them predict and understand what has happened. So if it makes it easier to understand what's changing, at the same time, it can show us what's important. So since our eyes are naturally drawn to motion, if something moves and it's in our field of view, we're going to see it. It's a really strong tool for us to help direct focus. If in a music screen, the player controls are the primary interaction, the animation can point that out. Also, even noticing the details, those small things that you might not even notice overtly, like, for example, the small slide on the control slider as it comes in. Wait for it. There it is. Even though people might not notice it overtly, they see it and they know how things work without having to think a lot about it.
So these guys talked about many of our core principles, primarily the sense of tangible surfaces, which appeal to the primal parts of our minds with dimension and shading. Bold and intentional design, which provides a unified language that allows brand and UI elements to stand out. And meaningful motion, which fuses this design and the surfaces together and gives new affordances and life to UI. What we want to use these for is to create a new unified experience for users. We're surrounded by devices, and people experience our work across all of these different platforms. And for that reason, we want to treat every device as a window on the same content. We want to tailor the form factor so that each one of them has commonalities, but also can be unique. Color, type, and spatial relationships help tie them together. In this example email app, the sizes are all related by color and structure, but there's diversity in the overall presentation. The larger ones use cards so that line length is kept reasonable, and the small ones end up being full bleed so they can take advantage of the size of the device. In this Files app, there's a drawer on the side, but on desktop it becomes a persistent element. On tablets, it's a temporary overlay so it stays out of the way, and on phones, it's a persistent UI that you drill into. In this calendar example, there's more variety between the views, but again, typography and color tie them together so they feel like they're a consistent experience. Immersive imagery also plays a pretty big role. This is something that we've seen on mobile where people are doing things full bleed that we actually want to take back to desktop. It looks great there as well. And in particular, when things used to be sort of full bleed, we now can use things like cards to keep that same sense, even though they're now surrounded by other kinds of content. Beyond the platforms, we also care about working with different disciplines. Interaction, motion, visual design, and engineering are often not deeply associated. And so we've been using this material metaphor as a way to bind the different disciplines together and make them more collaborative. In interaction, the materials reinforce the overall sense of hierarchy. The scrolling and layering give a good sense of how gestures work and emphasize how the user should focus their attention. Visual design becomes simpler because of this. The content itself can be very graphic in its hierarchy and rely on dimensionality for higher level structures like toolbars or other elements, so they're not considered together. And emotion is in most ways the most important. Materiality provides a grounding for it. It makes it consistent and intuitive, so it's obeying realistic physics and speaking better to the user through that. More importantly, it allows motion to be deeply tied into interaction and visual design. We've got sessions tomorrow, and we'll talk a lot more about the interaction between these different elements, starting in the morning with interaction design, and then in the afternoon, visual and motion design. If you're interested in learning more now, you can take a look at the initial spec preview that we put up. There's probably more than you're interested in seeing in the moment, but you should come by and listen to the talks. We'll point out the most important parts. And stay in touch with us. We put up a new site for google.com/design, as well as a Plus community, so be sure and follow us there. We created these principles as a tool for all your future work. We want to inspire and involve your designs and your apps. So in addition to these sessions, we'll have a number of design sandbox events. You should come by and talk to us. But thank you for joining us.
So we've left time for questions. And there's actually microphones in the center aisle here. There's two. There's one in the back, and there's one up here. So if y'all have any questions about this or design at Google, or nobody has any questions. Everybody just wants to play with cardboard. By the way, if you've tried the Google Earth on the cardboard thing, it's just amazing. Here's a question.
I apologize. I'm a developer, not a designer, so this is a silly question. I like design, though. I see a lot of circles. What's up with the circles? I like them. I like them. Just could you speak about where they're appropriate, what you see them conveying to the user, stuff like that? Circles.
Who's going to take the circle question?
Matthias takes the circle question.
Oh, okay.
Okay, I'll take the circle question. I really would have thought the circle question should have belonged to the art directors, but. So one of the things that the circles provide, well, there's a couple different ways that we're using circles. Actually, it's probably good to step back and talk about one of the ways that we've simplified and we've tried to keep very kind of low level and elemental and primal what we're doing in material design is everything is really its most simple and basic geometric shape. So you'll see circles, you'll see squares, you'll see rectangles, you'll see basically divisions of space. So when you want to have a contained element, the simplest way to do that is to bring in the circle. So we use the circle because it's naturally has contrast to a space that you've divided up and that has blocks of text or areas that have been created by cards or divisions of color. The circle is a great way to draw your eye without motion to those elements that you want to emphasize, whether that is the floating action buttons that are indicating primary actions, or it's the avatars of people that are very important. The circles create rhythms themselves that help you organize and scan through the page, like when we have the multiple messages and email. So the circle, what you should think of the circle as is it is an element, a geometric element that is a visual design tool like any of the other tools. It perhaps, in a very simplified shape palette, stands out. And that is its attribute, that it does stand out, and you want to use it in places where you want to stand out or you want to create rhythms by repeating it. Did you guys want to add anything to that?
I was thinking about sort of where a lot of the circles kind of came from and kind of how we in the early days when we were thinking about this. So at the beginning, I talked a little bit about its material principles and the underlying physics. And one of the things that happens with any interface, if you're interacting with it, is you're injecting energy. Right? There's events that are happening. You're either interacting with it, you're touching the interface, and you're sort of, as you're using it, you're injecting energy into the process or things that are happening. And one of the most fundamental things that happens within physics is that whenever a signal happens, right, whether it's sound or light or what have you, it propagates in a circle. It propagates from its point of origin, and ideally at the same velocity outwards, right? And that's generally in a sphere in a constrained depth environment that's going to be in a circle. And so when you see not only the circles in terms of the affordance for interacting, but also as you tap on things and that circle radiates, it's really about just conveying the sense of the physicality of the energy going into the system, and that's actually your actions are spreading forth into communicating with the rest of the things that are on the screen. Next question.
Yes, my question is regarding the form factor. It seems like it's the apps now. With the material, you'll be able to design one app, and basically the app will adapt. It'll be responsive to the screen size that the app is running on. Is this where this is going, where with the material you'll be able to create one code base and be able to run the app on any screen size?
You want to talk to that one, Nicholas? Or
yeah, so there's two sides of this. One is we want to make it as easy as possible to not just reflow to different sizes, but also to tailor the way that we reflow in a unique way. So while the default platform behavior will do the right thing as far as allowing you to expand things to different sizes, we do want more thought and attention placed on how it should actually accomplish that. Beyond that, a lot of these design guidelines are intended to make that much more seamless of a transition, like the commonality of iconography and typography, those blend them together even as we introduce more differences. But our prime focus right now is trying to get these things to carry a design across those different form factors.
Yeah, I mean, I'll be a little more explicit as well. I mean, for starters, we do have two code bases, one if you're developing native apps for Android, and one if you're developing with Polymer for the web. There are framework components in both apps which will make it easier for you to scale between different screen sizes. But there is a lot of intentionality and design thought that needs to go into making some of those decisions. So we don't have one automatic system that will take any application and automatically scale it for you to any screen size. Maybe someday, but I think that would actually require intelligence that's pretty close to that of a developer and a designer combined. What we do have here is a design system where you can create a coherent app and use the same design and have very straightforward ways to adapt it if you understand also what the purpose of the app is and what is appropriate for the different screen sizes. And that still requires a human.
Cool. Next. Okay. By the way, I guess all the line is, yeah, okay, great. Okay. Yeah, you're good. You're good.
First off, you guys rock.
Thank you.
Yep. All right. So I'm a big fan of the animations and giving cues to the user and everything. But sometimes it could be too much, right? So at what point do you say, if I hit the play button, it's going to go around the screen 3 times, come back in, and pop up? Because some users
on every press, every single time.
So sometimes users can see that as a bug, or it might slow them down to whatever actions they're doing. So were there any concerns around that? And if so, how do you tackle that challenge?
Yeah, so I think one of the things to know about, and this isn't just true of motion design, it's true of design generally, that there's a lot that's going on below what people notice. So we don't actually want people all the time thinking about the animations when they're going from one state to another. You know, we don't want them to say, gee whiz, like this is, you know, I just opened up that email, and again, I saw that animation. We want them thinking about the email. And so, you know, if you apply that standard as, you know, how much do I want people thinking about the animation themselves? What is it trying to communicate? Then you can kind of back it down to the right level.
One of the things that we considered consistently throughout this process was how to use the animation to sort of go along with the user's intention, because when you have touch responses that sort of emanate outwards, it's very easy to hide details in there that reinforce what's happening without feeling like you've added a bunch of animation in there. So what we'll go into this a bit more tomorrow, but having things sort of move counter to the direction the user's doing things, draw attention to them. And if you're going to do so, you should do that intentionally. If you don't want attention to draw into things, there's places to hide them. And it's really about trying to figure out how you want to balance it and where you want to draw people's attention.
Hi. So I was wondering if you could extrapolate on how you see new forms of input with respect to motion. So in regards to wearable devices, let's say a swipe left and a swipe right with a wristwatch, or drawing a circle in the air. How would that integrate with the user experience on an app level, let's say, or on your desktop, and how that would sort of integrate?
We've been given a design challenge on the fly. How to design gestural interfaces. I think a lot of this I think goes back to the material as a metaphor, and part of what we're trying to do is, you know, you go and you watch. You watch some summer blockbuster sci-fi movie, and sometimes it can be a little bit of a letdown because they set up a bunch of, like, they set up the world in which they're operating, but then they break some principle, right? You know, and it just kind of falls flat. You're like, why did that happen? And I think part of what we're trying to do with a system like this is to set up a series of sort of a world in which it functions, and ideally it's grounded enough in the reality that we have here, such that, you know, you can bring your intuition of how objects function to the system, and it fulfills those expectations and hopefully exceeds them. But then maybe we add an additional, you know, magical things that we can't quite do yet with physical devices because we're rendering with virtual devices. The bridging of gesture and other types of interfaces, to me, is actually just another level of it's another additional dimensionality in terms of interaction. So, and it's a progression. So when we started with computers, we basically had keyboards, right? You know, and then it's like, oh, so eventually we got a mouse, and so like that was like a little bit of interaction, slightly removed. You know, here it's happening up here, and I'm using these things to control it. Then we get all the way now to today, where we have smartphones with touchscreen displays, and so now we have this additional dimensionality of being able to physically touch the software. And now we're adding this other layer in, hopefully over time, and hopefully do it right, where we have wearable devices that have, you know, gyros and stuff. I mean, even the cardboard device actually is really fascinating because it's really awesome you play with it. But you know, it's just like it's you know, basic head tracking and things like that. And so as we continue to sort of add in these the dimensionality of interaction, right, with gestures, it makes it so much more rich. And so we just want to make sure that we're always grounding it into sort of these principles that we set up initially, so that it's always self-consistent. You don't get to a moment where you're like, oh, I did this thing, and then that didn't make sense. I did this, you know, it was discontinuous with all of the principles that had been set up before it. One of the things that I think is really interesting about this, and we'll talk about this more in tomorrow's sessions, is that there's actually a fair amount of spectrum, right? There's a lot of different types of things that can be expressed, both in terms of color and content and the animation, that gives you a pretty big palette, right? It still feels like it's part of a system, but it gives you a very large palette, so you can express lots of different things. So I think with the addition of wearables, I look forward to seeing how people, you know, express their apps and their applications, you know, through these additional different forms, different interface forms in terms of manipulation.
One of the other things that came up as we were doing this, first as we were looking at just desktop and mobile together, was unifying the overall touch feedback through them. So having hover states and tap states all be resolved together. And then we started to see more and more of these, and treating it as energy was a very nice metaphor for us, because we were able to look at on touch, these things are going to move outwards. Voice, as you're speaking, you have a similar response to it. As you use the D-pad on the TV, the movement of your focus through UI will be very similar. And one of the things we didn't really touch on, but like tabbing between controls using a keyboard can have a very similar feel. It's like it is your focus moving through space, and then when you like hit enter on something, that energy blast is very similar to any other mode of input you might do.
Cool. Thanks.
Thank you, guys. Appreciate your time. So I work for a company where we are both cross-platform, and our mobile apps are not our primary moneymaker. So when it comes to when it comes to requesting time be allocated to working on this, it can be looked at as a little bit of an indulgence. What would you suggest as some maybe priorities to focus on when looking at implementing some of these things?
For the most part, the framework should be supplying 90% of the animation and the richness in the UI. What we're asking people to do is actually look at some of the new APIs for shared element transitions between activities. Like there are moments that make good places for polish and brand in your app. So using the core elements, using the core iconography, using the theming to make it feel like it's your product, but then just polishing one or two really critical things usually has the best outcome.
Yeah, and the Polymer framework is actually going to be really great for all kinds of different platforms, mobile platforms. So.
Yeah, and part of the reason we've done this for ourselves, it's helpful for us to be able to have, if we do a mobile web app and a native app, to create a very similar structure there, so we don't have different interaction designers thinking about different ways of handling it. They should be treated as pretty much the same app with small adjustments.
It's probably a good opportunity to also mention that after this, we're actually going to go, some of us are going to be in the design sandbox on level 2. And as part of releasing our spec and design and having all of this announced, we really want to talk to designers and developers about kind of the problems they have in terms of what they're trying to solve for their users, and so that we can understand how material design and the principles here can help support that, or maybe there's some unique problems out there that need a little bit of a different twist. And we'd love to hear feedback about that. Cool. Thanks.
Hey there, I'm Peter. I'm a UX UI designer, and my question is regarding animations. For one, as you all know, animations are something that kind of make an app pop and stand out. And recently we had a lot of trouble where, like, I work in design agencies and stuff, so where we make an app, we create animations either in Fireworks, After Effects, Origami, or we just animate them manually. And I was wondering if is there going to be a tool from Google that will help us kind of animate our design, because that's the hardest part of transferring it to a developer, explaining to them how it's going to interact. And will there be, in addition to the design guidelines, explaining what kind of default animations you should focus on, what kind of, will there be like more of a sandbox that designers can use so they can kind of carry their points across to the developers? Because I usually find that point where you kind of transfer all of your work to the developers, that's the toughest bit. And if a tool were there, like a native tool that would help us aid in that process, that would be great. But do you have any tips for that? And is there anything planned on kind of like improving that?
So even before the tool, one of the things that we've noticed as we've been doing that same process and designing things and working with engineering to make them happen is that having that shared metaphor and having engineering kind of understand those same principles gets us a lot closer from the very beginning, that we kind of know how things should move and how things should react. And I think that's a good place to start. I don't know if anybody else wants to comment.
It's also helped us we actually define a number of different animation curves. Like, we're not using just sort of simple ease in, ease out. But we got those sort of built in and worked with the engineers so they understood those. And we tend to use them everywhere, and then we iterate on them as needed. So tools aside, like, we found it just helpful to stay in constant communication with the engineers and try to get as much of this stuff baked in as logic into the system rather than like as things that we're handing over that are one-offs.
Okay. And what's your standard design process for like explaining it to the developers? It's just like a case of them sitting near you and you kind of cover the entire animation process with them together? How do you get like the point across to them?
It's fairly ad hoc, depends on the situation.
All right.
Like, sitting together is always the best way to accomplish anything.
Okay. I was just wondering if you have a standardized process for that. All right, cool. Thanks.
Yeah.
I do want to mention before you walk away that that kind of request or interest in tools or anything like that. We don't have any tools to announce today, but that's the kind of feedback and pain point that you guys are feeling that we'd love to hear about more, so we know how to focus our energy. And if you guys have more of those kinds of questions or requests, come by the Design Sandbox.
One follow-up.
Where's the design box? Sorry.
It's the second floor. It's design. It's over by the distribute section.
Kind of like you look for the YouTube
so it's
sign
downstairs.
and follow the YouTube sign.
Yeah, exactly. It's by the YouTube booth. That's right.
It's a very clear design.
Yeah.
So my question is really about color, and I see a lot of bright colors these days everywhere, and even in the pictures there, some of you have a purple background and a red, and so very bright colors, and they're all different combinations. So how do you pick these bright color combinations in context of material design, so that it's not so it's actually appealing to the user, and so has meaning, and it's not bright enough to be noisy or something.
We test 41 shades.
Well,
Not funny.
I think there's actually
Just kidding. Sorry, too soon.
There's
Too
two
soon.
approaches to color. One is that we intentionally wanted to take a very exuberant approach to applying color to our applications. We felt that, like I was kind of talking about some of the slides, where you should really embrace your brand's product colors or your icon colors and extend those things all the way through all the series of screens that someone's going to see. And so we thought, why not push it further? And on the reverse side, I think there's also some pretty extensive usability and contrast ratio studies that we've started to standardize around. And I think that that's the intention of the design guidelines, is to kind of help give guidance on being exuberant while still being accessible and usable.
Yeah, so to be super clear, if you go into the spec, you will find a whole bunch of palettes, and they have a lot of guidance on what kinds of colors you should put together in order to get legible text on top of them and stuff like that. But we are very much in love with and excited with these modern bold colors, but the entire system is designed to let different approaches and philosophies to color feel just as much at home. If you want your content to pop more and your UI elements to be really muted and subdued, that's part of material design as well. The idea is that it is a material like paper, and you can print something that's very exuberant on it, or you can print something that's much more muted. We want it to be a framework where any brand can fully express itself and feel at home and not be overshadowed by the platform's conventions.
Some of the examples you actually can look at in the preview will be like the settings app is quite muted. It's intended to be very utilitarian. Calculator app is also muted, but it uses a single pop of color to draw attention to other functionality. So it's again about management of where you want attention and color that makes an app really unique. One other point too, the palette library that we've been working on, one of the reasons we were so excited about it was it allows you to select colors that can go alongside imagery that allow the image to feel like it is covering the entire surface, rather than like an arbitrarily chosen color that may contrast in some unusual way. So you have the opportunity to have it extend the image outwards into the system, or even to contrast with that image if you want to draw attention to an action.
It looks like we only have 3 minutes and
left.
4 questions left,
Yeah,
so let's try to
right,
get through them super quick.
Try to be 4 questions.
I'm sorry
in
to
3
take
minutes.
the time, but actually I have 2 questions, and it's tough.
All right, the
first
crowd
of
will
all,
vote on which one we answer. No, just joking.
Okay.
Go ahead.
First of all, I heard Jonathan is working for UXA, which is the Google defined guidelines for the Google apps. So would you like to talk about that a little bit? How would you working across different apps to make the UX guideline consistent across Google apps, and how you also make sure all the apps will follow the guidelines when you did that? That's the first question. And the second question was, Google always have a big push on the left navigations. As a company, we didn't follow that rule, and unfortunately, what happened was right after our release from main screen navigation to the left navigation, we did see a lot of drop for the user engagement. And also we see a big trend that for Facebook app and Google Plus, they changed from left navigation into the main screen navigation. So do you guys like to share some insights of that change and how that will lead into a lot of companies that develop social app that could get insights from this? Thank you.
Okay, I'll answer the second question first.
Super quick. Second question.
Left nav is appropriate for certain classes of apps. The places we've seen the most successful is when it's something like Gmail or a stream of content where like 90% of your time is spent there. And the rest of the time you need sometimes access to other labels or things like that. We'll go a lot more into this in interaction design tomorrow morning, but like left nav is only one of a number of different top-level constructions. You can have tabs, you can have the content area itself act as overall navigation. One of the things we are trying to do in the guidelines is very specifically calling out the benefits of each of those different ones. Left nav itself isn't inherently bad, but when it's used for the wrong type of application, it can focus the user in the wrong way.
And I'll answer the question, how do we coordinate design across Google? We all talk to each other all the time. That's it. We go up, that's it. We just talk to each other all the time, just talking. All right, next question. Drinking and talking. Yeah.
I was thinking about all the materiality and the physicality that you stressed out in the paper metaphor. And I was thinking about Facebook's paper app, and they go a step further, giving away all buttons and making the interaction, the motion, the clue to the interaction, like to close something. And I wanted to know what you think of this. If you think that this app would feel right in the next generation of Android apps, or?
We love using motion as an affordance for things that can happen. We need to be careful about being too reliant on it because there may be people who can't perceive it. But it is a wonderful way to give clues as to gestures that can be taken, and even just to simplify the way the UI looks through it. So we're excited about the possibilities.
In our calculator app, we have a side panel of expanded options. There's no button for it. There's no little textured drag handle. It's just a surface.
And you close it by sliding twice?
Yes. Okay. All right, we take one more question.
Oh no, come on.
Just one. Sorry, they're telling us to go.
Hi. I was wondering if these design principles also apply to Google Glass.
Google Glass?
Will the design principles also apply to Google Glass?
As of right now, our design principles don't cover Google Glass. The information about color and brand and iconography definitely do, and we're working very closely with that team. Our primary focus for now has been sort of the watch to television form factors, but we're definitely considering it and working to tie them together.
Awesome. Thank you, everybody, for attending. Enjoy the rest of your afternoon.
Hi, my name is Alice, and I'm an engineer on the Glass software team. After our initial launch in the United States, Glass is expanding to other countries. I'd like to show you how to make your GTK glassware support more languages and therefore reach more users. Here are some basic techniques for localizing Android GTK glassware. First, make sure all visible text is declared in a base strings.xml file. You can then refer to each string by its name in your Java code. It's good practice to include a comment for each string, so your translators have more context on how it's used. Once your translations come back, simply put them into the corresponding values directory for that language. You can also have different versions of images, audio, and video files for different locales, but it's better if the same icon can just apply to all languages. That's pretty much all that's needed. Piece of cake. Now, let's look at some issues you might run into. One common oversight is using hard-coded strings in the code. This will lead to untranslated text. Another problem is translations that are too long, causing overlapping text. You can avoid this by suggesting a character limit in your original strings definition, so translators know not to exceed it. One more thing to look out for is parameters in text. It may be tempting to simply concatenate substrings together. In this example, received at followed by the variable to followed by a clock. But in the Chinese translation, 2点钟收到, the time variable moved to the front of the sentence instead. As shown here, the solution is to use placeholders in your string definition so that the entire sentence gets translated as a whole. That concludes how GTK glassware can be localized. Once your glassware is ready, remember to submit it to the Glass team for review. We look forward to seeing your submissions, and thank you for watching.
Hi, my name is Prateep Banerjee. I am a product manager on the Google Play for Education team. I'm excited to be here today to talk to you about Google Play for Education, what we've launched, why we launched it, and what we're launching new this summer. So just to start off, when we built Google Play for Education, we went out and we talked with a bunch of educators to really get a good sense for the challenges that they faced with deploying technology in the classroom. And what we heard from them was 4 things. First, we heard they really wanted an affordable choice of devices to use in the classroom. They wanted devices at different price points, with different sets of features, with different form factors. Second, we heard that IT departments really wanted a solution that scales. They wanted a solution that made it easy to provision tablets. They wanted a solution that made it easy to manage those tablets once they were provisioned. They wanted all this in an environment that was safe and secure for student use in the classroom. Third, educators told us that they really wanted to get tools that empowered teachers. Teachers are close to students. They see where they're struggling. They see where they're succeeding. Teachers want to be able to find the content that they need and actually manage which things go out to students. And last, we heard educators wanted a broad set of digital content available at their fingertips, ranging from apps to books to videos that they actually controlled and were able to push out to students when they needed it. So I'm going to walk through each of these areas and talk a bit about what we've done to solve some of these problems. So with Google Play for Education, we've made available a broad set of Android devices. Today, we've actually got a 7-inch Nexus tablet that's available for schools, as well as a Samsung Galaxy Tab for education. We've also announced that we're rolling out an Asus Transformer, as well as an HP Slate 8 Pro. What this means is that schools can actually choose from many different types of tablets, and when they buy one of these tablets, they know it's going to work within a classroom environment, and they know it's going to work with Google Play for Education. Once you buy one of these tablets, how do you actually get it working in a classroom environment? Many of you have set up Android tablets, and you know that it's multi-step. So you have to add a Wi-Fi configuration, you actually have to set up a username and password, you have to go and download device policy, and then you have to download apps that you want to use on your tablet. This is fine if you're setting up a couple of tablets, but once you're an IT admin that's trying to do this for 5,000 tablets across the district, it actually gets pretty cumbersome. So what we built is this device activation and setup tool. So an admin downloads this tool onto their device, and then all they need to do is NFC bump every other tablet with this admin tablet. And those tablets automatically start setting up Wi-Fi, adding a student profile with a username and password, downloading device policy, and downloading any apps that need to be pre-installed on that device. So then that tablet can be just handed to a student. So what this means is instead of taking days or weeks to set up a district of tablets, you could do that in the matter of hours. So once one of these tablets is set up, how does an educator actually find content for use on that tablet? So with Google Play for Education, what we built is a new set of search filters and browse filters that let educators find apps that align with specific subjects, that align with specific grade levels, that actually can align with specific Common Core curriculum standards as well, if applicable. And the way we do this is that we allow developers to opt into Google Play for Education, and then any app that's opted in goes to a third-party network of teachers that review the app, make sure that the app works well in a classroom environment, and assign metadata to that app that allows for us to surface that app in the right way. So for example, if a 3rd grade math teacher is looking for an app that teaches their kids how to do multiplication, they just look for math, they look for 3rd grade, and they look for a Common Core curriculum standard that's going to align with multiplication. And they're going to see every single app that exists within the Play for Education store that aligns with that. So once they found an app, how does the teacher actually get this app into the hands of the student? Obviously, a teacher can use a standard distribution mechanism of putting in a student's username and send to a student. But the cool thing that we've done is we actually made the ability to do bulk distribution by having a teacher set up Google Groups for a classroom, for an entire grade, or for subsets of a class. And then when a teacher actually provisions to one of these groups, the app is pushed out to every single student that's in the group. So a teacher could set up a group for basic math students and a group for advanced math students. Find apps that make sense for each of those sets of students, and then provision those apps directly to those students, and those apps will just show up on the students' devices. So with the apps that are getting pushed out, we've also built a broad set of management tools that really works for schools. We heard from schools that they really did not want to pay with credit cards. That just didn't work with their buying process. So we built the ability to accept purchase orders. So the way this works is a school sends Google a purchase order, Google logs that purchase order, and then schools can make purchases against that purchase order with the balance declining. And then on a monthly basis, we invoice the school so that they see how much they've spent, what they've spent it on. The cool thing about this is that this happens completely transparently to the developer. The developer doesn't have to know anything about purchase orders. They just know that they sold a certain number of apps and that they get a check in the mail. We've also built tools that allow for teachers to manage the apps that are actually present on the devices. So if a student is done with an app, a teacher is able to use Google Play for Education to remotely uninstall that app, either from a specific student or from a set of students, as well as reassign that app to another student if one student is done with it and another student needs to use it. So no digital content solution in the classroom would be complete without books. So we've actually launched a flexible rental model that has publishers, including top textbook publishers, as well as trade fiction publishers. We've also made available YouTube education videos. So YouTube has a broad set of content that's available that works great in the classroom. Using Google Play for Education, educators can actually find those YouTube EDU videos using the same search criteria that we have for apps and provision those videos to students as well. So what are we launching new? This summer, we're excited to announce that we're expanding availability of Play for Education to Chromebook schools. So for those of you that don't know, Chromebooks are doing extremely well in the classroom environment. In 2013 Q4, 25% of all EDU devices sold were Chromebooks. And over 10,000 schools are using Chromebooks today by millions of students. So this summer, admins of Chromebook schools are going to be able to enable Google Play for Education on their domains, which is going to allow educators in those domains to find the same book and video content that Android EDU schools can find, as well as find Chrome apps that are available in the education space. And all this content can be provisioned and managed using the same management tools that are available for Android schools. The last thing that we're launching this summer that we're super excited to be announcing is the ability for teachers to leave tips for other teachers. What we heard over and over again from teachers is that they want to know what's working for other teachers in the classroom. So what we're enabling now is allowing a teacher to actually leave a tip that talks about an app, what the goals were when they used it in the classroom, how they used it in the classroom. They can link to YouTube videos showing how they used it. They can link to a curriculum or a lesson plan that shows how it really worked in the classroom. So then other teachers that are actually looking for content in the classroom can go read these tips, can learn how this app worked for other teachers with similar profiles, and can really make the app shine within their classroom environment. So what's next? If you're an Android developer that's interested in participating in Google Play for Education, go to developer.android.com/edu. There you can learn more about what it takes to build an awesome K-12 app, as well as understand what the process is to opt in to have your app included in Play for Education. If you're a Chrome app developer, we're not quite ready to accept your app in Google Play for Education yet. We're launching with a small set of developers and a small set of apps, but we're going to be expanding and opening Google Play for Education up to you very soon. Go to developer.google.com/edu if you're interested in learning more about what it takes to build a cool app for the classroom environment, and fill out the form that lets us notify you when we have the opt-in process available. If you're an interested Chromebook school, please go to play.google.com/edu. You can actually opt in to start using Google Play for Education right away. And if you're a school that's interested in Android tablets, check out google.com/edu/play, and you can actually learn how to set up Android tablets within your classroom as well. Thanks a lot, and happy schooling.
Hello. That's right. Usually I say hello and you say hi, Timothy. Hello. I love that. Welcome to Wearable Computing with Google. I'm going to try that clicker one more time, and I'm going to switch to the other. Oh, something wasn't plugged in. There we are. Woo, and things work. I'm Timothy Jordan. I'm a developer advocate at Google. You can reach me online, google.com/+TimothyJordan, or on Twitter, @TimothyJordan. Now, I'm going to cover 3 topics in this session. First, what is wearable computing? And I mean more than just a device that you wear. What is it at its core? I'm going to talk about how we live in a world where users have multiple devices. They're using them at the same time, and instead of ignoring that and letting them compete for each other, how do we connect those devices together into a single, seamless experience for the user? And I have an announcement in that section I think you're going to like. And then third, how can we use Google to make this whole thing a lot simpler and yet more powerful? Sound like fun? OK. So first off, what is wearable computing? You know, I keep having these conversations with developers about cool ideas, right, that they have for new form factors and wearable computing and beyond. And although cool, they aren't necessarily great user experiences that solve real user problems. Let me give you an example, and I hear this idea all the time. In fact, a few of you probably have had this as well. Wouldn't it be cool if I walked into a conference and everybody I knew had a little thought bubble above them with their name and what they do and how I know them? It's not a great experience, and I'm going to tell you why. The user problem that you're trying to solve for is how do we connect people more deeply to those around them? And that's a great problem to solve. But in that solution, what you end up doing is distracting them and distancing them from the people around them. Now, there's another way to solve this. Right? What if the user had that information before walking into a business meeting? Right? They could have looked it up on their own. What if it was just delivered to them through their Glass or through their Android Wear device? That's a completely different experience. In fact, you can already get it on My Glass today. And what it does is it prepares that user and gives them the opportunity to connect deeply to the people around them. But the problem with the first idea is that it was built on this idea of a device. It was built on this idea of what computing is supposed to be in our future, when instead, what we should be focusing on is the user. That's the true promise of wearable computing. See, people bring technology into their lives and wear it out into the world on their adventures. And our job is to enable them to have richer experiences and be more connected to the people and world around them. Let's take a step back and examine that idea in a little bit more detail. Computers used to look like this. They filled a whole room. Shortly after that, just on your desk, and very soon after that, the palm of your hands, where you could get the full repository of human knowledge and worldwide communication just right there by reaching into your pocket. It's such a cool idea. But something that you'll notice about all of these devices is without anything else in the picture, it's hard to see the human. And one of my favorite thought experiments is by this VR pioneer, Jan Lanier. Some of you have heard this before. Just please bear with me if you have. What if aliens came to Earth, cute, fuzzy aliens, and people were nowhere to be found, and they were trying to figure out us by looking at our computers? What would they think? I mean, do we have 102 fingers and one big eye? No, we don't. Now, if you look at a hammer, it almost makes sense. You can kind of see the arm that would wield that hammer and hammer in nails. But this computer? I mean, look at the keyboard. It's not really built for us. It's not even really built to type fast. Back when the keyboard layout was designed, it was designed to keep us from typing too fast so that the type bars wouldn't get caught amongst each other and screw everything up. But this is what evolved into the modern keyboard. Now, this is a very physical difference between the person and the machine. Let's look at something that's a little less physical, but just as dangerous. What's wrong with this picture? Yeah. In many ways, this is our relationship with technology. It gives us a lot of value. However, we are adapting our lifestyle to the technology that assists us. And there's a heavy cost. And we pay it frequently. How does that make sense? What if we didn't have to? And here's a photo I took a few months ago of my team playing a word guessing game. That's Lindsay in the top center of the photo, and she's trying to describe a word given to her on glass. And what I love about this photo is that you can hardly see the technology. Some people think the future of computing is floating screens and constant digital overlay, constantly looking things up on the internet. They want to keep you immersed and keep you away from your life. But as it turns out with wearable computing, less is more. It's where we, as developers and designers, get to put the user before the technology. It's briefly there when you need it and not when you don't. It gives you what you need and you're back to your life. Now, this simple core philosophy to wearable computing is what you see over and over and over again in terms you hear throughout Google I/O, such as micro-interaction and glanceable information. And it's not new. It's the idea that success isn't measured by how long the user is engaged with the interface, but how quickly we can get them what they need and get them on their way. And there's a website that's been around for 15 years with that exact philosophy in mind. This kind of interaction is in our DNA. Back at the time when the search engine philosophy was keep the user on the page as long as possible, Google went in the opposite direction. And as it turns out, that's exactly what users wanted. It's exactly what they needed. And that's why it made sense for us to recognize this core philosophy in wearable computing as well. These devices are about that kind of experience. Now, that's not to say that desktops, laptops are going away. They're not. But those are often tools for work, whereas these are tools for life. That's what wearable computing is. Now, let's talk about connecting it all together. Remember what I said. What if the benefits of technology were available everywhere, no matter what you were doing? And this idea is bigger than just one or two devices that the user might have on them at the time. It's about all the technology that they keep in their lives. And this is what's meant by the term ubiquitous computing. And it's how we need to start thinking. It's the idea that a user starts to use a service, and it's available to them everywhere they want it to be. Now, maybe it's something as simple as an alarm clock, but it rings in whatever the context the user's in right then. And maybe it's in their pocket, or on their wrist, or eyewear, or in the living room, or in their car. And if you watch closely, this is where we as an industry of wearables is going, connecting all of these devices into a single seamless user experience across all of them. But how do we deal, as developers, with the complexity across this constellation of devices? Well, we do what any good engineer would do, and we simplify the problem. We need two major things, that's it. Platform components that make it easy, and a design pattern that simplifies the whole thing, or maybe patterns. Let's start with the platform. Now, for Glass, you've got the Mirror API, which allows you to insert timeline items and have basic user interaction. The GDK for full apps on the device with access to the hardware and advanced user interaction. On Android Wear, you can create a single app with an APK that runs on the phone and on the watch, as well as notifications going from the phone to the watch, including some enhancements. Now, I told you I had an announcement. Glass is going to support Android Wear notifications. And this includes support for enhanced notifications and stacks and pages and replies. And it's going to be available to users on a build in the next few months. Now, this is great news for developers because it lowers the barrier of entry into the wearable space. You can build rich notifications on the phone, and they're delivered to the user wherever they are, whether that's the phone, the watch, or Glass. And of course, it's great for these users. Notifications will start showing up on the wearable, and as you may know, to get this done, you don't have to do anything. They just show up. Enhanced notifications will also show on the wearable, and again, to get this done, you don't have to do anything. It just works. Now, Android Wear has a few more features for these notifications that require just a few more lines of code. And they work on Glass just as they would work on the watch with a couple differences, right? Here's stacks. On Glass, it's bundles. Here's pages. And of course, on Glass, you're going to have the read more menu item to get to those pages. And of course, replies. They'd work the way you'd expect. So that's platform, Android Wear on Glass, bringing components together to make it easy to develop across all of these devices. Now let's talk about a design platform that simplifies the whole thing. Let's go easy. Model View Controller. I'm not kidding. This is great. Now, this is a simple example of MVC. And you could use any other design pattern here, but I'm going to show you how to spread it across devices. And it's a lot easier than you might think it is. But before I get there, who here is familiar with Model View Controller? Interesting. About 50% evenly distributed. You don't clump together. That's nice. So this is the MVC you know and love. Let's throw the user in there as well. For those of you that didn't raise your hands, this is how it works. The view is what shows the user what's going on, right? That's what they see. And maybe there's a button, and the user touches that button. That triggers the controller. The controller decides what to do, and often this means mutating some amount of data in the model. And then as that model updates, the view gets that message, and it updates in response, just around in this circle. Now, the view controller part of this, that's what your device is. Right, this is your watch, or this is your glass, or this is your phone. This is any device in the user's life. They're going to have a view. We need to adapt that per device. And I'll talk more about that. But it's got to be sticky. You got to remember this part. What you design, the UI you present to the user, has got to make sense for that piece of technology that they're using. On the controller, this will be on the device. And it also is sometimes going to be spread across. And this might be in the cloud in something like App Engine, right? Where once they get a response from each device, it can hold on to that context and deliver it back to the user, or through the view, through the model. The model is the required common layer across all of these devices. In fact, there's two common layers. It's the model and the user, and they're platform agnostic, right? They can use a number of different tools to accomplish the same task. That's our goal here. And we can use this model, and maybe the controller in the cloud as well, to keep context across all of those devices and deliver it to the right device at the right time. Does that make sense? This is just the MVC paradigm, except we're stretching the model and sometimes the controller across devices. Right? So we're building a client for the phone and for the watch and for glass. But then we have this other component that's there to help all of them. And keeping that big picture in mind is what we're going to do with an example, building all of these things on top of Google technology. We're going to make a reminder app because it's simple, right? This is very simple. I didn't spend a lot of time designing these mocks, as you'll see. But the idea is just to think about how do we put these pieces together, right? Because this is the first time we're really doing it at this scale. We're going to do it on these devices. And we could, of course, add in the living room or the user's car, but we'll keep it simple for now. And these are our features. The user is going to be able to set a reminder from anywhere, right? They'll be able to receive a reminder wherever they are, and it's going to be location aware. Right? So they can set a place reminder, not just a time. Now, I'm not going to go into detail here, but let me just briefly go over these items. App Engine and Cloud Endpoints, that's what we're going to use for our cloud. Right? And there are two components that you need. Some sort of structure that you can keep a controller in then if you need to, and some sort of access to that model. That's Cloud Endpoints. I don't know if you've used them, but it's really easy to deploy endpoints right away and be able to mutate that model from any device that the user might be on. And then Android. We're going to use a lot of Android. We're going to use Android Wear, we're going to use the GDK, we're going to use geofencing, and we're going to use GCM to get information from the cloud onto the device. Now here's our diagram. I went for complex, as you can see. Again, this is a simple example, but you can simplify this kind of service across devices. We've got App Engine up at the top, and then the user might have any of those three devices in the middle, and of course they're at the bottom using them. Now this is pretty much the same diagram that I showed you earlier, right? But App Engine is the model, and then each of these devices has a view controller pair. All right, let's go through the feature set, all three of them, one by one, just to see how they're built, how these pieces are put together. To set a reminder from anywhere, we need first an app on the device to take the user input. So we'll start with the phone. And this is just going to be a basic Android app. It'll look a little something like this. I took my inspiration from the alarm clock, as you see. I can add a new reminder with a name. I can add a time for that to happen at. And of course, I save it, and now it's on the list. I forgot one of those items. Oh, well. Now, there's a number of steps involved for that, right? Because this is a phone interface. I can easily browse, and I can edit. I can do lots of things, but there's a number of steps involved in each one of those things, and that's fine. It's on our phone. But for the app on the watch and on glass, it's got to be simpler. Remember, it's a device that's micro-interaction, glanceable. I should be able to set an alarm on the go and be done. So for the watch, we're going to use a voice command. Just a simple one, OK, Google, remind me. And I speak what I want to be reminded. And for glass, OK, glass, remind me to ring my speaker notes. I did do that. And finally, we need a common place to keep all of this data. And that's the App Engine with cloud endpoints. So anytime the GDK app on Glass or the Android Wear app on the phone or on the watch get a new reminder, they're going to hit that cloud endpoint, and it's going to update our model. And then that model is going to sync down to the phone via GCM, so the phone always has the latest alarms. I'm going to see why in a moment, why it's the phone that's keeping the reminders. To receive from anywhere, we're going to use Android Wear. This is the simplest part, right? We want to let the user know of the reminder. We're going to send a notification on the phone. That's why it has all the reminders on it. And then it's going to appear on the watch or Glass, whatever the user has on them. You dismiss on any one of those devices, and it dismisses everywhere. OK, one last step, just so you know that you can add more pieces and build onto this basic functionality, is to make it location aware. So when the user sets the reminder, we can give them an option for a particular place, like remember to get the bacon salad because it was awesome next time I'm here, right? When the user sets that reminder, we'll give them that option, and then the device is going to pull GPS from somewhere. Now the watch will pull it from the phone, and from Glass, there's a location service that is actually pulling it from the phone. So the phone is going to keep the GPS. And then it's also going to hold the geofence. So when the user enters that geofence again, then again, it will send out the reminder, and it'll propagate to all the devices. What I love about this example is that each of these steps seems like they're going to be complex, but 2 slides later, it's simple. It's easy to do. We can set from anywhere by just having an APK on each one of these devices that can accept the data from the user and send it up to the cloud. We can receive that from anywhere by just sending a notification on the phone and relying on Android Wear to get that to the user. And it can be location aware by just attaching some GPS when we hit the cloud endpoint with that reminder. OK, a few things to remember, just a couple quick last notes. First off, this is important too. Right? As we just talked about building something, we spent a lot of time thinking about the design just now. We would then go into development. We always kind of hope that our time looks like this. Lots of time for development, a little bit of time for debugging at the end. You know as well as I do, it usually actually looks like this. We need a lot of time for debugging. But on wearable devices, you have a new piece of that pie, which is testing, or UX iteration. Now, you're probably doing this a lot on your applications already. But if you're not, or if you're not doing it much, for wearables, be prepared for this to be a large portion of your time. And the reason is because when you design a user interface or a service that goes across all these devices, you have an idea of how it will work. But you don't know for sure until you try it while you're walking across the street or on the weekend at your niece's birthday party. You can't just test it sitting down at your desk in the middle of the work week. And on the same note, or a similar one at least, these devices are fundamentally different in how the user uses them. That's why you have to test. You should also think ahead of time. Know that you're going to have to build a different experience. You can't just stamp out a service from the phone on Glass or on a watch and just have it work the way you want it to. You have to rethink it a little bit. What is it about the watch or the Glass that you couldn't do before that now you can, that will come alive on these new devices? Right? We did not take the launcher and just put it on the watch, a bunch of icons. That wouldn't make sense. Right? The user can ask for things, or they can be given things. The service should flow from one device to the other, because it's about the user's experience across devices, not just any one device. Because at the end of the day, we're building for people, not for technology. People out living their dreams or having adventures, and our job is to help them have those adventures only richer and more fun. OK, we have some documentation online. I hope you check it out. And of course, stay in this room and stay tuned to this channel for the next section, or next session, Designing for Wearables. I talked a lot about a rather simple example just to describe how the pieces fit together. They're going to talk more about the design of each one of those pieces to take them to the next level. Thank you very much. So I do have some time for questions, in case I answered them all, which would be OK, too. But I believe there's microphones around here. There's a microphone stand there with a droopy microphone, but it's on there. If you could go up there, that way the people watching the live stream can hear your question as well. That'd be great.
OK. Hello. If you have Google Glass and Android Wear at the same time, what the notification would behave like? So you will get pinged on both of them, or only Wear, or only Glass? How are you expecting to do that?
Yeah, it's a great question. And I think that we are all just starting to explore this area. So it's a rather simple action right now, is that if there's a notification on the phone, it gets sent to the wearable devices as well. Now, the nice thing about the wearable devices is it's a rather subtle notification that the user can easily ignore, just a buzz on the wrist or a ding on glass. And when a notification is dismissed on any of those devices, it just sort of goes away everywhere.
OK, thank you.
Question. What about group notifications? Say you go out hiking or biking on a group, and you want to notify the group of change of plans. Is there, and they're all wearing a watch, and they're, some of them ahead of the pack. Is there a group notification functionality?
I'm a little unclear what you're asking. So you're saying you have multiple users, multiple phones and Wear devices,
right,
and you want to send a notification out to all of them.
Right, and maybe they're using the same app.
Yeah, so this is a great example of using something like that distributed MVC model, only you're saving data for the group, not just the user. So that when you sync it back down to the phone via GCM, you're going to sync data from that group, and then all the phones will be able to push out the notification to that particular user.
And everybody will get it. OK, thank you.
Yeah.
Hi.
Hi.
I have a question more towards the philosophy of wearables. We design apps, and we do design a lot of apps for Android and things like that. But the problem is these apps I don't see being used by people who are physically disabled, or for example, a person who walks on the road who is blind. I don't think we are reaching to that level still. Although we have come a long way by building apps, by building the App Store, etc. Now, since we are just getting started with wearables, how do we ensure that we do build specifically for this set of people, how we as developers can contribute, and how from your side you can ensure that this thing happens and it reaches to people?
So I think what you're asking, and stay at the mic just for a moment so I can be sure about this, is it's really a distribution question. Once we build a service, and you're saying in particular services for disabled people, how do we reach that audience, right? Because you're having a challenge reaching that audience. And this isn't really a new problem, and I'm not an expert on distribution, so I don't know how much I'm going to be able to help you. But I would use your app stores, and I would evangelize with those communities.
Okay, thank you.
Thank you, team, for the presentation.
Hey, you're welcome.
So question, when we use Android Wear, we send a notification to an user, right? And they will see that notification, or they could see the notification in any device they have. What if we want to target a specific device? Like we have an app in which it doesn't make sense to send a notification to the phone, but only to the watch. And you don't want to send a notification to the glass as well.
Yeah, that's a great question. So right now, Android Wear sends the notification out to whatever wearable that the user is using. So if they're using multiple wearables, it'll go to all of them. The nice thing about the notifications is that they're relatively easy to ignore, so you can kind of just pay attention to where your attention is. However, there are ways where you can have a notification just on a device if that's really important to your service and you want to build it today. When you build, even in this example, you've got a GDK app and you've got an APK on the Android Wear app that's on the watch. And both of those can communicate to the phone and deliver notifications to the user directly rather than using the Android Wear notification service. In that case, you'd be able to choose which device you want to have the notification and which you don't.
Okay, makes sense. Second question, very quickly.
Question. Yeah, it's fine.
Sorry. So for Glass now, we have initially the Mirror API, then we have the GDK, and now, happily, we're going to have the Android Wear. So is like the 3 platforms or the 3 ways of developing apps are going to be available for Glass in the future, or should we expect to just focus on Android Wear and neglect the others, or what's going to be like the preferred way of developing for Glass?
So I will give you a general answer and a specific answer. And a general answer, this applies to this question, any other sort of what's going to happen in the future question. As a policy, I don't comment on anything that might happen in the future. So there's some difficulty there. But what I can tell you is that the engineering and design teams for both Android Wear and Glass work very closely together. And our goal is for all of this stuff to work really well together.
Thank you.
Yeah.
What happens with persistent notifications on Wear? Like, say, for instance, you have a battery notifier in your notification bar, or some weather apps have weather, or what have you?
You know, I don't know the answer to that offhand. There is a more deeply technical session on Android Wear where you could ask some specific questions like that tomorrow. Android Wear from the developer's perspective. Or if you ask me online later, I'll look up the answer for you.
Thanks.
Yeah.
Beyond the basic interface, what kind of opportunities will there be to fully customize the screen for wearables?
That's a great question. So again, in this example, it was simple, right? However, the GDK app and again, the APK on the Android Wear app for the watch are both code running on the device, and both allow you to do full screen UIs that are fully custom.
Okay. The new devices for Android Wear, they introduce new possibilities of interaction. So do you have anything regarding gesture recognition? So like, let's say, recognizing the user is looking at the watch or something of that sort, like lifting the arm and looking at it, or doing other type of gestures with the hand. Is that something that...
So there is some of that built in, and as you heard in the keynote earlier, that most of the APIs in Android are also available for the app that you build that runs on the wearable. So there's a lot of that stuff that you can do already. But stay tuned for some more examples where we can examine that in more detail.
Thanks.
So sort of expanding on that point, how do you see gestures and voice recognition working together or commingling in sort of a unified experience?
Well, that's a great question as well. It's interesting that, and you should definitely stay for the designing section next, so they'll go in a little bit more detail about this, right? Different situations work well for each of those instances. Sometimes just being able to say something really quick, like remind me to, makes sense. Like trying to input that through a gesture wouldn't make sense. Right. But then on the other hand, you'll notice when you get a phone call, just swiping across the screen is really the right thing to do for a watch, right? Yeah. On Glass, you can do it through a gesture or through voice. So in many ways, you're giving the user the option, and in other cases, there is sort of a clear winner. There are sort of gotchas in each case, right? So for example, if you're using head gestures and the user happens to be walking somewhere, there's certain head gestures that work better than others. So for example, looking up and then looking down works pretty good. Like trying to scroll a list or scroll a list horizontally would be more difficult. So those are the kinds of things you need to think about. But all of those will become apparent as soon as you test it in different situations.
And do you see any implication or expansion to context-aware gestures? So you have essentially a gesture set to your specific location or in your environment, so that those similar movements mean different things in different scenarios or spaces.
I think that sounds very cool, and that you should definitely explore that with the platform.
Okay, yeah, come talk to me after.
Hi, Timothy. Great talk. Very excited about Android Wear coming to Glass. So a question. Up to this point, the timeline has sort of been a chronology. And sort of the cards that are to the left of the home screen have sort of been up-and-coming things. So Android Wear notifications, at least how they've been shown on watches, is kind of things that kind of you see once and then dismiss, which is a little different than the current paradigm for Glass timeline cards. They don't really get dismiss unless you actually go through and delete them. So I guess I'm kind of wondering, is this sort of changing the purpose of the timeline in a way? Or how do you see that changing or being the same in terms of the interaction with these cards?
Yeah. So I'm going to give you that sort of same general answer before, but again, two more specific ones. General, like I can't really talk about how this is going to change in the future. A specific one is, the 4 guys are going to be on the stage in the next session. They're designers from teams of both Android Wear and Glass. They might have some more insight. Another specific answer I'll give you is that when you do get an Android Wear notification on Glass, it will always include a dismiss menu item.
Okay, great, thanks.
Yeah.
Hi, Timothy. I had a question. You were talking about the kind of maintaining a similar experience across different types of wearable devices. And so, with Glass and upcoming with Wear, we're working with both gestures and voice control. Do you see in the future with the new wearable devices, those kind of remaining the predominant form of interaction with your device? Or do you see maybe in the future we might have different ways of interacting or focusing around the same thing?
Yeah, I mean, if I'm doing the hand wavy, what do I think wearable computing is all about? I think all those things are important. I also think context is really important, where the user is, what they're doing right now, what they're doing next, and sometimes almost as important as when they invoke a voice command.
Sure. All right. Thank you very much.
Welcome.
So after Google Glass supports Android Wear notification, is Mirror API still supported? And do you think they conflict, or is it still useful?
I don't think any of these things conflict. We're one big happy family. Mirror API is certainly alive and well, and there's glassware that I'm running today that use it that I think are great for it. So for example, New York Times uses the Mirror API, so does CNN. And just for sending a timeline item to Glass, it's really a stellar experience. How this stuff evolves over time, again, I can't really speak to the future, but we're always going to want to make this stuff work better and better with each other.
Thank you very much.
Yeah.
Hi, Tim. First of all, awesome session.
Thank you.
So there are 2 questions, actually. The first one is the app discovery in the wearable. So like right now in any phone, we go and have the grids of apps. So would the app discovery be more context aware, or user can just still go through maybe smaller grids or different stuff of app discovery in the wearable?
It's a really great question. And you saw that slide where I had sort of the launcher on the phone and the launcher on the watch.
Yeah.
That doesn't make sense.
That's true.
And both the Glass UX team and the Android Wear team went away from the launcher, right? Sort of like this post-grid philosophy, if you will, no grid of icons. When the user wants to do something, when they want to start an action, they use a voice command. Right, or they select that command from the voice command touch menu. And they're sort of given contextually aware cards about information that makes sense to them then and at that moment. So you're exactly right that the launcher is going away, and the base philosophy in there is that what if we could reduce almost to nothing the time between intent and action? A launcher implies I take out something, I look through stuff, and I pick one. Whereas when I say, OK, Glass, get directions to the Museum of Modern Art, it's done.
Right. So, I mean, the reason of that question was sometimes, even on mobile, you have so many of apps. So at one point, there would be in glassware too, user would have too many things that they think useful at times, but they tend to forget that, was it already there? So every time giving a single command and browsing through, it's kind of pain.
Well, and that's, of course, against that philosophy that I was talking about earlier, which is, what if we can make all this simpler? What if we could give the user all the value from technology, but with none of the fuss? So I don't think our goal is to fill the watch with lots of different things that they may someday want to do, but to give them the experiences that they need to do today.
Cool, thanks. Yeah. And the second question is, for now, it's more adding to the design questions previous folks had, is that there are guidelines for Android app design, like navbar and six-pack designs and stuff. So is Android going to come up with the suggested design? And there are, of course, anti-design patterns. So are there any design patterns to look forward for the wearables, or like as of now, developers kind of and designer have to figure it out?
There are design guidelines available for both Glass and Android Wear, and you'll find that they're very similar. And they give you a lot of information, in fact, a very clear roadmap of where to go with your design. So I'd look for that on both the developer documentation for each of those. In fact, let me go back one slide just so you can remember what those URLs are. If you add a /design, I think, to either one of these, but I know for Glass, it'll take you to the design page.
Awesome, awesome. Well, thanks a lot.
You're welcome.
So I could imagine many apps wanting to implement wearable notifications. Is there going to be a central place that a user can subscribe and unsubscribe to notifications, or is it on a per app basis? And is there any way to prioritize notifications so that they get the most important ones first?
So what will be available when you get your Android Wear device up and running is that when you have the companion app on the phone, you can choose any application that you want to mute. There's certainly a lot further we could go with there. We'll just have to see what the future holds.
Thank you.
Yeah.
Hi. Based on your example for the reminder stuff, if I don't have the phone with me, will it be able to create an application that uses only the wearable device that holds information in it and present or communicate even with other devices than the phone?
Yeah, that's a good question. So for the Android Wear notifications, that requires the phone, because that's
Yeah,
where the notifications are coming from. But if you have the Android Wear app, right, which is an APK on the phone and an APK on the watch, that would work on the watch even in absence of the phone.
And
right, and you'd want to build your service in such a way that like you'd still have that capability if you wanted it.
And like connect the watch with other devices other than the phone?
I don't know that offhand. You'll have to stay tuned for that.
Thanks.
Yeah.
So from a user's perspective, it seems like there's a lot of overlap and redundancy in functionality between Glass devices and the Android Wear devices that we've seen so far. Is the expectation that the user is typically going to have one or the other, or do we expect both of them to kind of work together in a lot of cases?
Gosh, I don't know. You know, I mean, we do a lot of building these things for users, but then we get to learn how they're going to use them when they actually get their hands on them. So we're going to have to find out. I think with wearable technology, one of the things that we start to learn is once you do sort of put the human in that picture, right, there's a lot of personal preferences involved. Right? So we're just going to have to see how that plays out.
Thank you.
Yeah.
I have two quick questions. The first, you had talked about apps on the wearable communicating with the phone. And there is apparently structures for that in Android Wear. There's nothing like that on Glass at the moment. Can we expect or request that sort of a data interchange platform?
So there is a way for you to exchange data over Bluetooth between Glass and the phone.
But you have to roll your own, basically.
Yeah, it's not simple.
Right.
As far as a feature that we'd release in the future, of course, again, I can't like comment on that.
Okay.
But I can say that I've heard this feedback, and I definitely appreciate the feedback. Thank you.
Second, very quick question. What happened to your hat?
I left it.
Okay. I can't be the only one wondering.
Thanks. Some days are hat days, and some days are hatless days, I suppose.
Thank you.
Yeah. Thank you.
Notifications with media style allow you to like play and pause things through notifications like in an app, right? I was curious, is there any limitation within the API or anything that stops you from building buttons that do other things?
That's a great question. I don't know the answer offhand. I'm sorry. What I can tell you is that when you play or pause, you have that notification on your phone, it automatically just shows up that way on the Wear device. So if there is a way, then that likely would as well.
Okay, thanks.
Is there a left eye version of the Google Glass for people who are weak in the right eye?
And this is the last question that we have. No, Glass is only available on the right eye version.
Okay. And there is another question is, I don't want to carry my phone around everywhere.
What's that?
I don't want to carry the phone, the Android phone everywhere.
Okay.
I just want to carry my watch and probably the Google Glass.
Okay.
Because, so is there a way things can work with just these two?
Well, both those devices still work in absence of a phone. What doesn't work is the notification service, which is relaying from the phone to those devices. So when the phone's not around, it of course won't do that. But again, remember that on both these devices, you can put APKs on them that can run code on that device and work in an offline mode. So for example, with Glass, one of my favorite glassware is Word Lens. and it does like translations right in front of you, right, of whatever you're looking at. And that works without an internet connection and without the phone being present.
Okay, thank you.
You're welcome. Thank you all so much for coming. I really appreciate it.
Hey guys, I'm Eric Beitelman. I'm a staff developer relations engineer working on Polymer at Google. So in this video, I'm going to talk to you about how you can use Polymer and web components to interact with some of Google's most popular APIs and services just by writing a little bit of HTML. You know, the other day I was thinking, how many APIs does Google have? Do you know? I actually didn't. I had to do my research on this one. So it's over 250 APIs, things like Google Maps and Google Drive, spreadsheets, calendar, analytics, you name it, Google's probably got it. And of course, we all know that creating complex web applications requires you to interact with APIs and services. So on the Polymer team, we've been thinking about this a little bit. How do you combine Google's awesomeness with the world of web components? We really want to make working with web components as easy as writing a little bit of HTML. That's really the power of web components. And it turns out they're a great delivery vehicle for wrapping existing content, libraries, and services. Think of it as a way to declaratively provide a declarative surface area for the API that exists. This is really where Polymer comes in. For those that don't know, Polymer is a bleeding-edge technology. It's a library built for the web and allows you to create web applications based on web components. But to me, what Polymer really does is provide a thin layer of opinionated layer on top of the web component APIs. So we built in things like data binding, property observation, gesture support, mobile support. These are really important when you're building applications. We want to make it easier for you to ramp up and use. So we built that into Polymer itself. You know, a popular API is something like Google Maps. It's very complex, it's very rich. So let's take a look at how web components can actually make your life easier using that API. This is Google Maps Hello World, right? It's pretty simple, but there's a little bit of boilerplate code that you have to write every time you want to render just a map to your page. You have to know to style it using a little bit of CSS. You have to know that there's a container div that you need to create. You have to load the library. You have to remember that. You have to work with loading and callbacks and write a little bit of JavaScript. Point is, there's a lot of process you have to go through to get this thing kicking. So let's see what we can do with web components. In the world of web components, this is the Google Maps API. It's a single tag you declare on your page. That's ridiculous. Ridiculously awesome. You declare it and you're off to the races. And it does exactly what you expect, which is render a map to your page. It's simple, it's declarative, it's intuitive. I don't have to write JavaScript code. I don't have to know about callbacks. I don't have to read API documentation. You get my point. You just use this thing and it works. But Google Maps, right, is an extremely complex API. So instead of writing JavaScript, what we can do in the world of web components is expose attributes on this element for people to configure the different properties and methods that the API exposes. So for instance, really common thing to do, latitude and longitude, set the center of the map. We can do that now using that latitude and longitude attributes. We can also set the zoom level of this map just by setting the zoom attribute to 15. That's really awesome. Again, it's all declarative and super intuitive. You can read this code and know what's going on. And adding markers is just as easy. It's just as declarative. So we can drop in a bunch of Google Map marker elements inside of the Google Map tag itself and compose these in different ways. The fact that the marker tag is in the map is significant. It knows to render that marker to the page. I'm also reusing other parts of the platform here. So you notice I didn't reinvent the wheel for the title attribute, or I didn't reinvent the wheel for the drag and drop API. I'm using the draggable true attribute. So again, I can reuse parts of the web platform that already exist. I don't have to reinvent that wheel every time I start a new project. That's cool. The other thing I really love about this element is that it makes some of the API complexity go away. So one thing that's really common to do in the world of maps is center your map inside of the viewport of all the markers that contained inside of it, right? Make sure they're available to the users at all times. That's a little bit of boilerplate code, a little bit of JavaScript that you have to know how to write every time you want to do that. You add a new marker, you want to update the map. Instead, what we can do in the world of web components is, again, expose another attribute, this fit to markers attribute. So as long as I have that on my marker tag, my map tag, boom, the map just updates itself. It knows to set the zoom property accordingly. That's Google Maps. It's super declarative, super easy to use. But you can imagine a ton of other use cases here for all the APIs Google has, whether it's working with charts or spreadsheets, analytics. Anything can be a web component. We can provide a declarative surface for people to tap into that. And that's exactly what we've done. So we've been experimenting with this over on GitHub. If you want to check it out, Google Web Components is the GitHub organization. We have a growing collection of awesome components there things for analytics and maps, you saw, Google Spreadsheets. We also have base components for doing more low-level things, working with the libraries that Google has, doing OAuth 2. God knows that is very complex. So just like maps, these are super declarative, super easy to use. Check them out. If anything is missing, let us know. We're really interested in getting your feedback, getting pull requests, and adding new APIs and services all the time. So actually, let's use this. Let's combine proof in the pudding, create an application that uses Google Maps and Google Spreadsheets. We'll create a Polymer element that wraps all that together, and users can use that element inside of their own applications. Oh yeah, I almost forgot. We're not going to write any JavaScript to do this. We're just going to write a little bit of HTML. So if you're curious, this data is going to be coming from a Google spreadsheet. This is what the data actually looks like. Essentially, it's just a list of businesses in Portland, Oregon, right? There's a little bit of metadata, but the most important thing here is that we have the latitude and longitude columns. This is the data that's going to render those marker objects. So the first thing we do, we got to bring this stuff locally into our app. We're going to use Bower to install it. We're going to Bower install the Google Map tag, and then you see the example here, which we've already seen, so let's move on. What you haven't seen is the Google Sheets tag. This is an element for working with Google Spreadsheets. We're also going to Bower install that, bring it in locally to our application. And the second example here is how you actually use this element. So again, it's super declarative. I declare Google Sheets, and boom, I'm off to the races. It's got a publish property, which essentially means, hey, this data is being published publicly. Don't worry about doing authentication, it's just there. GID corresponds to the tab in the spreadsheet that I want to interact with. So GID 0, first tab. And the last thing we're doing is providing a spreadsheet key. And you see the example here. Where you actually get the key is in the URL bar when viewing this spreadsheet in Google Docs. So it's super easy to use. And the last step, if you're outside of Polymer, you just have to write a little bit of JavaScript to maybe listen for the event that this element fires and then react accordingly. So in this case, we can print out the data that the spreadsheet returned. But it's really that easy. Declare, go. So now that we have those dependencies installed, right, Google Maps and Sheets, let's actually use them. Let's create a Polymer element that wraps that functionality together. This is the entirety of the application. Let's walk through these pieces. So the first thing, now that we have the dependencies installed, you want to list them at the top of your file. So this is using HTML imports, which is one of the web component APIs. We're going to list Polymer as a dependency, the Google Sheets as a dependency, and Google Maps as a dependency, now that they're in our application. The second thing we're going to do is create a Polymer element. So this is using Polymer's declarative sugaring to do this. The name of the tag we're going to create is map-sheets. This is what somebody's actually going to declare on their page when they use our stuff. The second thing you see here is this no-script attribute. That's essentially just a hint to Polymer to say, hey, I'm not going to add any properties, any methods to this. It's just going to be a little bit of markup that we're essentially repackaging for users. So it's a pretty simple element. Inside the elements template, you're going to drop in that Google Sheets component. This is what's going to talk to our spreadsheet. You can see I got the key there. I got that publish attribute, and we're data binding to the rows attribute that this thing has on it. More on that in just a second. Right below it, we have the Google Map Sheet. This is your friendly tag that we already know about. Notice that we're using that fit to markers attribute that we talked about before. So again, anytime I have extra markers being rendered in this map, it's just going to know to set the zoom level to the appropriate level. Lastly, what we're doing is we're using Polymer's declarative data binding features to declaratively loop over the row data returned in the spreadsheet. So again, I'm not writing any JavaScript code to wire this stuff up. I'm literally just declaring a template, looping over the data, and stamping out Google Map marker children. And of course, we're data binding that latitude and longitude property to the particular cell that we're interested in. So again, it's all super declarative, and the surface area is just using HTML attributes. So that's the entirety of the application. If somebody wants to use this, it's just a matter of bringing in platform.js, right? These are the polyfills that actually allow you to use this stuff in browsers that don't support the native APIs. Check. You want to declare the Google Maps sheet as an HTML import. That's going to bring in the element we just created. Check. The last thing you want to do is just declare the Map Sheets tag on your page. And of course, what people get is this beautiful map, marker data, all powered by Google Spreadsheets. We didn't write any code to do it. We used Polymer web components. That's the bee's knees. So if you want to see a live demo of this, go check it out. It's at googlewebcomponents.github.io. We have this demo as well as a ton of other demos for all the other components we've created. So that's a small taste, just a small taste of what Polymer and web components can do. I really think web components are going to unlock a fundamentally new way to program for the web. You've already seen it's productive, it's declarative, it's reusable, and you can vastly reduce the amount of code you write as a front-end developer. That's really, really awesome. So if you want to know more about creating applications using Polymer, do check out Rob Dotson's video and Eddie Osmani's video. These are a couple of stellar guys with some really, really great content. Check us out on polymer-project.org. This is our website, powered by Polymer, of course. And follow us on Twitter at Polymer. You can also feel free to hit me up anytime, ask questions. I'm always on Twitter. I'm on Google+. Oh yeah, one last thing. Go componentize the web, guys. Thanks for watching.
Hi, I'm Justin, a product manager in Google Search. In the next few minutes, I'll show you an easy new way for event organizers, performers, venues, and ticket sellers to promote their events in Google Search through the Knowledge Graph. The Knowledge Graph is Google's system for organizing information about millions of well-known people, places, and things in the real world. The better we understand these things, the better we can understand what web pages are really talking about and what users are really searching for. The information in the Knowledge Graph comes from lots of sources like Wikipedia, Google Maps, the FDA for drug data, MusicBrainz for album data, and so on. But in the case of events, we think the best source of event information is the event organizers themselves. For example, when people ask about Keith Urban's upcoming concert dates, we'd like to give them an authoritative answer from Keith himself or from his official website. Likewise, when people search for what's going on at a local venue, whether that's a music club, a stadium, a theater, or the local library, we think that venue's website is the best source of answers. So that's the basis for our new approach to events in Google Search. We're asking event organizers to take charge of their own events in the Knowledge Graph by adding structured data markup to their official websites. Google can then read this markup as it crawls the web, add it to the Knowledge Graph, and show it to users in search. So I'm going to show you how easy it is to add that markup thanks to the new JSON LD format. But before I get to the technical details, let's take a quick peek at one way events from the Knowledge Graph show up in search. We'll start with a song someone told me about. It's called Alligator Strut. All right, I'm going to Google that song, and I learn it's by Anton Schwartz. Who's he? All right, he's a saxophonist, got a few albums out, he's well educated, and he's got upcoming events. Let's take a look at those. All right, here's a nice rich list of events that I can swipe through. I can discover one near me. When I click on it, I get more details, including a map, and I get the ability to click right through to his official website where I can get all the details. Let's learn about this event. Right on with the Boston Symphony. I'm getting a ticket. All right. And that's just one example of how the Knowledge Graph helps people discover events. In addition, the Knowledge Graph powers event-rich snippets in search results, it powers event listings in Google Maps, and it powers notifications in Google Now to automatically inform people of interesting nearby events and when their favorite bands are coming to town. So again, to be eligible for all these cool features, event organizers have to mark up their websites. We pay special attention to data on the official websites of touring performers, like musical artists and comedians, to venues' official websites, and soon to the official websites of annual events like festivals and conferences. Finally, for any event where tickets are sold, we'll also look to the primary ticketer's official website for ticketing details. So, our request for markup on all of these websites is the same. Use the schema.org vocabulary to label the key properties of each event. Schema.org is just a set of standard property names for structured data agreed upon by the major search engines. When Google processes a web page, it can recognize schema.org properties in several different markup formats, including microdata and RDFA. However, in this talk, I'm going to tell you about a new format, JSON-LD. Unlike the other formats, JSON-LD doesn't require you to interleave your structured data with the HTML displayed content. That makes it the most developer-friendly format yet, and Google is embracing it. All right, let's take a closer look. Here's what JSON-LD looks like when embedded in a web page. in this case Keith Urban's tour page. As you can see, it's just a block of JSON data. The JSON keys highlighted in yellow, like start date and location, are schema.org property names. The whole JSON block should be wrapped in a script tag, and then you can insert it anywhere in the web page, either the head or the body. Okay, let's go through some of the interesting properties here. First, the @type. You should use the most specific subtype of event that applies to your event. Popular subtypes include comedy event, festival, food event, music event, theater event, and sports event. This helps search engines categorize your event, and in some cases lets you specify extra fields relevant to that type of event, such as home team and away team on a sports event. Next, the start date. This needs to be in ISO 8601 format. The time is included in the field, and it's assumed to be in the local time zone of the event location. If the event has a definite ending time, you can specify that using a separate end date property. Next, location. The value of this property is a nested sub-object of type place. In our experience, this type of hierarchical data nesting was really easy for developers to mess up in the microdata or RDFA format. But in JSON-LD, it's very natural. You can see that the place sub-object should have a name property, that's the name of the venue, and an address property. The address can be given as a single string, which Google is good at picking apart, or as a set of individual fields in another nested sub-object of type postal address. There's another interesting property on the place here, same as fiddlersgreenamp.com. This property is designed to help you connect your data to the knowledge graph. The value of the same as property should be a URL that unambiguously indicates the item's identity. For example, the venue's Wikipedia page, Freebase page, or official homepage. In this case, the homepage of Fiddler's Green Amphitheater is provided, which helps Google understand that Fiddler's Green refers to the amphitheater in Colorado, not to the mythical location in the afterlife where fiddlers fiddle and dancers dance for all eternity. So, moving back to the code, we're up to the event's performer markup. Again, note the same as link, this time to a Wikipedia page, ensuring that Google can understand exactly which real-world artist is performing at the event. The same as URLs, by the way, don't have to appear in the user visible portion of the web page. They're only a hint to search engines about how to understand the user visible text. If there are multiple performers at the event, great. Use a JSON array to list all of them.
Hello. Hi, I'm Hayes Raffle. I'm here today with three colleagues I've been working with for a long time. Bob Rice-Camp, Emmett Connolly, and Alex Fabord. Actually, the four of us go back a long time in different ways. Alex and I were at the MIT Media Lab together about 10 years ago. And Bob and Emmett were on the watch design team, I think about 3 years ago, doing the very early design iterations of Android Wear. And now Alex and Emmett work together on the Wear team, and Bob and I have been working on Glass for about 3 years. And you guys are sort of getting 4 for the price of 1 today. We're here to share with you some of the things that we've learned along the way. Because over the last 3 or 4 years, we've been finding our way through this new space of wearables and trying to understand what it means, what works, and what direction it makes sense to go in this new space. And so I wanted to start with a little bit of philosophy, some of the things that we've found useful as we've worked through this space. And a couple of things that have been most helpful for me are some of the things that Sergey and Larry have talked about over the years. Larry talks about how technology should do the hard work, and you should have a chance to live, have a good life, and get on with it. And that's great, and you see that in products like Google Search that try and get you what you need and get out of the way as fast as possible. And Sergey talks about how computing needs to be more comfortable. And on their surface, these might actually seem like different statements. One is about form, the other one's about function. But they're really the same idea, and the idea is that computing should start to disappear. It should fade into the background of our lives. It should be ephemeral, not the foreground of our attention all the time. Because life is beautiful. It's full of beautiful people and puppies and sunsets and things that are just really lovely. And computing shouldn't be taking us away from that. It should be helping to bring us closer to it, if anything. And so one of the phrases that we use a lot when we're doing design is we talk about the world being the experience. The user experience, the experience with a product, could never possibly compete with the beautiful things around you. At best, it can provide timely information and help and things that can help you be connected to others and be connected to the moment that you're in. And you see that in lots of aspects of the design of the products that we're building. You see it in the placement of the glass display. It's not in front of you. It's off on the periphery. You see that even in the font weights. Very thin, light strokes with a black background, which shows up as transparent on the glass display. You see that in some of the use cases. Some of my favorites, this one of Sebastian Thrun swinging his son around in a circle right after we got the camera working on glass a couple years ago, and showing how technology could really help transport us into that moment of joy that he was having with his 3-year-old. This is what it means when we say the world is the experience. And now my background actually is in fine art. And the thing that I care most about when I do my work is creating a sense of empathy between people, getting people closer together. Because while we talk so much at Google about the user experience and designing for the user, none of us live in isolation. We live in a world surrounded by people that we care about. And how can technology help to bring us closer to others? And I want to show you a couple examples that I think are starting to get in that direction. This is a picture of a journalist named Tim Pool. Tim works for Vice magazine. And about a year ago, he was in the streets of Istanbul documenting the riots that were happening there and broadcasting live from glass to a huge viewer base that he has. And Tim's been doing this for a long time with cameras on his shoulder, with his cell phone, now with glass. And I think for me, the transformative thing that's happening is that glass is allowing him to interview people in a more intimate way. When he talks to people in the street and with glass, they're not talking to his camera, they're talking to him. And what that means is that when you're watching that broadcast from far away and trying to understand what's happening in Istanbul, you're that much closer to the action, you're that much closer to the way that people are feeling in the streets there. There's another thing that we think a lot about with wearables and this idea of being connected. Wearables themselves are very, very intimate. You're wearing them on your body. In fact, these glasses are so specially designed for me. If you put them on, you probably can't see them because I have my prescription on them. They're very hard to share. And on the same token, the way that we design the experience for wearables needs to be very personal. It needs to reflect the things about me as the wearer that I find important. It needs to be about the closest people, the people that I care about who are close both in time and in space, whether it's my family or you who are in this room with me right now. It's about surfacing the information from the people you care about in a way that feels personal to you. It's about being able to bring your niece to her grandmother's birthday party to see 100 candles get blown out, even if she couldn't be there in person. Again, this is what we mean by the world is the experience. Now, one of the tactics that we talk about, like how do you do this? And we're going to talk about some different ways today, but the first one that I want to talk about is called micro-interactions. And the idea with micro-interactions is that wearables are on the periphery. You're not designing the windshield. You're designing what goes in the rear view mirror. Because whatever is happening in front of the user in their life is going to be demanding, it's going to be happening fast, and it's going to need most of their attention. And whatever you're giving them needs to be very glanceable. And this idea of glanceability is really about getting to the essence of the information that that person needs in the time and the place that they are. And so what does that mean in how you design software? Well, if you look at driving directions on glass, when you ask for directions, for the most part, the screen is turned off. But before you have to turn, it'll turn on and tell you, turn right on Greenwich Avenue in 100 feet, show you a map of where you need to go, and then after you've completed the turn, disappear again. This is glanceable. This is what it means to be the rear view mirror, not the windshield. It means when you're designing a messaging app for the watch, how minimal can you make it? What is the simplest amount of information that the user needs to get their task completed? Here's two designs. And the big difference between them is that one of them has twice as much information as the other one. On the left, 6 pieces of information for a user to look at. On the right, only 3. That difference is about 900 milliseconds of attention for someone who's focused. Now, 900 milliseconds, why would you care about that? Well, you have to remember, this person's wearing it on their wrist. They might be running to the next meeting. Which one of these would you rather have if you're running to the next session in room 7? We've even played around with, could we put an emulator like this into the developer tools so that you could play with this? But I think the real idea, and Timothy mentioned it earlier, is that none of this stuff is particularly intuitive. It's taken us a long time to get to where we're at today, and there's certainly a long way to go still. And the way that we make progress is by continually testing on the device in the context where we mean to use these things. This is sort of a paradigm shift, I think, because if you look at the way that people use their phones today, people get out their phone, and then they do their task, and then they get distracted by a lot of other things that are there. They get lost in their phone, and they are taken out of the world. And what we're trying to do with wearables is actually get to a place where people have the same utility and benefit from computing, but there's actually less computing in their life, because we've designed experiences for them that are much more compact, so they can get in and out, get their goal completed. Put another way, I think our job now as designers and developers is to create experiences that are as short as possible, as fast as possible, to complete the task that the user needs to do. So we're going to talk more about different strategies that we've developed and ideas we have to do that. And I want to turn over the stage now to Bob, who's going to talk about some of the things he's learned about voice. Bob's been wearing computers since they weren't quite so wearable, and so he has a lot of perspective on it.
Thanks, Hayes. So ever since the bike helmet days, we've been designing our wearable products to help you be more engaged with the real world. And one way that we've done that is through creating natural language voice interfaces for our products. We've tried a lot of different interaction techniques for wear and for glass. And one thing we found is that when you can speak naturally to a device, just like you and I could talk, it makes your interactions much faster. It makes it much easier to stay connected to the people you're with and the places you're in. And for wearables, this is even more important than for some other devices. For instance, Hayes and I both love to go cycling, and this is a fantastic place in the world to go cycling. It's a sport that's all about the outdoors, but it's also got a bunch of just amazing technology that you can really get into. And it's an example of an activity where, like Hayes said, the world is the experience, and it's very, very important to pay attention to it. And I also love my phone. But that same gorgeous phone interface that works so well when I'm sitting and standing doesn't work as well when I'm active. Maybe my hands are sweaty, I'm trying to ride at the same time, trying to hit those small icons on a screen. Maybe the sun is causing some glare. So we felt that glass and wearables could be great to use while cycling. You can keep your hands on the handlebars, you can keep your eyes on the road, it works with your voice. But when we first started designing interfaces for glass, we tried to use a lot of the same interaction and visual design patterns that we knew from designing for phones and desktops. We had a screen, we put it roughly in the middle of your perspective. You'd first try to choose an app to run. And then you'd select a few features. You'd choose an option. And maybe finally you could view individual items. You could input some information. And with all of those steps, we found that we weren't really getting a different experience from the phone. You still have to think about what's the structure of my operating system, and what features does each app have, and where do I input those information into those fields. Now, this is a very powerful system, which is why we use it on desktops and phones. But it didn't feel appropriate for a wearable device. And when you step back and think about it, when you're engaged with the real world, your interactions aren't like that. If you're cycling with a group of friends, you're not opening menu options and clicking buttons. You're looking at people and you're talking to them. You're seeing things, you point at them, you reach for things and hold them. You know, these are all very natural interactions. You don't need a manual to tell you how to do them. And so we wanted, as much as possible, to make our experiences on wearables more like that. For instance, we designed the messaging experience on Glass to be as close as possible to the way you'd talk to a close friend. OK, Glass, send a message to Jane Williams. Hey, Jane, it's great to see you today. You know, we even show a photo of the person in the background while you're talking. Overall, we wanted to make it feel like that face-to-face conversation, except now you could do it across time and space. Now, this cuts out a whole bunch of the decisions and steps required to do that same action on a phone or a desktop. And it turns out to be tremendously faster than pulling your phone out and manipulating all those options. That's because when we designed the messaging glassware, we chose just a single experience, sending one message to a single contact. And we designed a unique voice command and a unique flow for just that experience. Now, if you want to look at an older message, or you want to edit your contacts, you want to do any of the other things you think of belong in a messaging application, you can do those in other ways, in other places. But this experience is very singular and very focused. You do just one thing at a time, and you see just one thing at a time. And with Android Wear, we wanted to bring that same kind of experience to a lot more devices. As you saw in today's keynote, if you have a car service or ride-sharing application installed, you can simply speak a command. OK, Google, call me a car. You know, it's a simple natural language command. It instantly gets a car headed your way. Again, it's almost like you're able to talk across the city directly to the driver. So one thing you can do to make your wearable interface more natural is to carefully design that voice experience. You know, don't just port over the structure of your app from your mobile device or your desktop. Think very carefully about what's that individual short experience that people want to have, and break up that big app into individual flows. And then you can design and craft one single voice action just for that flow and just get that person that perfect experience. And make that as much like normal speech as possible. We believe that natural language speech, when it's connected to all the amazing services that all of you are building, is going to make interacting with wearables even easier and faster than using phones and desktops. But you know, this example of calling for a car also does something else to improve the experience, and that's use knowledge about your context and where you are. So I'll next hand over to Emmett, who is one of the founding designers of the Wear project, and he'll walk you through how we've been designing using context. Emmett and I worked in Zurich together while he was working on some of these early ideas, so I got to see all of his crazy, embarrassing early prototypes as well.
Hi, everyone. So Bob talked about how speaking a command can be one of the fastest and easiest ways of actually performing an action. And I'm going to talk about one way that's potentially even faster than that, and that's to not even speak a command at all. To just have the right information appear automatically based solely on the context that the user is in. So let's rewind for a minute. This is a wooden prototype of the Palm Pilot that Jeff Hawkins made when they were first designing and developing it, one of the first portable computers. It's a little stylus, chopstick stylus there. I love that. So before they ever started building anything, Jeff used to carry this around with him every day. And if someone said to him, hey, are you free at 3 o'clock today or whatever, he would pull out his little wooden computer and tap away on it with his chopstick and pretend to actually check if he was free. He would do this every day for months, and what he was actually doing was trying to figure out what it was like to use a device like this, a new type of device at the time, on a day-to-day basis and in a regular day-to-day context. He was trying to figure out what kind of UI might feel right for this new form factor. And in retrospect, he was trying to avoid a common mistake. It seems like that very often when these new devices come along, the general reaction seems to be to take the dominant paradigm, UI paradigm of the day and just slap it on these new devices. And the truth is that never really works out all that well. You have these new types of devices, and they're often really begging for some new interface ideas. And to a certain extent, we've seen this play out with the early wearables market as well. A lot of these devices are really just taking the grid of apps and putting it on this tiny screen. And again, we see that this doesn't often really work out so well. To start with, these are really tiny tap targets, and so especially on a moving target, it's hard to hit. You can't see very many of these icons at once, so it's hard to build up a spatial memory of even where everything is located. And it can just take a lot of swiping to go through all these screens and actually access what it is that you're trying to access to even start with your action. So we took a step back from this and we tried to think about what if we didn't require any input at all, that we just had the right information show up at the right time. And this is what we came up with. So some of you noticed the subtle detail in this photograph. Yes, it's just a phone strapped to a wrist. Well done. But there is something interesting happening here. This is an actual prototype that we built. And there's no grid of apps here. There's just one simple, clear piece of information showing up at a time. And if another piece of information comes along, and that's more important for the user to know about, then we'll show that instead. So we kept thinking about this. We thought, what if there's more than one piece of information that's useful to know about? Maybe we could arrange these simple screens as a row or as a group of cards, and you could just rank them and have the most important stuff appear at the top. And you see this thinking today reflected in the philosophy of the Android Wear UI and also of the Glass UI. In both devices, there's just this targeted, relevant piece of information. And in both devices, the way that you interact with them is the same. You're just swiping through this really clear stream of cards. And it feels like roughly the right level of interaction for these devices in terms of the ergonomics, visually how they appear, and just the overall interaction. So that's kind of a nice UI model for wearables, but we still have this problem of how do we know when to show the right piece of information? When do we put this information in front of users? Well, there's something special about these devices. They're packed with these sensors. They're aware of their situation and state. They're aware of the context that they're being used in. For example, your application can know where the user is, potentially where they're headed. And then you can ask yourself, what's nearby? What might be useful for the user to know about? Your app obviously knows what time of day it is and what date it is. And the user may have granted permission to access their events and what's important to them coming up. There is, of course, the identity of the user, their patterns, their preferences, their habits. And then these devices also have motion sensors. And because they're worn on the body, we can transfer this raw motion information into activities. And we actually have APIs that are available to you as developers that can sense these simple activities that you can pattern match against. Things like walking, cycling, driving, and so on. These devices are connected, of course, and often to other nearby devices. So you can start to ask questions like, what is the phone doing right now? Is the TV being used? Maybe there's music streaming to the speaker. Maybe the thermostat knows something. And these are all signals that add into this context. And finally, there are additional sensors, some of them built into the wearable. I could get a spare. No, I'm back. OK. Is it me? I'll try and keep going. Thanks. Yeah, so there are nearby devices that can provide other information, perhaps like precise location from Bluetooth beacons. So the real interesting thing happens when we take the combined total of all of this sensor data and put it together into one single rich picture of the user's situation, the scenario that they're in right now. So as developers, we can look at this situation and we can ask ourselves the question, how can we present the user with useful information that will help them? And for you guys as developers, what you can do is define detailed contextual trigger conditions and have your app show up at precisely the right time based on those trigger conditions. So let's look at a practical example now. So first, we'll look at a typical interaction as it exists today. Let's say you're going for a run. You probably pull out your phone, then you launch a running app, maybe tap in some goals. You might decide to switch over to a music app, queue up that album that you had been listening to earlier, switch back to the running app, tap start so that you can get going, strap the phone onto your arm, and off you go. Fairly typical interaction that we're probably used to. Now we'll try and redesign this experience for wearables using context to drive the interaction. So in this case, assume you're using an Android Wear device. It's a pleasant Sunday afternoon. You're at the head of your running trail that maybe you run at most Sundays. You probably just stretch out, plug in your headphones, and start running. So based just on these simple inputs from our sensors, the things that we can detect, things like the time, the location, your habits, physical movement, even what the headphone jack is doing, it really looks like this person is going for a run right now. So why shouldn't we do the obvious thing and present them with helpful information? In this case, it would be something like start tracking their run, and perhaps also offer to pick up playing that album. So the user didn't have to do very much at all here. They just acted as they normally would, and the technology does the right thing automatically. It was like Hayes said, the world is the experience, and the technology just adapts to what the user is doing. So again, rather than asking the user to manually tell the device what they want to do and then have to manage state on an ongoing basis, on wearables, we're going to do something much simpler than that. We're going to do all the heavy lifting for them based on context and present them with just the right information at the right time. So that was a simple example. Next up, Alex is going to talk you through some more examples and also introduce you to some design tools that will help you apply this thinking to your own applications.
All right, so that was a lot of information, and this is a new form factor, so that means thinking about building entirely new types of software. But it also means a lot of opportunities to build breakthrough applications because this is a new form factor and we're just getting started. So first, let's summarize. Hayes talked about how the world is the experience, sunsets and puppies and these things that we care about more than having to interact with devices. And how do we achieve the world being the experience? Well, we achieve it by having the user be in the world more. And we can do that through micro-interactions so that you're more present and engaged in the real world, but you're also more connected virtually because you have more check-ins. It's just your engagement with the technology is shorter. How do we make those engagements shorter? How do we achieve micro-interactions? Well, the two core components, voice, as Bob talked about, and context, as Emmett talked about. So now you're thinking, OK, that sounds cool, but where do I actually start? I want to build an application. We've got this OS that's built around voice and context. But how do I translate my app? How do I build an entirely new app for this platform? And of course, it's good to start sketching. But at this stage, you're just looking at a blank piece of paper, and you're kind of lost. So I want you to consider two thought experiments to kind of ground your thinking in how to approach wearable applications. So the first one's about voice. Now imagine that you are your app. And the only way that the user can communicate with you is through voice. So as the app, you're sitting in a room. It's a very nice white room. And the only thing in the room is a pedestal, and there's this red telephone on it. And when the user needs something, that telephone's going to ring, and you're going to answer it, and it's the user, and they're going to say exactly what they need from the app. So what's the first thing that the user says when you pick up that phone? What's the range of calls that you're expecting to get throughout the day? How does the user phrase the request? And the great thing about building on top of Google's voice recognition system is that we're building out all of the capabilities. We're actually handling all of the transcription and natural language processing and grammars. And all you have to do is just subscribe to a particular intent. But then the question is, which intents do you want? So as we're building up the system, we really definitely want to hear from you about the applications you're trying to build and which voice intents you're interested in. So we can start working on those and getting those into the system so that your apps can subscribe to them. So you can go to this form, just fill out and tell us what you're interested in the voice recognition system being capable of. And we'll show some examples of what it can currently do. So the second thought experiment is about context. And as Emmett said, even faster than voice is the application being able to anticipate the information that you need. So for here, I want you to think about this moment where a surgeon reaches out their hand, and immediately, without ever having to look away, the tool that they need is placed in that hand. And what's interesting about context is contextual cards aren't meant to be surprises. Users are going to reach out their hand for your app at various times. They're going to adapt to the system as much as the system's adapting to them. And they're expecting the app to be there. So imagine that you're with the user and you have the app ready. And you're ready to give the user the app at any moment. When do you expect the user to reach their hand out? What's going on in that situation? What's the environment? And then as you think about that, you can think about how you can build the contextual trigger conditions so that the card is there on their device at just the right moment. So we're almost ready to start sketching our app, but we still have this blank piece of paper. And one thing that's really useful for sketching applications is, of course, stencils. This is a stencil that was made for Android phone applications, and it's really great. You have all the patterns, and you can quickly sketch out all of your screens. So then the question is, well, what does this stencil look like for wearable applications? So we started playing around with that, and we haven't actually built it, but here's a picture of what we think it would look like. So what's sort of interesting is, of course, voice, right? We're just opening with speech bubbles, where you can draw a speech bubble, sort of sketch what you expect the user to say. And then next we have context, all of the contextual trigger conditions that Emmett was talking about. And only then do we move on to then sketching the actual UI on the watch, the card that appears, or the screen that's a result of the voice action. So let's look at some examples of voice. The talk's been pretty high level, but I want to run through some very specific examples, a few apps that are actually already available. So imagine you're going furniture shopping, and you see a new couch that you're interested in, you want to remember. You can just say, OK, Google, take a note. And apps can subscribe to the take a note intent. So in this case, Evernote is the user's favorite note application, but it could be any number of note applications that the user likes to use. Say you're going for the run, back to Emmett's example. And as you're running, you're curious what your heart rate is. So you can just say, OK, Google, what's my heart rate? And if the device has the sensor, that'll be available just with a quick voice command. This is another intent that we currently support. Then at the end of the run, if you want to stop recording, you can just say, OK, Google, stop running. And apps can subscribe to that intent. So we have all of these various natural language processing grammars built up for all the different ways that users can say these things. But from the app side, all they have to think about is they're subscribing to stop a run or take a note or what the basic intents are. Let's look at some examples for context. There's a few really good ones on Glass that are already shipping. This is LinksFit. Developers actually in the room. They did an awesome job. It's all applaud LinksFit. It's so good. So how this works is it's going to use motion sensors to actually watch you do the workout. And it guides you by speaking to you and showing you quick little video clips. And it really works like a personal trainer would in real life in that it's giving you instructions and it's actually observing your motion. And this is great. I mean, it doesn't get more contextual than this. It's like actually you're recording each motion. Another example of context is Field Trip, where this shows you information about your surroundings. In this case, the user is interested in history, so they're seeing some historical information. This one's pretty crazy. It's 9450. It uses a special basketball that has sensors that can sense your shot style, and then gives you feedback on the shot on glass. This is also kind of a good example of the world being the experience, because really the experience here is you're shooting a basketball. But this is just giving you some additional data to help you have a better shot. Similar example with golf. This is Swing Byte, which connects to a sensor on your club. And this unlocks all sorts of really useful data as you're playing. In some ways, it's kind of like a caddy, but it's even more accurate than a caddy because it has really detailed information. So let's look at some examples on Wear. So imagine your friend has a Pinterest board of the best gummy candy in North America. And of course, you're going to subscribe to that. So you subscribed to it a long time ago. You've since forgotten. But as you're traveling and you're walking around, Pinterest fires, and it says, hey, one of the pins that you're interested in is actually in walking distance. You can go check it out, because it knew that that was something that you're interested in. And this is currently available. Another great application from Trulia. This one's really cool. So as you're going to open houses, when you're near the property, it's going to show information about the property. It gives you actions like you can call the agent. You can quickly favorite the property. And again, this is very much the world as the experience. It's kind of like you're right-clicking on the world. It's like the world has a contextual menu where you can just say, like, favorite this property, which I think this one's really cool. All right, so let's look at a few more hypothetical examples. So imagine you're at home. Your device detects that you're at home, gives you controls for your thermostat. Imagine you're going skiing and the conditions are pretty icy, but since you're inside the grounds of the ski resort, your device could just tell you which lifts are running, which trails have been groomed, all of the contextual information that you want right then. Imagine you're at the airport, and as you're scrolling through your cards, you see the airline that you're on is providing information on how many miles you've acquired and how you're doing. You're staying at a hotel, and the hotel chain recognizes that you're on one of their properties. They can give you quick access to actions like requesting a late checkout. Imagine you're at a conference. Social network could tell you, hey, here's some friends that you haven't actually seen in a long time, but they're also at the conference if you guys want to meet up. You're at a restaurant. Nutritional application could detect which restaurant chain you're in, quickly look up nutritional information for that chain, and provide suggestions of the healthiest items on the menu. Say you're getting the oil changed in your car. You could have an assistant application that recognizes that and just offers to set a reminder for another 6 months. You're at the zoo, and you have a watch that automatically knows when the penguins are going to be fed. Imagine if you're able to ask real-time location-based questions, and people using the service could choose if they want to respond. And these wouldn't be interruptive, but if you saw one come by as you're using the device and you felt like responding, you could help them out. So questions that you could otherwise never search for, you could use, like saying, are there any picnic tables free, and getting an answer to that. Imagine you're using a car sharing service, and as you approach the vehicle, you get a quick action to unlock the car. So what's sort of interesting about all those examples is that the UI wasn't actually that complicated. The UI is usually just a card or a button. And when you look at the stencil, there's not much of the stencil devoted to the UI. This isn't about sketching a variety of different UI widgets. What the stencil is about is the user and their world. It's about what the user is going to say. It's about what the contextual trigger conditions are. Even with our mockups, we were focused more on sort of the background of the scene than when the device came up. So what's really important when thinking about these wearable applications is thinking about the world and what the user needs. And we ran through a bunch of them, but this brings us back to our overall notion of the world being the experience. It's really being the thing that drives the use cases for these wearable applications. And the world's a big place, so there's really a tremendous amount of opportunity for really interesting applications built in this space by designers and developers. Google's crafting the infrastructure with APIs for voice and context that you guys can build on. And this is in the same spirit as our initial work on Google Now, but we're opening up the platform to the entire ecosystem for contextual cards and voice actions. And really, together, we'll be able to build things that are really far beyond anything that we could build on our own. So a quick announcement, which you may have heard in the last session. If you're watching this on video, check out Timothy's session, Wearable Computing at Google. Wear notifications are going to start appearing on Glass in the next few months, which will make life much easier for developers, because they can develop for both devices simultaneously. And this will get you access to pages, stacks, voice replies, and actions. And with that, we'd love to take your questions. Thank you. Any questions? Maybe not.
Microphones in the center if you want to step up to those. Give people a second.
Hi. I have a question about the Wear. By looking at the SDK, it doesn't allow you to modify the notifications that you can post from your phone APK. Is there a reason why the design has been in such a way that the developer doesn't fully control the layout of the notification? You have to actually build an APK for the Wear in order to design a layout that uses the full screen. You're sort of bound in that tiny square of the notification. What was the reasoning behind?
So the nice thing about developers using templates is then as new form factors come out, those notifications can be automatically adapted to the new form factor, which is, even for Wear, we have square and circular devices, right? So that's pretty useful. So it provides less work for the developer when you're using one of those templates, because you just know you're sort of guaranteed for all future form factors. But you can, of course, create an activity view and control every pixel if you want. Then it's just more overhead for testing on the new devices and making sure everything's working correctly.
Right. Is there a plan in the future where you would allow developers to completely custom design the layout of the notifications?
Yeah, that actually launched today. The Wear SDK lets you do activity views inside cards where you can do the full UI.
Awesome. Thank you.
No problem.
Hi, my name is Jonathan. I want to ask, when will we see some more sensors on the Android Wear devices? I mean, temperature, moisture, some more. I mean, the LG doesn't have a heart rate, and most of the really interesting applications would be around the more sensors.
Yeah, well, I think as people are seeing the types of apps that developers want to build and the ecosystem's growing, we're going to see a lot of innovation in this space. I mean, one of the great things about Wear is we're going to have lots of devices. So that will enable competition in the marketplace for people to add sensors and have really cool use cases.
Any known watches coming out with
I can't
multiple
pre-announce.
sensors?
I'm not going to pre-announce other watches, but
okay. Thanks.
Theoretically, yeah.
Thank you all for the presentation. So you've been mentioning all these things where smartwatches and smart glasses are similar, and how Android Wear is going to work with both glass and Wear. And so my question is exactly the opposite. Where do you see glass and smartwatches being totally different? What are the, and this is for any of you, what's the feature where a smartwatch makes sense but glass doesn't, and vice versa?
You want to take that, Bob?
Sure. I think as Timothy Jordan said in the last session, a lot of it does come down to the individual user, what people's preferences are. I think one thing I've found while working on wearable devices is they're much more like other things you wear, like shoes and socks and shirts and jackets and hats, and actually less like phones and tablets in a lot of ways, in that you might one day wear one, another day wear another, depending on what you plan to do that day. For example, myself, I love to wear the watch around my house. It frees me from my phone, which can be downstairs, and I can still get my notifications. But I love to wear glass when I'm cycling or when I'm playing with my 1.5-year-old son. It's the world's best baby camera. So I'll take one off, put one on, depending on what I want to do that day. I think that's probably the future of wearable technology is that sort of use case, very flexible, and people get to choose and customize for themselves.
Awesome, thank you.
Another thing to consider as an app developer is if the user has to maintain eye contact with something, then glass is definitely better. So like the basketball example works really well on glass, but I don't think you necessarily want to be looking down at your watch while playing basketball. So there's some significant sort of form factor differences to consider for your specific case.
My name's Julie Stanford, and I run a UX design agency called SliceBread, where we do a lot of interactive prototyping like the kind you showed. And we use a lot of HTML jQuery to do just quick Wizard of Oz prototypes. And I'm wondering if Android Wear is going to support doing that type of quick prototyping without having to go through creating a backend and or if there's just some quick way to do rapid prototyping on that platform.
Well, it should. It doesn't currently.
OK, but it will.
Yeah, well, I mean, it should in theory. Yeah, it's still pretty early. The team's been really focused on getting a product out before we've been able to do more robust things like helping prototypers and stuff.
OK, so you can't just like create something in HTML and quickly show it to see how it might work.
No, it doesn't. Okay. It doesn't have a rendering engine.
All right.
But I would say don't let that discourage you. Yeah. Strap a bicycle helmet to your head or a phone to your wrist.
I'm not discouraged.
We're all designers.
Yeah,
we actually did a bunch in HTML and JavaScript prototypes. And the real important thing is that you can just wear it and try it.
Sure.
In any way possible.
You could also just draw to a smaller area of a phone screen and have people.
Right.
Yeah. I mean, that stuff works okay.
Hi. Just a quick question. I'm just thinking about, on average, most people have like, 50 apps. And there's a lot of competing apps and a lot of competing information. So let's say, where should I eat tonight? Which card comes up? Something from Foursquare, something from Yelp. Or, where should I stay tonight? Does Airbnb give me a suggestion, or Hotel Tonight? I'm just wondering, how does Wearable kind of tackle that? Or, Android Wear?
So the first time you say it, if you have multiple apps installed or after you've installed a new application, the user has a menu of choices they can choose for the application at that moment. In the future, it's going to default to the one that you previously selected, but it gives you a moment to pause and choose one of the others, which is kind of nice for voice, because you can say a command, drop your arm, and it's just going to happen. Or you could say a command and then quickly pause it and say, no, I want to switch over to this other service.
Cool.
Also on the companion app, you can set which defaults are associated with everything.
And in terms of the passive cards and the ranking of the order, is that determined by Google in terms of what's most relevant to you as you kind of scroll through the different types of cards?
At the moment, it's determined by a number of signals that the developers are providing, priority levels. In the future, we're looking at ranking based off of how contextual things are. So it's kind of working hand in hand with the developers to understand what's important about their card and how it fits in.
Cool.
Hi, my name's Conrad, and I work at the University of Washington. I'm a grad student there, and there's a number of my colleagues are working on accessibility, and they're all really excited about wearables because they're adding like more input modalities for people that are blind or that can't hear, and it's all really exciting. And so I'm wondering, is your team working on any accessibility technologies with wearables? Like for instance, like you have a screen, and like you can put TalkBack, which is on Android phones, onto watches as well. Are you working on anything like that?
Yeah, I don't want to talk too much about what we're working on in the future, but I think something that is really exciting is, particularly with glass, like the voice feedback. And building natural voice interactions, of course, are incredibly accessible. And they also benefit everyone, just as the sidewalk ramps benefit everyone. So even if it's done initially for accessibility, it's super powerful to give everyone access to it.
And I think on the glass platform, we've seen most innovation for accessibility from third parties. A lot of it actually from academic sectors, people doing really innovative stuff. I think that from our point of view, we're trying to design more towards what I'd call universal access, which is how to make stuff that's as usable as possible for everybody. But a lot of these ideas transfer over to the accessibility space. And of course, there's some that don't and some custom work that needs to be done. But the developer community has been amazingly productive in that space so far with glass, and I expect to see more of that with Wear as the platform emerges.
All right, thank you.
Okay, I have a question regarding context. Is it possible to provide custom contexts? So, for example, if I can actually have an algorithm that determines whether I'm in a noisy room or in a quiet place, or any other type of custom context, is that something that I can actually use to trigger certain mechanisms in wearables?
Yeah, so from the user's point of view, we'd prefer to keep it really simple where they didn't need to do a lot of setting up of trigger conditions and so on just to have things to appear. But I think you might be asking from an app developer's point of view, and we would absolutely encourage you to use every single signal possible to really focus and target content to the users. So all of those examples that you specified, I think are great signals and really paint that picture of what the user is doing.
So I'm asking if I can actually do a custom context to create a trigger, a custom trigger.
Yeah, so it somewhat depends on the hardware being used. So like for microphone, that there's permissions surrounding that. Also there's battery implications. And the other aspect is we're trying to build systems that are pretty robust that everyone can benefit from. Like with activity detection, it's really hard to do machine learning on accelerometer data to figure out the difference between biking and driving. So by us providing that to all the developers, then they get all of that learning for free. But for the things that you can access, yeah, we totally encourage you guys to build your own models of context. It'll give you a leg up in the market against your competitors if you're more contextual.
Okay. And raw sensor data is available to you. For example, in the accelerometer case, like if you don't want to, you don't have to use those APIs.
If you have a better model, then
could that be triggered? I mean, I can't use that I can't use that to trigger anything with raw accelerometer data. Accelerometer data is, it's not. I can't use that to trigger something from the background, right?
Seems like maybe we can follow up afterward and talk in more depth.
Yeah. Generally, you can put a card into the stream whenever you feel that it's contextual.
We'll take just one more question. Thanks.
Well, this is crazy. You just stole my question, but I'll add a little bit more. You guys have been working on this space for a while now. Do you have any sort of like conceptual frameworks for thinking about multiplexing contextual data? You can often be overwhelmed by a particular signal or have a particular signal that is not represented as well. Is there any sort of more towards the theoretical side of like where to go to combine these things together?
It would be a really good problem for us to have, because like right now we're figuring out context and then matching that against all the available sources of information that have cards that can match. At the moment, Android Wear is just launching now, so we don't have a tremendous number of applications. But it would be a great problem for us to have, that suddenly there's too many contextual cards for your environment, and then we have to think about ranking. And then that's sort of fundamentally a search problem, so I think we're hopefully pretty well equipped to tackle it. I'm looking forward to that being something we can work on.
Okay, thanks. So go forth and give us that problem.
Yes, please.
Thanks, everyone.
Yeah, thanks very much, everybody.
Thank you.
Everything has a location, whether it be the photos you took, where you are, the places you like to hang out, where you bought that special gift, or even the last place you met your date. I'm Megan Boundy, Product Manager for the Google Maps mobile SDKs. Today I'm going to show you some cool ways to use Google Maps mobile SDKs to help you both bring these experiences alive and delight and engage your users. In this session, I'm focusing on the Google Maps Android API v2, but all of this functionality is available in the Google Maps SDK for iOS as well. This is great if you're looking for cross-platform consistency for your apps. When developers think of having a map in their app, they often think of something like this, a marker on a map. This is great for showing your location or marking out where you might want to meet someone. But did you know that you could add Street View to your app like this? Or make cool apps like Santa Tracker that follows Santa around the world as he delivers presents? Let's take a look. Our docs show you how to embed a Google map in an Android activity. Then it's easy to add markers to your map. You just use the add marker method and specify a few options to customize the marker. For example, you can set latitude and longitude, change the color of the marker. You can also set what shows up in the info window when the user taps the marker and the info window pops up. You may even want to use photos as your marker. Maybe you want to show where the photo was taken on a map and associate it with an event, rather than just showing a strip of photos in your app. Now that you've seen markers, let's take a look at Street View. Most excitingly, you can add Street View imagery to your apps. In this demo, you can see the split screen with the Street View imagery in the top half and the Google Map in the bottom half. By long pressing the marker and dragging, Street View imagery updates and shows you the location where you drag the marker to. So how do you do this? A very similar demo is available in the demo examples in the Google Maps for Android API v2 itself, so the code is all there. Here we've split the layout into two parts. It's one fragment for the Street View panorama and one fragment for the Google Map. You then set the same initial location for the map, the marker and the panorama, and we've given our marker a custom icon which is Pegman. When you drag the marker, you listen to a drag event from the marker and use the callback to position the location of the panorama. When the panorama change event occurs, the listener will give you the precise location of the panorama, and you can feed this back to the marker to update its position completely accurately. So what else can you do with Street View? You may want to add Street View to your store locator, see an area around a hotel, or view a museum or an aquarium. Street View also provides you with seamless access to Google's indoor Street View imagery. You can set the Street View panorama to be of imagery within the aquarium, or set it outside the aquarium and have your users navigate inside if they wish. Of course, you can do this for stores as well if the store has indoor business view imagery. This would be awesome if you're a store owner and you want your customers to see what's available inside to entice them to come and visit you. Okay, moving on. How can you make your users feel more immersed in their Maps experience? Have you tried out the Santa Tracker app and wondered why it felt so movie-like to follow Santa as he flies around the world? This is because we made the camera track Santa's location. Both the Google Maps mobile SDKs use a camera that lets you set the location of what you want to look at. You can animate the camera by using a camera update and calling the animate camera method. This is where you can also set the zoom level, the bearing, the tilt, and the duration of the animation. It's so effective. If you don't want to see any animation, you just call the Move Camera method instead, and it will move the map directly to that new location. We have a whole session dedicated to the Santa Tracker app at Google I/O 2014, so make sure to take a look. Now you know how to make your users feel more immersed in their Maps experience. How do you add things to the map and animate them? For example, how do those weather apps get the clouds coming in over the terrain map? Google Maps has several map types available, such as satellite, hybrid, or terrain. It's really easy to switch between map types. You just use the Set Map Type method on the map and specify the map type that you want. These apps are also using mostly transparent tile overlays with the clouds as the opaque features. Tile overlays allow you to specify particular tiles to be shown at a given set of coordinates. You should also specify which tiles can be shown at each zoom level. All you need to do is define a URL tile provider and supply that to the tile overlay options, then add it to the map. To make their clouds appear to be moving, the weather apps are swapping out multiple tile overlays periodically to make it appear animated. Talking about the weather, it may be time to go inside. There's also the ability to see indoor maps along with programmatic control of the indoor level of the building and the floor picker. You can find out which building is active by calling getFocusBuilding, and then find out the active level of that building by calling getActiveLevelIndex. This is great if you want to show custom markup for the active level, such as markers, polylines, tile overlays, and other shapes. You can also turn off our default level picker and implement your own by passing false to the method setIndoorLevelPickerEnabled, and then adding your own. Now we've seen all parts of the world via our map: indoor, outdoor, street view, a normal road map, and weather overlays. Who knew you could do so much with maps in your apps? To get started mapping up your own apps, go here for Android and here for iOS. And if you need any help, our support page lists the Stack Overflow tags that you need. So what are you waiting for? It's time to get out there and start mapping up your apps.
You started an online store and the customers are rolling in. Your website is functional art, your ad campaign's gone viral, and the shopping carts are filling up. Your products have universal appeal. And you notice, hey, I'm huge in Japan. You're getting lots of international traffic, but it's not converting into sales. Why is that? After examining your analytics data, you see a lot of items getting abandoned during checkout. Do your international users just have a shorter attention span? Or is there something suboptimal about the user experience that is frustrating their urge to consume? We're going to address these questions and elucidate some of the famous question marks that beget profit. Have you ever seen an address in Japan? Let's start with something easy for me as an American. Here's where I work in Los Angeles. But here's where Googlers work in Japan. Let's remove the language barrier for a second. As you might notice, we're not in Kansas anymore. The order of this address is almost completely reversed from Western conventions. But you're smart. You can handle this. You whip out some JavaScript and manipulate that DOM. After a careful reading of Wikipedia, you are pretty confident. You can deal with users coming from Japan, shuffle your address around to make sure they feel right at home. Remove any impediments that might prevent them from obtaining the latest in wearable tech for their pets. But wait a second. Every country does things a little differently. How many countries are there in the world? I don't know, a bunch. You're going to be up pretty late tonight, scouring the web for this sort of information for every country that likes cats. That's problem one. Now, here's problem two. Here's that address again, but this time it contains a typo. Can you spot it? I can't either. But users love typos, almost more than their cats. So you better figure out how to verify the address as it's being entered. Yo, my yo. Okay, I will end this rant. I hope you're convinced. Addresses are hard, and you just want to go shopping. But it's okay. Chrome's Request Autocomplete gives you all this and more for free. Request Autocomplete is a brand spanking new member of the HTML standard. And today, you can find it on Chrome for desktop, Chrome OS, Android, and iOS. And it's super easy to integrate into your site, which is nice. Request Autocomplete remembers your address, so in practice, most of the time you won't need to enter a new one, but when you do, here's what it looks like on your phone. It's native UI. So this is straightforward to use as an American. You can put in your name, my city, all that stuff. That's well and good, but here's the hard part: Russia. As you might have expected, the address fields look quite different from the United States. For example, you see the postal code and the city fields on top of the street address and the name fields. What about validation, you ask? No problem. Request Autocomplete can do that as well. Fantastic. Best of all, next time my address is ready and waiting for me. So, Chrome handles address input, data validation, and more while you focus on your product. Want to add Request Autocomplete to your site? Check it out here, or point your browser here. Easier internationalization is just one reason why Request Autocomplete rocks. The team is working hard to improve the checkout process for your users. Our goal is to help you maximize conversions and optimize the payments experience for the web, especially the mobile web, because let's face it, this resource is occupied. Until next time, I'm Ruslan Salamakin, and I'm huge in Japan.
Everything has a location, whether it be the photos you took, where you are, the places you like to hang out, where you bought that special gift, or even the last place you met your date. I'm Megan Boundy, Product Manager for the Google Maps mobile SDKs. Today I'm going to show you some cool ways to use Google Maps mobile SDKs to help you both bring these experiences alive and delight and engage your users. In this session, I'm focusing on the Google Maps Android API v2, but all of this functionality is available in the Google Maps SDK for iOS as well. This is great if you're looking for cross-platform consistency for your apps. When developers think of having a map in their app, they often think of something like this, a marker on a map. This is great for showing your location or marking out where you might want to meet someone. But did you know that you could add Street View to your app like this? Or make cool apps like Santa Tracker that follows Santa around the world as he delivers presents. Let's take a look. Our docs show you how to embed a Google map in an Android activity. Then it's easy to add markers to your map. You just use the Add Marker method and specify a few options to customize the marker. For example, you can set latitude and longitude, change the color of the marker. You can also set what shows up in the info window when the user taps the marker and the info window pops up. You may even want to use photos as your marker. Maybe you want to show where the photo was taken on a map and associate it with an event, rather than just showing a strip of photos in your app. Now that you've seen markers, let's take a look at Street View. Most excitingly, you can add Street View imagery to your apps. In this demo, you can see the split screen with the Street View imagery in the top half and the Google Map in the bottom half. By long pressing the marker and dragging, Street View imagery updates and shows you the location where you drag the marker to. So how do you do this? A very similar demo is available in the demo examples in the Google Maps for Android API v2 itself, so the code is all there. Here we've split the layout into two parts. It's one fragment for the Street View panorama and one fragment for the Google Map. You then set the same initial location for the map, the marker and the panorama, and we've given our marker a custom icon which is Pegman. When you drag the marker, you listen to a drag event from the marker and use the callback to position the location of the panorama. When the panorama change event occurs, the listener will give you the precise location of the panorama, and you can feed this back to the marker to update its position completely accurately. So what else can you do with Street View? You may want to add Street View to your store locator, see an area around a hotel, or view a museum or an aquarium. Street View also provides you with seamless access to Google's indoor Street View imagery. You can set the Street View panorama to be of imagery within the aquarium, or set it outside the aquarium and have your users navigate inside if they wish. Of course, you can do this for stores as well if the store has indoor business view imagery. This would be awesome if you're a store owner and you want your customers to see what's available inside to entice them to come and visit you. Okay, moving on. How can you make your users feel more immersed in their Maps experience? Have you tried out the Santa Tracker app and wondered why it felt so movie-like to follow Santa as he flies around the world? This is because we made the camera track Santa's location. Both the Google Maps mobile SDKs use a camera that lets you set the location of what you want to look at. You can animate the camera by using a camera update and calling the animate camera method. This is where you can also set the zoom level, the bearing, the tilt, and the duration of the animation. It's so effective. If you don't want to see any animation, you just call the move camera method instead, and it will move the map directly to that new location. We have a whole session dedicated to the Santa